My name is Andreas, and in this video, you'll build a tool where you can upload a full podcast and get short form clips out, ready to post on YouTube Shorts or TikTok. An AI model is used to transcribe the video and get the timestamps of all words said in the video. A large language model is then used to find the viral moments in the podcast, such as questions and stories, and output those as JSON. It'll be constrained to find longer clips under a minute. Another AI model is then used for active speaker detection to crop the clip to the center of the face. This new clip is then rendered with GPU acceleration. Every service in the video is free, so you don't have to pay anything to follow along. The project is heavy on background processing, so you'll set up a queue to manage user load. The queue is configured to only let users process a single podcast at a time. In the meantime, new podcasts are queued. And we can also see the status of each queue item and the individual steps in the function that the queue triggers. Serverless GPUs are used for heavy backend processing, such as AI inference and video rendering. We'll set up a FastAPI endpoint for processing the podcasts, and we can see the status of each request in the Modal dashboard. Here, for example, we log the timestamps of the viral moments identified. The user starts with 10 credits and spend a credit per clip created. The user can then buy new credits from one of 3 packs. We'll set up Stripe for handling payments such that they are taken to the checkout page whenever they click buy. We then add the credits to the user's account whenever we receive the Stripe webhook after they bought something. In this example, we just purchased 150 credits, which are then added to our accounts. In the Stripe dashboard, you can browse around to see the payments made by your users and all of your customers. You'll create a product with 3 prices, one for each pack. These then correspond to the 3 packs that the user can buy. We'll then build out a simple authentication system where the user is able to sign up and also sign in. We'll then add some validation to both the email and the password, both on client and on server side. After signing up, the user is taken to the dashboard. The entire app, including the backend, frontend, and the queue, will be deployed to production, so you'll know how to deploy the SaaS fully. We'll cover all kinds of relevant theory, for example how the video is cropped, queues, and also the Stripe flow. We will also take a look at how we can offload fetches to the Inngest platform to bypass Vercel's maximum duration for serverless functions. The project will be built using Python, FastAPI, Next.js, React, Tailwind Shadcn, Modal, Inngest, and Stripe, and also many other exciting technologies. So let's get started with this video. Let's start by going through how we can create these clips. So the basic flow of the system is that a user can upload a full podcast, and then this podcast goes into an S3 bucket. When the upload has finished, we'll put an item into a queue with the S3 key to the original video upload, and then we'll queue the video processing for that specific upload. When the queue then determines that that video is ready to be processed, a backend endpoint will be called with the S3 key to the original upload because that is stored inside the queue item. And then the backend will then download the video from S3 and then create the clips. So clips are created from the video, uploaded back up to the same S3 folder where this video up here is also within. And after the backend has created the clips, the frontend can now scan the same S3 folder for new clips and then show the user the new clips that were generated. So on the web page, the user uploads a video. This is uploaded to an S3 bucket. The S3 key is the only thing you'll need to create clips. The backend is called with the S3 key as the only parameter. And then the following steps then happens in our backend. So what happens down here is what happens in this step right there. So the first thing we'll do in our backend is we'll authenticate the request with a bearer token. So this is just to verify that we are actually the ones calling the API. This will prevent abuse of our backend if anyone should get a hold of the endpoint URL, if it's just freely open for everyone to use. And that shouldn't really be the case. So after authenticating our request, we can then go ahead and download the video from S3. So we'll create an IAM user with S3 permissions to upload, download, and also list S3 items. So the IAM user in AWS will need permissions to upload the video for the first step, to download the video from in this step right here, whenever you need to download the video to process it, and also to list the S3 items whenever we need to scan the S3 folder for new clips, and then store those clips S3 keys in the database and show them to the user. So when processing this video, we'll download down the video from the S3 bucket and then do some processing to it. So there will be some temporary files involved, such as files generated by libraries we'll use that will track the phases. So all temporary phases created and used in the endpoint to generate videos are put in a folder with a unique ID. This means that when clips has been generated and uploaded to S3, then this folder can be deleted again to reclaim the space. This folder name will then be a unique UUID. So for example, in our Docker container, which we run in the cloud to do this, we'll have a folder called temp in the system. Inside temp, we'll have a specific folder with a UUID for that specific video. then all the temporary files will be put right here. This also means that whenever we download the file down, so the original video file, it'll also be downloaded to this path right here. So each video that is processed will then have this unique UUID, which we can use to find its temporary files whenever we work with it. So the next step is going to be to transcribe the video. So up here we downloaded the video from an S3 bucket, and now we would like to transcribe it. So since we have the video downloaded, so the video file, we'll be able to use the FFmpeg tool to extract the audio from the video. Then we can use a GitHub repository called m-bain/whisperX. We can use this to go ahead and transcribe the video. And what we then want out of this entire step is a data structure in the following structure. So we would like an array of different words along with each word's start and also end timestamp in the video. And then for the next step, that is going to be identifying the viral moments in the video. So now we have the full transcript of the video, and then we can use a large language model to actually read through the transcript and identify the viral moments, such that you don't have to do this manually, obviously. So we're going to use Gemini 2.5 as the LLM, and instead of hosting an LLM ourselves, we'll just go ahead and call an external API because there are so many free LLM APIs. So we'll use Gemini 2.5, which you can use for free from Google. It has a massive context window, so we can pass in a full transcript, and they also have very high limits for how many requests you can do per minute and how many tokens you can pass into it for free. So the prompt we're going to send to this LLM for identifying the viral moments is going to be something like find viral moments in this transcript and output these as JSON. And then of course it'll be way more in depth, such as what JSON structure it should output. And also we'll pass in a bunch of criteria for what a viral moment even is and how long these different clips should be. And then along with this system prompt right here, or just this prompt, we'll pass in the entire transcript from up here. So we pass in the word, the start and the end timestamps for each word. This means that when it does identify viral moments, it'll also know when these viral moments starts and also end. And the output for this LLM will then be some output, which is going to be JSON but in text. So we'll use Python to just pass this output as JSON so we can get it as structured data. So the output we'll end up with in this step is going to be the timestamps of viral moments in the original video. So next we can go ahead and create clips from these timestamps. So we'll loop through all of these identified moments. So if it's a long podcast, it'll obviously identify more moments. And if it is a short podcast, it might only identify one moment or two moments. So for each clip found by the LLM, so for each viral moment found by the LLM, we'll extract the part of the original video between the start and the end timestamps that are then identified by the LLM. We can then run active speaker detection with the LR-ASD repository from GitHub. So what this repo will do is that it'll find the speaking phases for each frame in the video, along with their position and a score for how likely the face is to be speaking. So if there are two phases speaking in the video, for example, two faces in the video and one is speaking and another one is silent, then the face that is speaking will have a higher score than the face that is not speaking. And with this information, we can then crop to the face that is speaking and then leave out the face that is not speaking. So after having gotten this information, we can go ahead and create the vertical video, which is what is going to be the clip itself. So in creating the vertical video, we'll need to crop the video to a mobile format. Because whenever you watch a video on a desktop computer, for example, it is going to look like this. But we would like the video to fit on a mobile screen so it looks better for short form content platforms. So we'll take the normal YouTube aspect ratio, which is wider than it is tall, and then we'll turn it into a mobile friendly aspect ratio, which is going to be 1920 by 1080. So the problem we'll need to solve to do this is going to be to figure out where we need to crop the video. So right now we have a bunch of space we can crop, but we really want to crop it to a specific speaking person. So down here, we'll find out the X and Y coordinates of this specific speaking person, and we'll get this information from the LR-ASD repository up here whenever we run that script on a video. And this will then give us the X and Y position of the faces that are speaking in the video, and we can then use that to crop to that specific face and then leave out some buffer on the left and the right corresponding to the width, half the width of the aspect ratio we desire up here. So if this person is speaking and this person is not speaking, then we'll crop to the speaking person and then we'll cut off the rest of the video and leave that out. So let's just go through how we can do that practically. So the output of the LR-ASD library up here is going to be some tracks, for example. So step 1 is going to be looping through these tracks. So a track is a sequence of detections of the same face across consecutive frames. So each track will contain the following: which frames the face appears in, also the X and the Y position of that face along with the size of the face, and then also other properties of the face for each frame, as well as a score indicating how likely it is that that specific face is speaking in each frame. So this actually means we can loop over each frame in the video, and then we can find out which faces are in that specific frame and also the score for how likely it is to be speaking. So this makes it pretty easy for us to actually crop to those speaking faces. So when looping through these tracks, we will average the speaker score over a window of 30 different frames for smoothness. So the reason we're doing this is that by averaging the scores, so how likely the face is to be speaking over this window of 30 frames, we'll get a more stable and less jittery estimate of whether the person is speaking at that moment. So this makes the decision about which face to focus on in the video less sensitive to brief, random changes in the model's output, and this will then result in a smoother and more visually pleasant video where the focus doesn't jump around unnecessarily. So if we hop up to this example right here, let's say that this person is speaking for 10 frames, for example. So in theory, the AI model from this repository up here should then say that this face is speaking by giving it the highest score for all 10 consecutive frames. But if the AI model messes up and then says that this face right here is speaking in frame 5, for example, and then this face is speaking in frame 1 to 4, and then also frame 6 to 10, this means that we'll have a quick jump from this face to this face whenever we crop over here. And that is what I mean by jittery, so the video kind of flickers between the different faces because the model messes up in its predictions. So to avoid this, we'll then average out the speaker scores across these windows of 30 frames, so we don't get this jittery motion of jumping between different faces whenever we crop the video. And then the output of step 1 right here is going to be a list of frames, and then for each frame we'll then have each face that is detected within that frame along with the score for how likely it is for that face to be speaking, and then also the X and the Y coordinates for those specific faces. So now that we have the information about what face to crop to, we can go ahead and actually create the new video. So we'll write a new video with the OpenCV library. So we'll create a new CV2 video writer, and then we'll use that to write the video. So a video consists of frames, so we'll create a new video by looping through the existing frames and then cropping each of those existing frames to the video faces most likely to be speaking within that frame. So it looks something like this. For each frame in the uncropped clip, so in the original video, we'll get the faces and their scores found for that specific frame that we are currently in. And then from that list of faces, we'll take the face with the highest score from that list. So either we get one face out, we can also get 0 faces out if there are 0 faces speaking in the video. So if the frame contains a speaking face, then we'll render the frame in so-called crop mode. If the frame does not contain a speaking face, then we'll render the frame in a so-called resize mode. And I'll go through these just down below. But after rendering out the full video, we'll then combine the audio from the original video with the new written video with the cropped frames, because the new written video, it only contains the frames, so no audio. So we'll have to manually overlay the audio with the new video. So now we can just go through what resize mode and crop mode actually means. So there are 2 different cases. In the crop mode case, we do have speakers in the video which we can crop the video to. So let's say we have a speaking face right here, then we'll crop the video to that person. If there is only one person in the video, we'll also crop that video to that single person in the video. But let's say we have a video with no speakers, for example, or a video where there are no speakers shown momentarily. Well, in that case, we'll take the entire video and then resize it down so it fits within the width of the screen. And then we'll put some blurry parts over and also under that video. So we'll use the original video as the background in the blurred parts, so it isn't just black down here, both there and also there. And then we'll resize the video as well and then overlay that over the blurred part, so the entire video frame or the entire frame fits within the vertical video as well. This means you can see some blurred part in the bottom and also in the top. Then you can see the video that has been resized to play right here in the middle. And obviously this isn't optimal compared to the crop mode over here where it looks way better. But if there is, for example, a couple of seconds where we don't really see any people in the video we can crop to, then it might be necessary to do this approach or to take this approach, since we don't really know where to crop the video to. You could also just crop to the center of the video, but let's say something is happening out on the right in the video and then you can't really see that anymore. So this is just one possible solution to the problem of not having any speakers in the videos to crop to. You can take any approach you would like to, but this is just the one I'm going to go ahead and do. So to hop back up to this for each clip found by the LLM flowchart up here, we can just continue that. So going down, we created the vertical video now, and then after creating this vertical video for that specific clip, we can then go ahead and add subtitles to the video. So we did take out the transcription for the video in the start of the flowchart. So what we can do is that we can show 5 words at a time on the screen as the subtitles for the video. So we'll need to group words into chunks of 5 from the transcript, and then we can use an ASS subtitle format that allows us to style the actual subtitles with the font we would like, for example, and also other styling properties. So after creating the subtitles, we can then burn the subtitles into the video with FFmpeg as well. And then we have the finished clip, which we can then upload to an S3 bucket. So that is going to be the basics behind how we can create these kinds of videos and then also put them into an S3 bucket so that the user can actually watch them later on. So let's go ahead and talk about how we can do this from an infrastructure perspective as well. So we're going to use a queue system for the video processing, as I explained over here, where the video processing is queued. So we're going to use Inngest as our queue system. So let's just go through the flow of how it works whenever a user uploads a video to an S3 bucket. So first, a video is uploaded to an S3 bucket whenever the user uploads a video. This will then insert an event into a queue that is managed by Inngest. And each message in this queue is going to contain an S3 key of the original video we want to process. And whenever an event is then consumed or sent to processing down here, it'll then trigger an ingest function where we can define some steps that should happen whenever a video should be processed. So these steps includes, for example, calling our backend to actually process the video, deducting credits from the user's accounts, saving the credit clips S3 paths in the database, and also setting the video statuses to processing, processed, no credits, etc. So the first step is going to be calling the backend to actually go ahead and process the video. So this Modal backend endpoint is going to pull the uploaded video down from S3 and then create the clips and upload the clips back to S3. And then back here in the ingest function, we can then save those created clips S3 paths in the database. So we now know the new S3 keys. So this ingest function is going to be in our Next.js backend, and this Modal backend is then going to be a Python backend of itself. So our ingest function is going to call our backend through a FastAPI endpoint to process the video. And then because we are doing all of this with a queue system instead of just calling the Modal backend directly from the Next.js server action that also handles the video uploading, it will mean that all of this will happen asynchronously in the background instead of synchronously whenever the video is uploaded. This means we can play around with stuff such as limiting concurrency, rate limiting the user, and also throttling the user. So one thing we'll do specifically is that we'll limit the concurrency of the events processed to 1, meaning only one event can be processed at a time per user. So for example, if a user uploads 2 videos right after each other, then it'll finish processing one video, and then only after doing that, it'll start processing the next video. If you then set concurrency to 2, it would be able to process those 2 at the same time, but if you then upload 3 videos in a row, then it would wait with processing the 3rd video until the 2 first videos has been processed. So when using an ingest queue, we decouple the uploading and also the processing steps. So we separate those so users don't have to wait for the processing to finish. And then we can of course also throttle or scale the system based on the load, so we can prevent overload of the system. So let's say we don't want to make a lot of requests to this endpoint right here, so we don't overload it in some way. Well, then we can just throttle our system to prevent that. And all of these different steps up here, such as calling the backend, deducting the credits from the user, etc., are also each tracked and monitored, so we can debug those and analyze them more easily. And if any of these steps should fail, they will also independently retry to make sure that we actually fulfill the entire, that we actually run through the entire function instead of having it fail midway through because something failed. So because it might take 5 to 10 minutes for a video to process, it would be kind of a shame if the user had to wait for the Modal backend rendering process to finish before the video would actually be processed. So this should really happen in the background. That is kind of the reason we're using a queue in the first place. So the alternative to using an ingest queue up here would be something like an AWS simple queue system, so SQS. So you can try it out if you don't want to be dependent on any development tools. I have used it before actually when building this exact tool right here, so an AI podcast clipping SaaS. And in my personal experience, so this is only anecdotal, using a dev tool like Inngest allows me to build queues way faster and simpler. So when I was building my SaaS, it was pretty much about speed, so people had things they wanted me to fix. So getting things up and running and then fixing bugs as fast as possible was really important. So I would love to have had a development tool like Inngest to actually help me implement these queues faster. So some of the benefits we get from using Inngest is that we can use a local development service that will host a queue for us while we develop. So instead of having to create an SQS queue and then test with that while we develop, we can just run this locally with an npm command. So this will allow us to build very fast and then also deploy this queue whenever we need to production. We then also do not need to create and configure these queues like we do in SQS. So I would encourage you to try and set up a queue with SQS in AWS just to see how many of the configuration options you aren't really sure what does, because it did take a while for me to understand all the configuration options and then have it be set up correctly. So there is a bunch of customizability with these regular cloud services like SQS, for example. So there's so much more overhead when configuring these compared to using a development tool. And when building these SaaS products, it's really important to be able to just get things up and running as quick as possible. So it really helps using development tools such as queue tools like Inngest provides. Cool. So let's just go through this Inngest function. So Inngest provides both the queue right here. So the queue is what stores the elements the videos that we will need to process, or at least information about them. Then when each of these queue items should then be processed, the Inngest queue will then trigger an Inngest function, which will run some logic to actually process these videos. So what will happen whenever a queue item is consumed? Well, first inside this Inngest function, we'll get the user credits. Then we'll check if the user has 0 or more credits. If the user has 0 credits, then we'll set the video status to no credits in the database, and this will then be shown to the user in the dashboard. Then we'll stop the execution of this function right here and not do anything further. If the user does have more than 0 credits, we'll then set the video status to processing in the database, so the user will be able to refresh the dashboard, for example, and see the video being processed. We can then also call the endpoint that processes the video, so that is the endpoint right here. After calling that endpoint and it finishes processing the videos, we can then list the video files. We can then list the video files in the S3 bucket folder for that video that was processed. So this original video up here that was uploaded was put in a specific S3 folder inside the S3 buckets, and the clips that were created is also going to be put within this folder. So we can just check this folder if there are any additional clips added to that, and then for each of those generated clips found, we'll then add those S3 keys in the database. And next, we'll then also deduct credits from the user's account. So for each clip found, we'll deduct 1 credit from the user's account. And lastly, we'll then set the video status to processed in the database and then stop executing this function. So that is going to be the flow of what happens whenever an ingest event is going to be consumed from the queue. Now we can then take a look at how we are going to actually run this Modal backend right here. So going over to this section, we're going to run our program on serverless GPUs. So our queue is going to be run with Inngest, and our frontend is going to be in Next.js, and then the Inngest will also be set up as a part of the Next.js project, but the actual logic which we went through over here for creating the clips will be part of a Python script that will run on serverless GPUs, because we'll run a couple of different AI models down here. We'll run this one, for example, and also the Transcription AI model, so we'll need some serverless GPUs to be able to power those. And we'll then expose this functionality through a FastAPI endpoint, which we can call from a Next.js application. So this Python backend over here, which will host on Modal, is going to be run on serverless GPUs. So the GPUs are going to be used to speed up the AI inference for the AI models which will run, and also the video rendering itself, which we can speed up with GPUs as well. So you'll be able to get $30 per month for free on Modal, so you can just follow along without having to worry about GPU costs. So that is pretty nice for you. So our backend will of course also have to be developed in a serverless way. So we'll develop for the cloud instead of having to try to get it to work locally. That is something we can do with Modal, so that is pretty nice. So when we develop, we code the program, then we can run a Modal run command in the terminal. This will then push the code to Modal, and Modal will then automatically build a Docker image for us, and then run this program on the GPUs for us and return the result back to our computer. So instead of us having to, like we do down here with normal EC2 instances, having to build the Docker image locally, push the Docker image, and then store the Docker image in an ECR registry, and then pull that down to an EC2 instance and then run the program, this is a lot of overhead. We can just go ahead and run Modal run, and then it'll handle all of these processes for us and just do that automatically and return the result. So this lets us just develop for the cloud locally instead of having to try to get it to work locally before even trying to push it to the cloud. So it's a very nice to work with locally, and also when having to deploy the endpoint, it's very nice. So it lets us deploy it pretty easily as well. So whenever we run this endpoint, we know that it works, or whenever we run this code, we know that it does work in the cloud. So when we're ready to deploy it to production, we can just run Modal deploy, and then we deploy our endpoint basically. So that is pretty nice. We also pay per second of usage instead of paying for the uptime of the EC2 instance like we would do on AWS. And we also get access to some pretty high-end GPUs that are easily changeable. So with an EC2 instance down here, you would need to pick an instance with a specific GPU and then pay for the uptime for that instance. But if you want an H100 graphics card, for example, you would have to pay like $98 per hour for that instance, and you would be able to get a minimum of 8 graphics cards, but you probably only need 1. So it is pretty hard to get access to high-end GPUs, so it's not very accessible to normal people to pay that much money for GPU if they just want to play around with a program like this one we're building. And then I already went over this part where the Docker container is automatically built by Modal, as I said right here. That lets us just skip all of this overhead because it's really a time consumer having to build these Docker images, push them to ECR, pull them down to EC2, boot up the machine, etc. So if we compare this new approach which we're going to use to just using EC2 instances, for EC2 we would have to pay per hour of instance uptime instead of usage. So we would have this overhead of building the Docker images, pulling them down, installing Docker for example, and then also shutting down the instances. It would cost way more because there isn't really a free tier for any GPU instances on AWS. The main benefit of using EC2 would be that we would have 0 cold starts because the machine is always running, and that is because we do pay for the instance uptime, but the cold start is only going to be like 3 seconds on Modal anyways, so that is going to be pretty negligible, especially because it is running as a background job in a queue right here and doesn't depend on like immediate feedback to the user. So that is how we're going to build and deploy our backend on serverless GPUs. So let's just hop over to the next part, which is how we're going to handle the purchase flow. So we're going to use Stripe for our purchasing flow, which is just a platform for managing payments and letting users pay basically. So whenever a user signs up in our system as a user, we'll sign up the users in Stripe as well as a customer. This way we have a user both in our own database and also in Stripe. So we'll then have a custom ID returned back to us from Stripe whenever we create them as customers. And this custom ID will then be stored in the database as a column for each user. So whenever a user then buys something, the user will then click a buy button when being logged in. And then we can get their custom ID from our database because we did sign them up as Stripe customers as well. And then we can use that custom ID to create a checkout session by calling the Stripe API right here. The Stripe API will then return a session ID, which we can use to create a session URL. We can then redirect the user to this session URL, which is going to be the billing page you see whenever you click a buy button on a website, for example. When the user then fills out his information and then buys something on this checkout URL, he'll then complete the purchase. This will be registered in the Stripe API, and Stripe will then send a webhook event back to our Next.js backend containing all the information about the purchase that the user just made. This will then, of course, also include some information about the order lines in this user purchase. And we can then extract the IDs of the products that the user bought from the purchase and match these price IDs up with the products we have created in Stripe. So if the user bought a price ID that corresponds to a product that should give him 100 credits, we'll then give the user 100 credits in the database. So we'll update the credits based on the price ID in the database. And then whenever the user refreshes the page, or this should even happen automatically, then we'll just show the new amount of credits in the dashboard because it has been updated in the database. So this right here is going to be the flow for how the user can purchase credits. This won't happen recurrently. The user will be able to buy credits as a one-time thing for this SaaS specifically. But you can also set this up to be a recurring model where the user purchases a plan, then it deducts some amount from his credit card every month, and then adds maybe 100 credits to his account every month, so the service just keeps running, for example. Before hopping into the code, let me just talk about the sponsors of this video. So as you might have guessed, Inngest and Modal are the two companies that sponsor this video. And I personally reached out to both of these companies to cover the needs that we'll need for this video. So in any case, when you build a program like this, you're going to need some kind of queue and also some kind of cloud compute. So whether this is Inngest, SQS, Modal, or EC2, all depends on your preferences. But for my preferences, I prefer these companies instead of just using the raw cloud services. So by having sponsors for my videos, I can use the tools that I really like and I can get paid for what I do. And I can also teach you to use the tools that I would think is probably the best for this task. And you can follow along for free by using the free credits offered by, for example, Modal and also Inngest, where you don't have to pay for the usage up until a certain point. So I really see it as a win-win for both me and you. Now I've included 2 links in the description for these 2 companies if you want to check out the tools which we'll use in the video. Okay, so I just opened up Visual Studio Code and we'll just set up the project. So first I'll go to File, Open Folder, then I'll hop into my Documents and then my repositories, and in here I'll create a new folder called AI Podcast Clipper and say Create. Then I'll open up that folder. In here I'll just create another folder as well, AI Podcast Clipper Backend. I'll just save that, and then I would like to hop into that specific folder. So I'll say Open Folder, and then just find the AI Podcast Clipper, the backend, and say Open. So now we're inside the folder which we just created. Then I would like to download 2 YouTube videos which we can use for our video to test out our tool. So first I'll just hop over to YouTube. In here I would like to search for podcast. Then what I'll do is say filters, and then I'll say Creative Commons. This means that we are able to use them. I would like to use this podcast right here. So I'll just open that up in a new URL. And then I think I would like to also use another one. So let me just scroll down and see if we can find another one. And I would like to use this one right here. So what I'll do is I'll just open that up in a new tab as well. So now we have these 2 YouTube videos. So I'll just take the first one and take the URL, hop into right here, and then I'll say YouTube download.py. Then I'll say URL 1 is equal to the first URL, and I'll take the second URL and paste that in as well. So this will just be URL 2 right here. And the reason I wanted it to be Creative Commons is because if I hop down here and then just click this Creative Commons badge, we see that we are able to use this video. So by marking your original content with Creative Commons license, you're granting the entire YouTube community right to reuse and edit that video. This means we can download the video and actually do some tests with it. Cool. So now we've searched for GitHub and then PyTube fix. This should let us download the YouTube video. So I'll just take this and then just install that library over here. First thing I would like to do is just open up a new Python environment. So what I'll do is press Shift Control P, and then I can search for create Python environment like this. And then if you do not see that, you should be able to just make sure you have the same extensions for Python as me. So I use this one, AutoPip 8, iSort, Pylance, Python, Python debugger, and this one you do not need. Cool. So I would like to press the same again, create environment, venv, and then I'll pick Python 3.12. And then if you do not have Python, you should go ahead and install it. So you can search for Python, download. And then if you hop in here, you should be able to download Python. I would just recommend you installing 3.12 for this video because that is what we're going to need. So you can go ahead and find 3.12 and then download that version to your computer. Cool. After doing that, you should copy this command. And then now the environment is selected. So we can go ahead and open up a new terminal, paste in the pip install PyTube fix, and then we can just create the code for downloading these videos into our repository. So what I would like to do is say from PyTube fix import YouTube, and I would like to say from PyTube fix .cli, I would like to import on progress like this, and then down here I can say YouTube is equal to YouTube, and I'll paste in URL 1, and on progress callback I'll set to, has to be on progress callback. I'll just set to on progress, and then I can say print YouTube.title, and we can say ys is equal to youtube.streams.get highest resolution. So we'd like the version of the video with the highest resolution. So hopping in here, we can see that we're able to select multiple different resolutions. We'll just take the one with the highest one. So we'll call this function and then say YouTube stream.download. And then we should be able to to start the script by saying Python YouTube download.py. And this should then start the script. So it printed out the title and now the video is downloading. And then I'll come back as soon as the video has downloaded to my computer. So the video just finished downloading. So if we click the video over here, it should load up in just a second. And then we see we have a 2-hour long video. We can probably press reveal and finder and then actually see the video if you would like to. It doesn't really matter that much right now. We just need to know that we have the video down. So that was the first video, and then we can just go ahead and do the same just for the second one. So we have 2 videos to test on. So I'll put in the URL too, run the same script again, and that should download this other video right here. And I'll just come back when that is done as well. Now we have both videos downloaded down now, and both of these are around 1 to 2 hours. This one is 1.2 hours, so that is also pretty long. So I would like a shorter version of one of these videos that we can use to test on. So what I would like to use to cut one part of these videos is FFmpeg. So if you search for FFmpeg and then download, you should be able to download FFmpeg to your computer. This is just what we'll use to cut the video into a smaller piece. So it isn't really loading right now. Doesn't really matter that much, but you can go ahead and install FFmpeg, or you can use another way, but I just want a shorter version. So I'll hop into my terminal, then I'll just call this mi6, and I'll call this therapy. And then I'll say FFmpeg, and then I'll say -start, and then I'll put in the start timestamps. I'll just put in 15 minutes, and then I'll say cut to, and then I'll put in 20. So I'll cut out 5 minutes of the mi6 video. So I'll say input is going to be mi6.mp4, and I'll say -c copy, and then I can say mi6, and then I can say 5 minutes.mp4, and then just run that. And I think it just made a little mistake. It has to be mp4, not mpy. So now if I open up this one, mi6 5 minutes, now we have and something is not right here. It should be 5 minutes, not 20 minutes. So if I just press up once, I can see that we have an error in the command. So we need to say 2 and not just t. So I'll just remove this file, and then just press enter again. If I then open it up, we should be able to see a video that is only 5 minutes long. So I'll just wait for this to open up in a second. And there it is. So now we see the video that is only 5 minutes long. So that is way better. Cool. So now we have a video to test on. And then I would like to also just create one that is a little bit longer. So I'll call this 15 to, let's say, 45 minutes. And then this output will then be mi6 30 minutes. Just so we have a half an hour long video as well to test on. So that should do it for some testing videos. We have 2 long videos, 1 5-er and 1 30-minute video. Now we should be able to move on with the actual program. So first I'll just hop into GitHub and just search for LR-ASD. So I'll search LR-ASD and then GitHub in my browser. Pull this up. So this is what we're going to use for active speaker detection. Then what we'll be able to do is run this Columbia test command right here, which will then output some tracks which we can be able to use to find the active speakers. So it's a pretty recent repository, as you can see, and it also performs really well and is super lightweight. So we'll say code and click this button right here, hop into our backend again, and then we'll say git clone and just clone this repository down. But instead of calling it LR-ASD, we'll call it ASD, just like this, for active speaker detection. Then I would like to create a main.py file. So I'll say main.py. In here we can define everything that needs to happen, such as our endpoints and the setup for Modal, etc. And then we will also need a requirements.txt file. This will define all of the requirements, all of the pip libraries which we'll use, and that should be installed into the Modal Docker image. So we can start by defining the requirements that I know that we're going to need. So some of these are required by ASD. So for example, if we hop into any of these files, we can see that pandas, tqdm, numpy, etc. is going to be needed, as well as torch. So I have a list of these that should already be installed, which we're going to use both for our own program, but also what is needed by ASD. So just follow along here, and then I'll explain what each is used for. So the first one is going to be tqdm. This is going to be progress bars for loops. So for example, when we download something or whenever we render a video, we're also going to need torch, OpenCV Python. So PyTorch, this is required to run deep learning models, and OpenCV Python is going to be image and video processing, so frame extraction, etc. We are going to need FFMPEGCV. This is going to be video writings with the GPU acceleration. And then we can also import NumPy. This is just numerical operations and array handling. We're going to need Python speech features. This is going to be audio feature extraction. We're going to need SciPy. So this is going to be for some scientific computing. It's not something that we'll directly use. Then we can also import scene detect. This is also used by ASD to detect specific scenes where specific users or specific faces are within. And then there's also another machine learning utility library called scikit-learn. We'll also download Google Down. So this is for pulling or downloading files from Google Drive, such as model weights. So ASD right here, active speaker detection, LR-ASD, will automatically pull down the model files with G down. So that's why we're going to need it. We'll need Torch Vision. Torch Vision is just some computer vision utilities for PyTorch up here. We'll then need Pandas. So Pandas is a data manipulation and analysis. So we're going to need transformers as well. So transformers is going to be Hugging Face transformers. We might also need Accelerate to run some of our AI models. So this is for multi-GPU or multi-device training or inference for models. We're going to need datasets. So this is the Hugging Face dataset library. Then we're going to need Google Generative AI. So this is just an API client for the Gemini large language model. We'll need PySubs too. This is just to be able to create subtitle files. And then we'll need Bodo-free. This is to be able to download S3 files and upload them. So it's just an AWS SDK for Python basically. We'll then need FastAPI, and I'll just say standard here. So what FastAPI is this web API which we'll use to expose the endpoint. So we'll need this as well. And then lastly, I'll install whisperX. So whisperX is just a speech to text and also alignment. So this is just an AI model. So if I hop into Google, search for m-bain, and then whisperX, this is what we'll use for the speech recognition. So this is going to be speech to text, so transcription. So this is just a library which we can install. We can pip install whisperX. And then what we'll be able to do is just give it an audio file, and then we can get out the actual transcription. And there's a full guide down here to how we use it within Python. So we'll of course use that because it is super fast for transcription. So I'll save this file, and now we should be ready to go ahead and use the libraries. So first I'll say pip install -r for requirements, and then I'll put in the requirements file .txt. This will on my local computer just install all of these different libraries such that we can resolve the imports whenever we do work with them. So I'll just wait for this to finish and then come back. And it just finished right here. And now I just want to set us up with Modal. So you can say pip install Modal. And then Modal is, as I said, what we're going to use to run our program on serverless GPUs. So click the link in the description to go to the Modal website. I'll just open it up right here. Modal, and then just say AI. So if you are not signed up already, I would encourage you to hop in and just sign up right here. And then as soon as you're signed up, we should be able to hop in and say Modal setup, because we have just installed Modal. And this should open up some way where we can authenticate. So I'll just continue with my GitHub right here and just sign in. So I just signed in, and the first thing we see is create a token. So then I'll say authorize, and now it'll redirect me in a couple of seconds, it says. And then going down here, we can see that a token was written to our local system that authorizes us with Modal. So that should be all good now. Hopping back, we can now see our apps, and we can see the Modal dashboard. So now we should be able to go ahead and work with Modal. So the first thing I would like to define in here is going to be the Modal image. So this corresponds to a Docker image, which is going to be built automatically by Modal in the cloud. So this will install the requirements, for example, and set everything up so we can run our endpoint. So I'll first of all go ahead and say image is equal to, and I'll just open it up as a new parentheses, modal.image, and then we just need to import Modal. So I'll say import Modal. So if I say modal.image.from registry, then you can open up a parentheses and then say NVIDIA, CUDA, and I'll say 12.4.0 development, Ubuntu, and then I'll say 22.04, and then I can pass in add Python, and we'll add Python 3.12 because that is the version we're working with as well. This will set up the Docker container for us whenever we run it for the first time. So this is going to be the first step in building the Docker image. So right after this, we'll say dot and then apt install. This lets us install specific libraries of things into our system that has this base image right here. So I would like to install, and we'll pass in an array. So this is an array of the different libraries we would like to install into our base image. And we're going to need FFmpeg within our program. We are also going to need a couple of other things. So one of these libraries is going to be an OpenGL libraries that is needed by CV2, so OpenCV for the image and video processing. So this is called lib, lib, and then gl1, misa, glx. I know it's a little bit cryptic, but this is a library you'll need. Otherwise, you'll probably run into an error whenever we use OpenGL later on in the development. So after this, we'll just get the vget as well. This means we can download things from the internet into our Docker container, which we'll do in just a second as one of the next commands. Then we'll also just install lib cud nn8, and what this does is that it is a NVIDIA and CUDA library used for GPU accelerated deep learning. So because we use whisperX, we'll need this library so we don't run into any errors. Right after this, I'll put in the exact same, just followed by -def, and then I'll go ahead and save this. Now, right after this apt install, I would like to put in a pip install from requirements. So just like we ran this pip install requirements down here in our local terminal, I would like to do the exact same just in the Docker image up here. So up here, I'll say requirements.txt. And the reason we do this is because we actually defined our requirements.txt file right here with all the requirements. So all these will be automatically installed into our Docker image so we can use the libraries. After this, we can go ahead and say run commands. So I would like to run a few different commands. So we can put in an array into this method called right now. And let me just see if I can make this multi-line. So I'll just do that and that. And then also for run commands. So the first command we're going to run after having installed both these libraries here and also the pip libraries is going to be a command to install a font. So for the subtitles, we're going to customize these, and I would like to use a specific font, and this font isn't really installed into this base image by default. So the font we're going to use is going to be Anton by Google. So if I search for Google font Anton, then you see this font right here. So in here, you can actually go ahead and get the font, so you can download the font. You don't need to do this. We'll just do this automatically. Just so you know it, this is how you get a font basically. So this is what the subtitle is going to look like. So in case you would like to use another subtitle, you can go into Google Fonts, find the exact subtitle you would like to, or the font you would like to use, and then you can download that in here. We're going to download Anton. So first I'll say make directory. So mkdir-p, and then I would like to make one at user, share, fonts, and then true type, and then custom. Like this. So that is the first command we'll run inside our Docker container. The next command is going to be vget. So we'll download something from the internet with the library we just installed. We'll download with -o, like this. And then we can say we'll download it into this custom fonts folder we just created. So we'll download into that, and then we'll call the file Anton regular.ttf. So this is just a typeface, and then we can download from https github.com/google/fonts/raw and then /main ofl Anton and then Anton regular.ttf. Now if I save this, I'll just make this multi-line as well. Oh, sorry, not multi-line, more lines. Then the next command I'm going to run is going to be update the font cache. So we'll say fc cache and then -f -v. So we first create a directory to store our font. Then we download the font down to this directory, call it Anton regular. We download it from Google, so from their GitHub. And then we can refresh the font cache. So what this does is that it is needed to update the system's font cache after installing this new font, so we can actually find the font with FFmpeg and also the other programs that might be needed to render out the subtitles. Then what I'll do is just close down right here, and then we can move on to the next part of the code. So since we pulled down this right here, ASD, active speaker detection repository, I would like to include this repository as part of our installation. So this should just be copied from a local computer into the Docker image, such that it can be used whenever it is running on the cloud. So after this one, I would like to say add local directory. And then what I'll do is say ASD, and I can then say /ASD over here. And it's because we are missing a closing quote right now. And then after this, I can say copy is equal to true. So by setting this copy to true right here, we'll copy in the files into the image layer at build time. So pretty similar to how copy works in a Docker file. And then what I will do is just make this a new line as well. And then down here, I'll say app is equal to modal.app. And then I can say podcast clipping. And I'll just say AI podcast clipper actually to match the name up here. And then I'll say image is equal to the image right there. And then lastly, I'll just create a volume. So a volume is kind of like a hard drive we can attach to our system or to our Docker container that is running in the cloud. This means that we can, for example, download a model file once and then have it be stored on our system instead of having to download the the model file for an AI model down every time. So we'll basically have to define a volume right here. So volume is equal to modal.volume.fromName. And then we'll like to define a volume called podcast. I'll just call AI podcast clipper model cache. And then we'll say creates if missing is equal to true. And then we'll need to define a mount path as well. So I'll say mount path outside of this parentheses. So mount path is going to be equal to /root. So we'll mount it to where Hugging Face places its torch model files. So root.cache, root/.cache, and then /torch right here. So whenever whisperX downloads down its model file when using it the first time, it'll place the model file inside this volume, and then the volume will automatically store the model file in the cloud rows. And the next time we run this Docker container again, so when we hit the endpoint again, the model file will automatically be available because the volume just attaches again, and then we don't need to download the model 2 times. And then we can go ahead and define a class. So I'll say app.cls. Under this, I'll define a class called AI podcast clipper, and I'll just define a def load models. We'll just pass in self, just say pass for now, and we'll just say modal.enter. This means that this is going to be run whenever the class is instantiated. So this is just something that is run whenever the endpoint is hit for the first time. And then inside this .cls, we can define what GPU we'll use. For example, in our endpoint, we'll use L40S. If you hop into Google, search for modal pricing, you can see the different GPUs. Let me just find it right there. You can see the different GPUs and how much they cost per hour. And this is per hour of runtime. So if you run something for 10 minutes, then it'll cost, then you can divide this by 6, and then you'll have the cost. But we'll use the L40S, so that's going to be about $2 an hour. So we'll define L40S right here. After this, we'll define a timeout. So how long can something run in our endpoint before it stops running and gives a timeout error? We'll just say 900. So this is going to be 900 seconds, so 15 minutes. We'll also say retries. We'll just set this to 0. Scale down window, we'll just set to 20. So if 2 requests are made to the endpoint at the same time, this won't be run again. It'll just keep the container warm, and then will be built for 20 seconds after an endpoint has been hit, but it'll then keep the container warm for 20 seconds. And then we'll just say volumes is equal to, and we can say mount path, and we can then say volume right there. So what this does is that it attaches this volume to our mount path. So this volume right here will be attached to this path. So anything that is added to this path will automatically be synchronized to some cloud storage in the cloud, and then it'll automatically be available whenever we call our endpoint the next time. So model files, for example. And then one more thing I would like to do is just hop into Modal. So I'll say dashboard, and then just hop to secrets. So if I just click this, we can say create new secret. So these are environment variables we can inject into the Docker container in runtime if we would like to. So we would like to store some credentials for an AWS user, for example, and maybe also the API key for the Gemini API. So we'll say create new secret, and then I'll just say custom, and then inside custom secret, we'll call this AI podcast clipper secret. And then for now, I'll just put in an auth token. So I'll just say auth token and call the value 123, and then done. This is just what we'll use to authenticate the endpoint with. So this is just because we need to define something. So I'll just say auth token 123, then press done. And then as soon as this is done running, we should be able to copy the name up here and then hop back, and then we can just define the secret. So right here, I'll just say secrets is equal to, and I'll say modal dot secret dot from name, and then I'll pass in the name of the secret which we just created, put in the comma that is needed right there. And now whenever we want to access this auth token, we should be able to go ahead and say os dot and then something like env, then we can get the auth token from the environment. So that is the power of just defining secrets. This means we do not have to store any secrets locally. We can just store them right here in this modal secrets menu. Then I'll just define the endpoint which we're going to create. So I'll say modal.FastAPI endpoint. Then I'll say the method is going to be post. So you'll need to call this endpoint with a post. And then I can say def and then something like process video. We can say self, and then we just need to define the things we need to pass in as the parameters. So the body will have a request, and we'll also have a token passed in. The token is going to be HTTP, and then authorization, and then credentials. So I'll just see if we can import this like that. Is equal to depends, and will depend on an authentication scheme. And we can define this by saying auth scheme is equal to HTTP bearer. So I'll just go ahead and import this as well. And then we can put this in right there and see if we can import this depends too. And we can. In here, I'll just say pass for now and just print out processing video. And up here, I'll print out loading models like this. And then I would just like to create a type for what we're going to receive as the request. So what I would like to use for that is just pedantic. So we can say class process video request, just define the class. And then we can say s3 key string. So this is what we expect to receive. And then I will say from pedantic import base model. We'll take this base model and inherit from that in this class. Then down here, we can just say that the type of request is going to be process video request. This means that we'll be able to get this s3 key out of the request parameter right here. And it'll also verify that the request also contains this s3 key and then throw a error to the caller of the API endpoint if the s3 key is not contained within the request. So we can actually say plus and then request dot s3 key like this, and then we'll be able to see that the s3 key was successfully passed into the endpoint. Cool. So this is the basic shell of our application. We have the image that we define up here. This is just a basic Docker image that is used to create the environment that our endpoint runs within. So we have a font available, for example. We install a bunch of requirements that is needed to do the processing of the video. We install some requirements into the system itself, such as FFmpeg, for example. And then we also copy this local directory from our computer. This means we can make changes inside these files, and it'll then be reflected inside the Docker image whenever we run the endpoint. So we'll copy this from our local directory and then into the Docker image. We then also create a volume, so we attach an external file system to our Docker image, meaning we can save things between different runs and between different containers running at the same time if we want to. And then down here, we define a class. So this class have a scale down window. So this is how long we keep the instance warm for. It has a timeout. It has a GPU, which we use. And we also pass in some secrets, which we defined. And we attach the volume. Then we have this enter function right here, our load model function. So this is only being run once whenever we start this AI podcast clipper class instantiated, So whenever we call this endpoint, for example, this will only be run once, as long as it is kept warm. And then down here, we have the actual endpoint itself. So now we just need to create a small main function to actually test out this endpoint. This means we can try and go ahead and deploy it, and then just test it out and see if we see these printouts in our local computer. Or it is actually not our local computer, it is in the cloud, but the printouts are being returned back to our local computer and then printed out in our local terminal. So first I would just like to say def main, and then say pass. Then I can say app.local entry point. So whenever we just run Modal run main.py locally, this is the code that is going to be run. In here I'll say import requests, because we would like to create a request to this endpoint right here. Inside the request, we can just define the payloads, such as this S3 key. First, we'll just say AI, AI podcast clipper is equal to, and then AI podcast clipper. Then I can say a URL to the endpoint will then be AI podcast clipper .process video.web URL. This means we can just get the web URL as a string to this, so we don't have to hard code it. Then we can say payload, which will send to the endpoint, and that'll be an S3 key. And then we'll create a folder inside an S3 bucket called test1, and we'll put a file into that S3 bucket called we'll call the file this mi6 5minutes.mp4. So this is going to be the body payload of the post request. Then we can also just define the headers. For the headers, we'll have a content type. This will be application JSON. And we'll also need to pass in an authorization token. So because we have this authorization token right here, we'll just need to pass it in as well. So I'll say authorization, and this will be bearer 123 matching the key which we defined in here as the authorization token. So we'll check whether this token value right here matches the auth token from the environment variable. So we'll then say response is equal to requests.post. We'll do a post request to the URL right here, and then we'll pass in the JSON body, which is just the payload, and we'll pass in the headers, which is going to be headers, and then we'll say response dot raise for requests, raise for status. So if we get an error 400, for example, when we call the endpoint, then we'll get an error in our local Python program. Then we can say result is equal to response.json, and we can say print results. So this means if we return anything, we're able to take that response and print it out locally. Cool. So now if I go ahead and say open in an integrated terminal, and I then say modal run main.py, what this should do is it should build up the entire Docker image right here. It'll have to build the entire Docker image. It might take 5 to 10 minutes. And then after doing that, it'll then call our endpoint with the code for doing the request as stated right there. So one thing you need to notice is that this is a Docker container definition basically. So you define the base image, and then you define different layers in the Docker image going down line by line. So if you want to change the base image, then it'll have to build the Docker image from here and then all the way down to the last line right here. So this means that what I'm trying to say is that it caches the lines. So if you change something in this local directory ASD, for example, then it'll have all of these different layers cached, and then it'll only rebuild this specific line for the Docker image. If you change anything within this requirements.txt file, for example, so if you add another requirement, then it'll have to rebuild this layer right here, and also all layers coming after that, because these layers depend on the previous layer. So just be careful that you don't change some of these early layers unless you absolutely have to, because then you will have to wait 5-10 minutes for the entire Docker container to rebuild again before you can actually test out the endpoint. So because we haven't built it yet, and because we haven't tested anything yet, this should have to build from scratch because nothing is cached. So that is also why I say it might take a while. So we should be able to go ahead and run this. Then I'll just come back whenever this is finished running. So we just got a small issue right here, but it seems like it finished and it built the image successfully. So what I'll do is just run it again, and then all of these layers that I talked about earlier should be cached, and then it should actually go ahead and run the endpoint like we expected to. So I'll just come back whenever this is done. So it just finished running right here. So what I can do is just open it up, and then we can take a look at what happened. So going up all the way to the top, we can see that it downloaded a bunch of stuff right here. So what it is downloading is both the app installs and also the pip installs. And then going all the way down, we can see the different steps it does. So this copied in the requirements from my local system to that system, then install the requirements. And then down here, it should do something with the font lastly. So let me just see, yeah, it installed the font and then refreshed the font cache. And then down here, we can see that when we ran it again, the image is already built. So what happened is that it just started up the image, and the blue text you see right here is output from the server, and the white text is output from our local terminal. So down here, we can see that we printed out loading models and processing video. So we printed out loading models on the server, then we printed out none locally, and that is because we printed out the result right here, but since we don't return anything from the response, from the endpoint, we don't have anything to print out, so it just prints out none. And then it also printed out on the server processing video along with the payload, so that is what happened up here. So it seems to be working just fine. So now we can go ahead and build out the actual app itself now that we have the shell ready of the application. If I just hop back over to the diagram, so into Excalibur right here, we can then take a look at what happens. So going over here, all the way over to the start. When the user uploads a video, this video goes into an S3 bucket, and then in the backend endpoint, so what we're building right now in Modal, we will need to download this video from the S3 bucket. So what we'll need to do is hop into AWS and set up an S3 bucket, and then also just create an IAM user that has permission to download the video, upload a video, and also list videos within a bucket. So first, I'll just close down these tabs since we don't really need those right now. And then what I'll do is just say AWS, hop into AWS, find the sign in button, and then I'll just go ahead and sign in myself. So I'll see you in the dashboard. Great, so now we're in the dashboard, and the first thing I would like to do is just hop into S3 right here. And then I would like to go ahead and create a bucket. So what we can do is say create bucket, and we'll say general purpose, and then I'll call this AI podcast Clipper. So this is just my bucket name, you can call it whatever you want. Then going down, I'll just leave this as it is, and then hop down to create bucket. And now the bucket should be created. We'll need to do a couple of things. First of all, under properties, it is permissions, we'll go down to the cause. So whenever we need to load things on the Next.js client, we might get cause errors unless we specify that we are able to access the bucket from Next.js. So this is why we'll go ahead and just allow all origins, headers, methods, etc. So the policy we're going to use is the following. I'll put in I'll put in an array, and then the first item is going to be allowed headers. Allowed headers should have content type, content length, and also authorization, like this. And then this just needs to be allowed headers. Then the next item will be allowed methods. In here we'll allow the put method. We can then also say allowed origins. So the reason we use put method, by the way, is because when we upload something to the bucket, we upload with a put command. So we generate a pre-signed URL, and then we do a put request to that URL with a fetch from the Next.js client, and then we can upload to the bucket. But we'll just need to allow this in the cause origin before we can do that. And of course, we also need to allow the origin and not just the method. So the origin is going to be something like star. That just means that you can do that from anywhere you want. So this is going to be allowed origins. Preferably you would want to put in the actual URL of the application you have built if you have a domain, for example, but I'll just put in a star for now just so we can move on. Next, I'll put in expose headers, and I'll expose e tag, and then I'll also just say And wait, I just need to make this an array. And then I also just need to put in max age seconds. And this will be 3600. If I then just go ahead and say save changes, we should be able to see the course policy down here. So now we have a bucket, and then first of all, I'll just create a folder corresponding to this hard-coded S3 key right here. So I'll take this test1, and then I'll create a new folder inside our bucket, call it test1, create the folder. Inside this folder, I'll just hop into that. I can say upload, add files, and then I would like to hop into my repositories, and then AI podcast clipper, backend, and then I'll upload this 5-minute version. Say upload, and this means we'll have some testing data to be able to test out our application with. I'll then just close it, and then I can say I am up here, and then we'll just create the user so we can be able to actually fetch this. So under users, I'll create a new user. I'll call this AI podcast clipper user. Say next, and then I'll just attach the policies directly and create a policy. I'll say JSON for this one, and then we can just manually put these in. So first I'll just remove this SID, and then under effect I'll say allow. Under action, what I would like to allow is S3 list bucket, so we can list items within a buckets, and then the resource we should be able to do this on is going to be the ARN of our actual. Let me just search for S3 up here, open this in a new tab. So we'll just need to grab the ARN, so the ID of our bucket. So hopping in here, we can copy this, hop back again, and then we can put in the resource ID. This means we can list resources in a bucket, but only for this bucket right here. Then what I'll do is just copy this statement and just paste it down right below, and then just say /star. And then down below here, I would like to put in get object. So get a specific object, and then also S3 put object, like that. So that should allow us to download a specific object from the bucket, such as the video itself, the original video. It should also allow us to upload the clips and then also list the items within the bucket. Good. So scrolling down, we can press next and call this AI podcast clipper policy, like that. And then we can say create policy. And now if I just take this policy and copy the name, hop back into create user, we should be able to refresh the list and then see the policy we just created, this one. Then we'll just say next and say create user. Good, so now we have the user, and we can say create access key, and I'll just say application running outside AWS, and I'll say Modal, AI podcast clipper, like this. Then I can take the access key, copy that, hop into the Modal secrets, and then we'll just add another one, paste in the value. Then I'll just do the same just for the secret key. Then I'll hop in, add another one, paste in the value. And then for the naming, I'll call this AWS access key ID. And for the secret key, I'll call it AWS secret access key. And then I'll just go ahead and save the changes. So now these should be available in our environment variables inside the code. Good, so now we can go ahead and hop back into the code, and then we can try and actually download this file to see if that works. So hopping back in here, I'll just close this down. And then what I would like to do is hop into the FastAPI endpoint, and then we can first of all just authenticate this, and then we'll download it. So I'll say s3 key is equal to request.s3 key. And then we can say if token.credentials. So what we're doing is checking whether the request we're currently getting in our endpoint actually contains the token that it is supposed to contain. So token.credentials is not equal to os. And we'll just need to import os. So hopping up here, we can say import os. Going back down, os.environment variable. And then we can say auth token, because remember we put this into our secrets. We put it in right here, auth token, and that is 123123. So if those are not alike, then we'll reject the request. So I'll say raise HTTP exception, like that. Just import that from FastAPI. Then I'll say status code is equal to status dot, and then I can say HTTP. And I think we just need to import this status. So going up to FastAPI, we can just say status right there, import that namespace, and now we can get HTTP and then the thing we actually need. So it'll be HTTP and then 401 unauthorized. And then I'll also just pass in detail that it's going to be incorrect. Bearer token, just so the request person knows. And then I can say headers, and that'll be equal to www authenticate. And then I'll just say bearer like this. Good. So now we have authenticated the request, and then we can go ahead and create a temporary. Let me just go back. So if I hop into Excalibur, then as I explained, we create this temporary folder right here for each video. So we'll just go ahead and create this, which we can download into. So I'll say run ID is equal to string, and then we'll need UUID. So we'll just need to import that. And then we can say dot UUID4. So we'll create a new UUID, which we can use as the folder name. Then we can say base directory is equal to pathlib. We'll just need to import that. Dot path, and then we can say temporary file, just a normal Linux folder, and then slash run ID. So we just append this to this temporary file. This just corresponds to doing this right here, run ID. So these two things are the same. It is just an easy notation just to do this. Then we can say base directory dot make directory, parents true, and exist okay, true. So that is all fine as well. So now we created the name of the folder and we created the folder itself. Then we'll just say download file. And then we can say video path, because we'll just need to specify where to download it to as well. This will be equal to the base directory slash input.mp4. So we'll download it into the following path right there. Then I'll say s3 client is equal to boto free, import that dot client, and then I'll say s3. Then I can say s3 client dot download file, and I would like to download from the bucket called AI podcast clipper right there. I'll just copy the name, and then I would like to download the following s3 key, and then I can say string video path and save that. And now the file should be downloaded to this path. So we'll just go ahead and print out something to be sure. So we'll say os list directory, base directory, and then this should print out if it works or not. Cool. So if I'll just open this back up, terminal, and then just run the entire thing again, then we should be able to see something in just a second. Okay, so it just finished after about 5 seconds, and now we can see that we have input.mp4. So this is the list of items inside the base directory it printed out. So it seems like it was downloaded successfully, so everything is working just fine. And the next step is then just transcribing the video. So right over this FastAPI endpoint, I'll create a new function, def transcribe video. We'll take self base directory string and video path, which is also a string, and this function will return a string. And in here we'll use the Whisper model or whisperX model to go ahead and transcribe the video on this video path. So we can just go ahead and load the actual Whisper model up here because we haven't done this yet. This means we can say self.whisper something is equal to a model, and then we can down here say self.whisper and then access the same model that was loaded once up here in the model.insert. So that is the approach we're going to go with. So first we'll load the model. So I'll remove pass, and then I can say self.whisperX model is equal to, and then I'll say whisperX, and we'll just need to import whisperX like this. Then I can say .load model, and I would like to load the large version 2, and I'll pass in a device, And since we have access to a GPU, I'll say CUDA. Then I can also say compute type. And this will be equal to float 16. If you are in doubt of why this is the way it is, there is some documentation, as I showed you before, inside the repository that just shows how to set up a simple example with the whisperX model. So this is the model that is used for transcription, but we'll also need a model for alignment, so to get the timestamps of the actual words. So I'll say self.alignment model is equal to, I'll destructure two things, self.metadata as well. We'll need both, is equal to whisperX.load alignment model. We'll pass in the language code. That'll just be English for now. You can also have it auto-detect the language as far as I know. And then for device, we'll just say CUDA2. So now we have whisperX model, alignment model, and metadata. We should then be able to use these instance variables to do the actual transcriptions down here in transcribe video. So I'll just say print transcription models loaded, ... And then down here we can remove the pass. So the first thing we'll need to do to transcribe the video is to extract the audio from the video. So we'll need to extract it to some path. So I'll say audio path is equal to base directory, and then /audio.vav. Then I can say extract command is equal to, and remember how we install FFmpeg up here, right there. So that's for processing audio, video, etc. So we can actually use the FFmpeg command down here now. So we'll say FFmpeg-I for input. Then we'll pass in the video path, so that this is the input for the command. So this is just the video we would like to extract the audio from. Then we can say video none-vn. It disables video output, so only audio is processed. Then we can set the audio codec. So I'll say audio codec, like this, codec PCM S16LE. So it'll set the audio codec to encrypt 16 bits. So this is a WAV format. Then I can say 16,000. I'll just need to pass in the flag as well. -AR 16,000. So this is going to set the audio sample rate to 16 kilohertz. After this, we can put in the mono channel. So we'll make sure there's only one audio channel. So we'll do -AC1. And then the output is going to be the audio path. So I'll say audio path right here. So this is basically just the command which will run. So to actually go ahead and run this, we can import subprocess and say .run. We'll pass in the extract command as well as a couple of more flags. I'll pass in shell to be true. I'll pass in check to be true. And I'll pass in capture output to be true. Now this command should then run and extract the audio from the video. And then we can say print starting transcription right after with whisperX like that, ... And then one fun thing we can do is actually time this. So we can say start time is equal to time.time and just see how long it takes to actually do the transcription. And then we can also do a duration. And duration is going to be equal to time.time minus start time, like that. And then we can print out the transcription and alignment actually took, and then we'll just do plus duration. And then what I'll do is just say plus seconds. Cool. So this should tell us how long the transcription takes. Now inside the transcription, what I'll do is say audio is equal to whisperX.load audio. So we can load the audio file into the whisperX model. So then we'll say string audio path. After this, we can say result is equal to self.whisperX model.transcribe. And I would like to pass in the audio, which we just loaded, as well as the batch size. And the batch size is just going to be set to 16. The higher the batch size, the more GPU memory you're going to need. I have tested it and 16 works pretty well for the L40S GPU. So that is just what I'm going to use. So this should do the actual transcription, and then right after we can do the alignment. So I'll redefine results. So I'll say result is equal to whisperX dot, and then I can say align, and I can then pass in the result segments. I can also pass in self.alignment model. I can pass in self.metadata. I can pass in the audio and the device, which is going to be CUDA, and I can pass in return char alignment and just set that to false. And then what I'll do is right after this, now that we have the result, I can say print, and then I'll just say results. And then we probably need to do something like JSON, import that dot dumps, and then pass in this with indent too. So now we should see if it actually prints out something and it actually does the transcription or not. So what I'll do is just run this code again, and then we can check out the result and then move on from that. So it just finished, and as you see, it didn't really print out anything, and I think I know why. So going down, we don't really call this transcription function. So I'll just hop down to right down here, then call the transcribe video, so self.transcribe video, because it is a class function, class method. Then we can pass in the, base directory, and we can pass in the video path. And then if we run it down here again, we should see some printout, because now it actually does transcribe the video. So I'll just come back whenever this is finished. And I just got this error right here. So if we scroll up, we can see that we have an error, return character alignment. So finding out where that is, it's right there. It is supposed to be return character alignments and not alignment. And it should also just be a false and not a string. So I'll just run it again, and then it should be done in just a second. So it just finished up, and now we can see the printout. So we have the 5-minute clip, and we can then see the words, the start timestamp, the end timestamp, and also some score, which we don't really need. And then let me just see. Yeah, it looks great to me. Cool. So we can take this and just transform it into a data format that is more appropriate for our use case. So down here, instead of JSON.dumps print, we'll just remove that, and then we'll create a variable called segments, which is going to be equal to an empty array. Then I can say if, and then there should be a property called word segments. This property should be within this result dictionary that is returned. So I'll say if word segments in results. Then I can say for word segment in results. And then I can say word segments. So we'll loop through the items of the word segments. Then we'll say segments.append. And the data I would like to keep is the start timestamp, which is word segment start. I would also like to keep the end segment right here. The end timestamp. And then also the word itself. So word and word. And since we are returning a string up here, what I would like to do is just transform this into JSON and just return that. So I can say return JSON, return JSON.dumps, and then I'll just dump the segments and return that. And then we can say read it as JSON whenever we need it later on. So now that we're returning something from transcribe video, I can say transcript segments JSON is equal to self.transcribe video. And then what I'll do is just say transcript segments without JSON is equal to JSON.loads, and JSON.loads transcript segments JSON, and now we should have some JSON with it in it. So this was the first step, which is transcription. The next step is going to be the identification of moments. So I'll say 2, or I'll just do this 1 and 2, and then identify moments for clips. So we'll just need to create a API key for Gemini so we can actually use this LLM. So I'll search for Gemini and then API key. This way we can get an API key which we can use. So we'll just need to sign into our account. So go ahead and create a Google account or use your existing one and just sign in, and I'll just see you on the other side. And now we are logged in. So under Google AI Studio and API keys, we can go ahead and create a new API key. And then we'll just need to create a Google Cloud project So if you do not have any of these, just go ahead and create one. I'll just select this Gemini API. I think this is one I've already created actually. Maybe it's there by default. Otherwise, I can just say create API key in existing project. And then just wait for this API key to be generated. I'll then just copy the key, hop under Modal and secrets, add another one, and paste in the key. I'll then just call this Gemini API key. Then I can just copy this and save the changes. And then we should be able to instantiate or create a Gemini client in here under the enter load model function. So under here, we can create self dot and then client. I'll just call this Gemini client is equal to generative AI, which we can import from Google. So going all the way up here, we can say from Google import generative AI. And then going down here again, gen AI dot, and I'll then just say client. I'll pass in the API key, which will be os.env or just environment. And then I would like to grab the specific key which we just created, so this Gemini API key. And this will then be stored on the class itself, so you can say self.Gemini client to be able to run queries through the Gemini API. So before this, I'll just say print, and then something like creating Gemini client. And then I'll just put in a print right after that says created Gemini client. And now we should be able to use this in a new method, which we'll just create down here. So I'll just create a new def, and this one will be called identify moments. So I'll say def identify moments. I'll pass in self and the transcript, which will be a dictionary. And then in here, I can say self.Gemini client.models.generate content. Then I can pass in the model I would like to work with. So if I hop in here and then search for, let me just see, API quick-start-guide, we should then be able to see what models we're able to work with. So under rate limits maybe, then we can first of all see all the models, and we can also see what limits we have available. So as you see, for the Gemini 2 models, we have many more requests we can make both per minute and also per day. So this is requests you can make per minute, this is requests per day, and these are the tokens you can make per minute, I suppose. So you can pass in 1 million tokens at a time per minute, which is quite a lot. I'll just go ahead and use this Gemini 2.5 flash preview, and then I'll copy this name, hop back into the code, and then it'll be Gemini 2.5. And then I'll just need to put in dashes instead of spaces, preview, and then 0417. Cool. So this is the model which we'll query with. Then I can say contents, and then I can open up these three brackets three quotas, and then the prompt itself will be inside these three quotation marks. And this is also a multi-line, so that is why I put in the 3. Now, what I now want you to do is just go to my GitHub repo and just copy in this prompt, because it is a little bit too long for me to write it out myself. So I will just paste this prompt in like that. So what you see right here is the full prompt. So I can just read through it quickly. This is a podcast video transcript containing sentences along with each sentence's start and end time. It'll probably be containing words along with each word's start and end time. I'm looking to create clips between a minimum of 30 and a maximum of 60 seconds long. The clip should never exceed 60 seconds. And then your task is to extract or find and extract stories or questions and their corresponding answers. So this is just a basic prompt. And then I also say, please adhere to the following rule. Clips cannot overlap. That is very important, because if you have 2 clips that overlap, you'll probably get the same clip once in a while, which isn't very good if people actually pay for it. And then also I put in rules such as only use the start and end timestamps provided in the input. Modifying timestamps is not allowed. And then very importantly, we wanted to format the output as a list of JSON objects, each object representing a clip with a start and end timestamp. So I would like the output to be something like an array, and then with a start and the end. And then the output should always be readable by Python's JSON.load function. So we'll just force it to output JSON. And then I also tell it that I want clips that are longer, so between 40 and 60 seconds. And then some things that I've noticed that it sometimes did, which I wanted to avoid, is the following. So moments of greeting, thanking, or saying goodbye. So sometimes if I use this prompt without this, it would create a clip with like just introduction to an interview or just like thank you, which doesn't really make much sense. And then also, if there are no valid clips to extract, the output should just be an empty list, also readable by the JSON.loads function in Python. And then we just need to pass in the transcript actually, because this is the prompt for finding the clips. And then we just need to give it the data to work with. So to do this, I'll say plus, and I'll stringify the transcript, which we got as a property up here, also a parameter. And then right on this, we can say print, and I'll just make it a format string and say identified moments response, and I'll then just pass in the response, and I'll just need to save this as response like that. I can then say response dot and then text. So this is the output, and then what I'll do is just return. So down here I can go ahead and say return response dot text. So these are going to be the viral moments. So hopping down, we can go ahead and call this function. So I'll say identified moments raw is equal to self dot identify moments, and I'll pass in the transcript segments. And then because we are just getting text out, we'll just need to clean up that text because it might contain something that isn't JSON, etc. And then we can load it in as JSON to get the structured data. So I'll just go ahead and first of all, I'll just print right here, identifying clip moments, just so we know it in the logs. Then I can say cleaned JSON string, and I'll then say identified moments raw dot strip. And if we hover this, we say it returns a copy of the string with leading and trailing white spaces removed. So it'll just clean up the string just a little bit. This will just need to be cleaning. Then we can say if clean JSON.string that starts with, and then I can put in free backticks JSON. So the model might output something that looks like this. So it might output JSON, and then it'll put the JSON inside of that, and then free backticks again. Oh, I think it's like that. So it might output something like this, where it just wraps it in this JSON just to let the user know that it is JSON. So if this happens, and I have seen this happen before, then we'll just go ahead and remove this because we can't really pass this as valid JSON. So I'll just go ahead and remove this. So if it starts with these JSONs, then if it starts with this free backtext JSON, then we'll just cut that away, and then we can pass it. And the same for if it ends with that, then we'll just cut these free backticks away, and then we'll pass it as JSON. So this is just like a guard statement because I've seen this happen before. So I'll say cleaning, I'll just say cleaned JSON string, cleaned and cleaned is equal to clean JSON string. And then we can cut away these characters. So I'll say length of, and then put in this right there. And then I can say dot strip again. So this should remove the end backticks, the start backticks, and I can also say dot ends with, and this will just be free backticks alone. And then I can go ahead and remove, let me just do this, remove these free backticks like this. So this right here, if it finds this, it'll then take from after the first 7 characters and then the rest of the string and keep that. Down here, if it sees these 3 in the end, it'll then keep the first part of the string all the way up until the last 3 characters. So the length minus 3 will from the end. So this means it'll just remove these. So now that we cleaned the string, we can actually go ahead and use these moments. So I'll say clip moments is equal to JSON.loads cleaned JSON string. And I can then say if not is instance clip moments list. So if the clip moments is not a list like we would expect it to be, a list of moments, then we'll say clip moments is equal to an empty array. And then we can also print out some error just to let us know what actually happened if in case then no clips are produced. So error identified moments is not a list, like that. And then if it is a list, we'll just do one more actually. I'll just say if not clip moments. So if it wasn't loaded properly at all, I'll then just say print, or actually I'll just combine these two. So if not clip moments or not as instance of a list, then we'll just go ahead and print that. Cool. So now what I can do is say print clip moments, like that. And then under this, we can loop through these clip moments and then process them one at a time. So I would like to say for index and moment in, and I can say enumerate to loop through the list while getting both the item in the list as well as the index in the list of that item. Then I can say clip moments, and I'll just take the first 3 clips for now. So for example, if you put in a very long podcast, you might get 20 clips out, and that can take a while to generate all those clips. So no matter how many clips it finds right now, I'll just take the 3 first. You might want to set it to 10 if you are fine with it spending time generating 10 clips. You might want to set it to 1 if you're just testing, for example, or you might don't care at all, so you can just do this. But for testing, I'll just set it to 3 right now. But in production, you probably want to change this to a higher amount or just remove this completely. Cool. So I'll take the first 3 clips from the list and loop through those. Then I can say if start in moment and end in moment. Then I'll print processing clip string index, so the index of the clip. I can then say plus from, and I'll put in the start from start. So it'll actually not be this, it'll be string moment start. And I can then say to string moment end. And then now we just print out the status just so you can see in the logs what happens. And then we actually need to go ahead and process the clip. So we'll create a function called process clip. In this, we'll pass in the base directory. We'll pass in the video path to the original video. We'll pass in the S3 key. So we have the folder which we'll need to upload the process clip to. We'll also pass in the start time. So start. We'll pass in the moment end, so we know where to clip the original video to and from. We'll also just pass in the index of the clip. This way we can name the clip in the S3 bucket after the index. So we can say clip 1.mp4, clip 2.mp4, etc. And we can then also pass in the transcript segments because we'll need to use this to do the actual subtitling of the clip. And then this function right here should actually take care of the rest. So after this, what we'll do is just go ahead and clean up the entire folder, because this should then upload the clip to the S3 bucket as well. So when this is running for all the clips, we should be done with the function. So I'll say if base directory .exists, then we'll print out cleaning up temp thereafter. Then I'll just put in the base directory right here. Then I can say sh util import that dot remove tree, so it'll remove the folder as well as everything within the folder. Base directory, ignore errors, true. Cool. So this will then do all the things we need to do. And down here, let me just put in this free process clips. Cool. And then after processing everything, we'll just remove all the remnants and reclaim the space, because now we don't need anything kept in the function anymore, because we'll end the function anyways. So going up, we can go ahead and create this process clip. So what I'll do is just create a new function, def process clip. And what I'll do is just take the same properties or parameters as we just passed down. So self is the first one, obviously, but we also have, let me just wait a second. We might actually not need anything from this class right here. We don't need the Whisper model, the alignment model, or the Gemini client. So what I'll do is just take this, remove self, and then move it all the way outside this class just to keep the class as clean and pure as possible, only containing things that actually need the things from this load model. So I'll just hop up here and define the process clip outside this class, and then we can call it like that. So for the parameters, we'll need the base directory, which is a string, original video path, which is also a string, s3 key, a string, start time, a floats, end time, a floats. We'll need the clip index, which is going to be an integer. We'll need the transcript segments, which is going to be a list like we just checked in that gar statement. And that should then be it. Cool. So if I remove this pass, we can go ahead and define a name for the clip. So this will be a clip name. So this will be a formatted string that says clip. And I'll then pass in the clip index. And then the s3 key for the clip is then going to be the clip name. And then we'll also need to prepend the folder name from the original video path. So the original video path might look something like this. So you have a UUID / the original video.mp4. So what we want to do is remove this .mp4 part and just keep this UUID. And then we want to append the clip name after that. So that is what we are trying to do right now. Cool. So we can first of all get the s3 key directory from the original video path. So we can use os.path.directory name actually. And then we can pass in the s3 key to get the directory name of this s3 key. So that is just going to be the folder. Then we can say output s3 key is going to be equal to a formatted string with s3 key directory / and then we can pass in the clip name. And lastly, it is going to be an mp4 file, which is going to be the output always. Now we can say print and then something like output s3 key and then output s3 key. Cool. So now we at least know that in the logs. The next thing we'll need to do is create a directory for this specific clip. So we have the base directory. So if we hop down here, the base directory is a directory for the entire video that we're processing, but it doesn't take into account that there are more clips actually. So for each clip, we're going to get the tracked faces, for example, etc. And these will be stored as files in the system. So we'll need to make sure to separate these files between these different processes. So if one clip creates a file, this file then shouldn't be used by another clip that is also being processed. So we'll need to separate these, and we'll do this by giving them unique file folder and file names. So first I'll say clip directory is equal to base directory / clip name. Then I can say clip directory dot make directory, and then parents is equal to true, and we'll say exist okay is equal to true as well, like this. Then we're going to create 3 different paths now. So the first path is going to be a segment path. The segment path will just be the original clip, and we'll cut the original clip from the start to end. So it'll just be the original clip, just a segment of the original clip from start time to end time. Then we'll also need a path for the vertical clip. So this is the clip without subtitles, and also a path for the clip with subtitles. So those are the 3 paths that we are creating right now. So first I'll say clip segment path is equal to clip directory / and I'll put in a formatted string clip name, and then I'll say underscore segment.mp4. Next I'll put in a vertical mp4 path that is equal to clip directory / PyAVI / video out vertical.mp4, like this. And then I'll put in a subtitle output path, and this should then be clip directory / PyAVI / video with subtitles.mp4, like this. And then this Columbia script which we'll use. So remember, under GitHub, and then LR-ASD. Let me just spell this correctly. GitHub LR-ASD. So there is a Columbia script which we're going to use. That is the one right here. And this Columbia script is going to create a couple of folders for us. One of these is going to be FastAPI, but there are other folders as well. And it'll need these folders to be available. So what I'll do is just create these folders beforehand so it can just insert it into these folders without running into any errors because the folders maybe didn't exist. So first I'll say clip directory, and then PyWork, and then I can say dot make directory. And this up here actually needs to be make directory without an underscore. So we'll just do the same down here. Make directory exist OK is equal to true. This just means if it already exists, it'll just not do anything and not throw an error. Then we don't need to store this PyWork path, so that is why we don't set a variable equal to it. We'll just make sure it exists. Then we can say pyframes path is equal to clip directory pyframes. This is another path that will be created by the Columbia script. We'll then have the PyAPI path. So PyAPI path, that'll just be PyAPI. And then we'll need an audio path as well. So I'll say audio path. That'll be clip directory PyAPI /audio.vav. I'll just make this a .vav. And then what I can do is say pyframes path .make directory and just exist OK. Set that equal to true and just do that for both this path up here. So pyframes path and also the PyAPI path. Cool. So now what we can do is try and actually cut the segment out of the original video. So first I'll get the duration of the segment. This will be end time minus start time. Then I can say cut command, and we'll just use the same kind of command that we did up here, or same way of defining the command. So we'll create a string and then pass it into a sub process that run afterwards. So the cut command will be equal to a format string FFMPEG, where the input is going to be the original video path, and then we'll say start, which will be start time, and we'll say 2, and this will be duration. And then we can just put in another line down here where we say format string again, and then we'll put in the clip segment path like that. Now we can go ahead and say subprocess.run, and then just run this command to cut that segment from start and end out of the original video. So we'll put in the cut command, say shell equals true, check equals true, capture output equals true, and text equals true, like this. And then after saving that, now we can also extract the audio from the segment. So remember, from the excalidraw, we render out the entire video. So we write a new video, and then we take the existing audio from the segment, and then we put that onto or overlay it over the video which we just wrote, because the video we wrote didn't contain any audio. So that is why we have this audio path. So we can take this vertical MP4 path and then just put the audio onto that. So first we'll need to extract the segment, then we can extract the audio from that segment, and then etc. So let's just take the audio and extract that. So I'll say extract audio command is equal to a format string FFmpeg -i clip segment path, and then I'll say -vn, and then let's just see if we can find the existing audio extraction command which we used up here. I'll just take this and copy it, hop back down right there, and then I'll just go ahead and fix the indentation, and this just needs to be clip segment path, and over here it is still correct. I will then just take the segment that we just created up here and then copy it to the base directory as well. And the reason is that this Columbia command, which we'll use from over here, requires us to specify a video folder as well as a video name within that folder. So I'll just copy in the clip, or sorry, the segment that is called the clip name 1, for example, into that base directory, and then run the Columbia command like this. So I'll say shutil.copy, and I would like to copy the clip segment path to base directory and I'll put in a formatted string, clip name, .mp4. Then I can say Columbia command. So the Columbia command will be equal to a formatted string, which is Python Columbia test.py. So hopping into this ASD folder, we can see that we have Columbia test.py, and that takes a bunch of different arguments. There's a video folder, a video name, and a bunch of other things. You can read more about how it actually works over here if you want a simple example. So otherwise, you can also just follow my lead if you want. So I'll say Python Columbia test.py, and then I can say -- video name, and the video name is going to be clip name. Right under this, I'll put in another formatted string. So I'll just put in a spacing, then another formatted string that says video folder. The video folder is just going to be the base directory now because we copied it into the base directory. Right under this, I'll put in another formatted string, pre-train model, wait, fine-tuning, talkset.model. Then what I'll do is just take this command and actually run it. So just like we did with the FFMPEG, I can say subprocess.run, pass in the Columbia command as well as the working directory. So we'll say change working directory right here. So this is where the command is going to be executed from. And it's going to be executed from the ASD folder. So right here, because you can't just call this Python Columbia test.py from the root folder right here. You have to first navigate into this ASD folder and then call it from in here. So that is why we change the working directory to ASD when the command is called. I'll then just set shell to true like this, so it is running in the shell. And then because a lot of things are happening in here, so we run 2 AI models, for example, I would like to take timing before and after just so we can see if it becomes a bottleneck in the logs. So I'll say Columbia start time is equal to time.time. And then right after we can say Columbia end time is equal to time.time. And then we can print out Columbia script completed in, and then we'll just take the Columbia end time. I'll make it a formatted string first. Columbia end time minus Columbia start time. And then I can just go ahead and say, change the formatting a little bit like that, and then say seconds. And that way we can know how long this will take whenever we run it in the terminal, in the logs. And the output of the script is then some temporary files. So one of these are tracks and one of these other files are scores, and these are stored as pickle files. And these pickle files are just Python objects that are stored or serialized within a .pkl or .pcl file. So it's kind of like a JSON object just for storing Python objects. So we can go ahead and just open up these pickle files to get out the tracks and also the scores that were calculated with this Columbia test.py script. So first I'll say tracks path, because we'll just need to find out what the path is. Then I can say clip directory, and then pywork, and then we can also say tracks.pckl. So what you can do is, if you want to find out what this script right here actually produced, you can go ahead and just run it and then list out the files that came out of it after it ran. So you can do something like os and then .list directory, and then you can put in the path that the video then, that the script then outputs to see what it produces. So I just did this and I found out what came out of the script, and that is therefore why I know that these files even exist. So the first one is the tracks, and then the next one is going to be the scores, and this will then just be scores.pickle instead. Then I can say if not tracks path .exists or not scores path .exists, then we'll raise a file not found error, because after all we do hardcode these file definitions, or these file paths, so we'll just make sure that they're actually there. And then I'll just say tracks or scores not found for clip, like that. And then right below we can say with, and then open, and then we'll just open up these 2 files and load them into memory. So I'll say tracks path, and then I'll do rb as file. Then we can say tracks is equal to pickle, and we'll just need to import pickle like this, .load file. And then what I'll do is just copy this line right here and just paste it in below and just call this scores path. This one should then be scores, and then I can say pickle.load file as well. And with the tracks and the scores done, we can go ahead and create the function for creating the vertical video. I'll just do this outside the class as well, because we don't really depend on any of these classes, any of these instance variables. So I'll just hop up to here and then say def create vertical video, and I'll pass in the tracks, I'll pass in the scores, PyFrames path. I'll also pass in the PyAPI path, audio path for the vertical video, and then also output path. And then I'll pass in a frame width we would like to render it to, and I'll just set this to 25 per default. In here I'll just set a target width, which is going to be 1080, also a target height, which is going to be 1920. Then we can first of all get all the frames that was also outputted by this Columbia script down here. So that is in the PyFrames path. So what I'll do is say flist is equal to glob.glob. So I'll just import glob like that. And then I can say os.path.join PyFrames path with star.jpg, .jpg, just to select all of the different JPGs, so all the different frames in that format. Then I can say flist.sort. So what this does is that the first line up here finds all the files ending with .jpg, and then just returns a list of their paths, and then the flist.sort down here, because this is now a list of all the paths leading to JPG images, and we then sort them, and because they are named with their numbers, so frame 0 would have 0, for example, we then sort all the file paths by their name, just to make sure that they are in the correct order. So before continuing the implementation of create vertical video, let me just go down and actually call it, just so we can test it out in just a second. So I'll say create vertical video, pass in the tracks, I'll pass in the scores, the PyFrames path, the PyAPI path, the audio path, and also the vertical MP4 path. And then I would also like to just take the time before and after. So I'll just say create a video, vertical video, something like this, start time. And then I'll just do create vertical video end time. And then down here I can say print clip. Then I'll say clip index, the vertical video creation time, just so we can check that in the logs in case something takes a lot of time, just so we can kind of debug what it is. And I'll then say create vertical video end time minus create vertical video start time. And I'll just format that number as well. And then say seconds. Cool. So now that this method should be called, and we can then hop into the method and continue the implementation. So now what I would like to do is just loop through the tracks. So hopping back to Excalibur, we can just check out what part we're actually at. So going down to right here, we can see this step 1 is looping through the tracks whenever we want to create the vertical video. So we'll loop through the tracks, and then for each frame we'll create a list of faces in that frame along with the faces positions and also the score, that is the probability of this face speaking. And then we of course also just need to average the speaker score over a window of 30 frames instead of just taking the score per frame. So that is what we're going to do now. So first I'll prepare a data structure for containing these faces per frame. So this is just a list of lists where each inner list contains faces for a frame. So I'll say faces is equal to a new list, and then I'll create a list for nothing in range len f list. So this will give us a list of lists where each list is an empty list, and then there is an amount of lists inside this list corresponding to how many frames there actually is. This means we can index into the list if we, for example, have an index of a frame. So now that we have this data structure ready, we can say for tidx and track in enumerate, and then we'll say tracks right here. If we then hover track is just going to be a track, and tidx is going to be an integer, so that is going to be the track ID, track number, the track index in this list of tracks. So this is going to be the number. So if we have iterated through this 2 times, then this will be 1, for example. And if we iterate through this 3 times, this will be 2, etc. and this will then just be the actual track we get out of the track lists. So now we can say score array, and then the score array is going to be equal to scores, where we put in the TIDX, so the number or the index. Then we can loop through the different frames. So I'll say for frame IDX and frame in enumerate track and frame. And I'll then say to list like this. So first, this code loops through all tracks and their scores. So each track is going to represent a detected face or speaker in the video over a number of frames. And then for each track, we then retrieve the corresponding score array. So this is how likely the user is to be speaking for each frame. And then after this, we can then loop through each frame index in the track representing the frames where the face appears. And what we'll now do is then for each frame, we'll calculate an average score by taking a window of scores around the current frame, so plus minus 30 frames for smoother results. So how I'll do this is first of all saying slice start. So we'll take, let's say we have a frame that is frame 100, then we'll take 30 frames before that and also 30 frames after that. So this will give us 60 frames total. So I'll need to take the original number of scores, or the original array of scores, and then slice 30 scores before the actual ID and 30 frames after that. So I'll put it into a max and then say if IDX minus 30. So this is going to be the start. And then I'll say 0. So in case the ID is 20, for example, then this would give negative 10. So this obviously doesn't exist because we can have a frame with an index negative 10. So this will then default to 0. This means we'll have a smaller average, an average based on a fewer numbers, but it is just to prevent us from going over bounds. So to less than 0 frames or to more frames than there actually is. So for slice end, we'll just do the same trick, just with a min. So slice end is equal to minimum if IDX plus 30. And then I'll say length of score array. This means that we can't really go over bounds with the scores array. Then I can say score slice is equal to score array, where we slice from the start to the end, like that. And now I can then calculate the score along this array slice. So I'll say average score is equal to, and we'll cast it to a float, numpy.mean. We'll put in the score slice, and then I'll say if length score slice is more than 0, else 0, like that. And I just need to move this outside, I think, like that. Oh, sorry, I think I need to remove that parentheses and then just put a parentheses right here instead. Cool. And then we just need to import numpy as an np. So that is what it did up here. Oh, I can just show you how it looks. Import numpy as np. And then now we have the average scores across this slice of different frames. Then what we can do is just store this data. So we can just take this faces array we created up here and then say for this specific frame, we would like to append the data. That is the track, TIDX. And then we would also like to append the score for the specific frame, for the specific face. And that is going to be average score, like that. And then we would also like to store the score. That is going to be track, and it is going to be PROC track. And then we'll need to with then underscore. And then we'll need to put another indexing into this, so S, and then also FIDX like this. Then what I'll do is just copy this line right here with the score 2 times and save. And then the next thing we would like to store is the X coordinate of the face. So this will be the same, just with X instead. And we'll also want to store the Y coordinate. So this will be Y right there and Y right there. So we now have a list of faces per frame because we can use frame as an index right here to get data out of it. And then if you have multiple faces in one frame, those faces are all appended to this list in here. And then each face will then contain a track ID, a score, and then, the score right here. And then we'll also have the X and Y values for the face's position so we can crop to it. So now we have created this part right here of looping through the tracks. And next we'll just need to go ahead and write the video where we crop it. So I'll just hop down to a new line, and then we can continue doing that. So I'll remove two indents right here, go back to the root level of the function, and then I can say temporary video path. So we'll need a temporary output file for the video. So I'll say temporary video path is equal to os.path.join. And I would like to join together PyAVI path with video only. So this is the vertical video we create, and then later we append the audio to this video only.mp4 file. We'll then create a variable called vout that'll be equal to none. So this is where we'll store and initialize the FFmpeg video writer to. And now we can then loop through the different frames. So I'll say for frame idx, fname, in, and then we'll create a progress bar when we're actually writing the video. So I'll say tqdm. So this is a library you can use to create progress bars. And then I can put in an enumerate frame list where the total it has to move towards is going to be the length of flist. And we can then also put in a description, which is going to be creating vertical video. So now it is basically like a normal loop. We just wrap it in tqdm, and this just prints out a progress bar in the terminal, so in the logs whenever we try and run this code. So the first thing I would like to do is just read the frame. So we loop for each frame here. So I'll just read the frame with cv2. So I'll say image is equal to cv2.imread. And we'll just need to import cv2 like that. So if name is the name of the frame we can read, then I can say if image is none, then we'll just continue to skip the frame if it can't be read. And we can now find the current faces for the specific frame from the list that we created up here. So what I'll do is say current faces is equal to faces if idx. So remember, we have the faces array, and then we can index in with the frame. And because we loop through frames, we can then access the faces from faces with the frame idx right here. So next we can find the face with the highest score. If there is any, so I'll say max score face is equal to max, and then we'll say current faces key is equal to lambda face score if current faces else none. So if the list up here is empty, so the list right here, which we append to, so if no faces were found in that frame, then we'll just set a max score face to none. Otherwise, we'll just take the face with the highest score. One thing we'll also do is just say if no face is speaking. So basically, if max score face and max score face score just were to be less than 0, then we also just want to set max score face to none. So I'm not sure that the score from the LLM can actually go below 0, but if it can go below 0, I guess the face is not speaking, so we'll just set it to none as well. And then we can initialize the video writer. So I'll say if vout, so that is the variable which we created up here, is none. Then we'll say vout is equal to FFmpegCV. So we should be able to import this. So hopping into GitHub, we can just check out what it actually is. FFmpegCV. So it is just like FFmpeg, it has the same API, but it just lets us GPU accelerate the video writing of the actual video, which hopefully helps us write the video a little bit faster than just using regular FFmpeg. So I'll use FFmpegCV, and then I can say dot video writer nv. I can then say file is equal to the temporary video file. So this lets us write frames to a specific file and then create a video progressively, like we talked about in the theory. So the file we're writing to is going to be this one up here, and then we'll add audio to that later on. So under here we'll just put in codec, and I'll set this to none and just let FFmpegCV choose the best codec. Then we can also say FPS, and that'll be equal to the frame rate which we defined up here. Then we can say resize, and the video should be resized to the target width, and also target width, and also the target height, like this. So now we have the video writer ready to actually write the frames to the video, and then we can go ahead and write the video. So remember how back in Excalibur I talked about that we have two different options. The frame can either contain a speaking face or not, so we'll need to set either resize mode or crop mode, and then render in one of these two ways depending on what mode we're in. So first I would like to just determine which mode we're in. So what I'll do is say if max score face, then we'll set the mode to crop, else we'll set the mode to resize, like that. So if there were no faces in the frame that we found up here, or if the score of the frame of the face that was found is less than 0, then we'll just go ahead and say, okay, then there's no faces in the frame because it wasn't really detected. So that is what we do to determine whether we're in crop mode or resize mode. Then we can start with the rendering. So if the mode is resize, so if resize, then we can actually go ahead and render this scenario right here. So remember, this is per frame basis. So we loop through each frame, and then for each frame we determine what mode we're in, and then we render based on that. So we'll start by implementing how we can render a resized mode frame. So what we'll do is first calculate the scale to fit the image width into the target width. So remember, we have to scale this big image right here down so it fits within the target width, which is the 1920 by 1080. So we'll have to find out the scale. So I'll say scale is equal to target width divided by image.shape1. So this is going to be the width of the image we're currently working with. So that is the image we read, or the frame we read up here. Next we can say resized height is equal to integer, so we'll cast it to an integer, image.shape 0 for the height times scale, so we scale the image down. So we need to compute the new height after scaling. Then we can actually go ahead and resize the image now that we have the scale and the resized heights. I just need to fix this, heights like that. Then we can say resized image is equal to cv2.resize. We'll pass in the image we would like to resize, so the frame from the original video, as well as the target width, the resized height, like that, and then also interpolation, which will just be cv2.interarea. There are different interpolations you can use that can affect how the image is resized and how fast it goes, and we'll just use interarea, which is just the one I used whenever I built this. So this code right here should take care of making the entire video fit within the mobile screen, and now we just need to create this blurred area. So remember how I told you that we need to use the original video as a background in the blurred parts, so this down here and up here isn't just black? Well, this means we'll have to take this video and just put it in so it fills the entire screen, and then probably do something like crop off the wrist. So down here, I can go ahead and say scale for background, which will be equal to the maximum between target width divided by image.shape1, and then target height divided by image.shape0. So the reason we are doing this with a max is that we want to ensure that the background image is scaled up to fully cover both the target width and the height. So this prevents any empty black borders whenever we crop the final vertical frame size, or crop to the final vertical frame size. So let's say we had this right here, and it was only this tall right here. Well, then it would obviously cover the width. As you see, it is wider than the mobile screen is, but it is not as tall as the mobile up here. So we would have a black bar up here, and that is obviously not what we want. So we would like to just make sure that we use the dimension that is the largest one, so we can fill out the entire mobile screen. So that is why we use max. Next, we can determine the actual background width. That is going to be integer image.shape1 multiplied by scale for background, and for the background heights, like this, background heights, we're going to have the first dimension in this array, first index, and then also multiplied by scale for background. So now we have the background width and height, and we can go ahead and actually resize the image for the blurred background. So I'll say blurred background is equal to cv2.resize the image to the background width and also the background height. So you see how we have this single frame up here. So we have this single image, and we need to do two things with it. We first need to create the frame that we resize. So that is the first thing we do with the first three lines right here. And then we also need to create another frame we use as the blurred background. So that is the second thing we do right here. And then also on this line, of course. And then now that we have resized the image so it fits into the screen right here, we can go ahead and blur it. So what I'll do is say blurred background is equal to cv2.Gaussian blur, and I'll pass in the blurred background again, and then I'll pass in some parameters used for the blurring. So it is called kernel size. So depending on the values you put in, the final blurred result will look different. So I'll put in 1:1 and 1:1, and this is for probably the x-axis and the y-axis, so it'll blur differently on those axes as far as I remember. I might be wrong. And then I'll also put in a 0 for sigma x. So this will just blur the background in a specific way. If you would like to change the blur and how it looks, try and play around with these different parameters just to see how it looks, to find something that you like. We can now define the cropping region, so the top left corner of the cropping for region of size, target width, and target height from the blurred background image. So I'll say crop x is equal to background width minus target width, like this. And I'll then do a division where I also round up by 2. And this actually rounds down. It doesn't round up because it is flawed division. And we'll then just copy this line and call this crop y, background width minus target height instead. So the background width and also, this mistake, I'll just say height. So the background width and also the background height are the dimensions of the blurred background. So subtracting the target width and also the target height from the background size and then dividing by 2 send us the crop window. So what we can then do is say blurred background is equal to, and then we'll actually go ahead and crop the blurred background now. So I'll say blurred background, and then first I'll say we'll crop from crop y to crop y plus the target height. And what we'll then do is also crop from crop x to crop x plus target width, like this. So now that we have the blurred image, so that is the background right here, we'll need to take this resized image and then put it onto the blurred background. So that is what we'll do now. So first I'll check if resized height is less than or equal to target height. If that is the case, we'll need to calculate the vertical offset, so that what the offset will need to center the resized image within the target frame. So we can go ahead and say center y, and then that is equal to target height minus resized height. And then I can go ahead and say floor division by 2. This is spelled wrong, by the way. It needs to be height like that. So I'll just go ahead and fix that, the places where we misspelled that. Another thing I just noticed as well is that we can just go ahead and remove this if statement, because since we're always clipping podcasts that are normal YouTube videos, so they're always wider than they're tall, we won't really run into a case where the resized height is smaller than the target height. So I'll just go ahead and remove this again. And then now that we have the blurred background, we can just, now that we have the new blurred background with the resized image written onto it, we can go ahead and write that to our video. So to do this, we'll say vout.write, and then we'll just write the blurred background. So that was the resize mode. The next mode is going to be the crop mode. So that is where we crop to the speaker like this. So we'll then have to find the score the face with the highest score and then crop to that specific speaker. So I'll say elif, so else if mode is equal to crop. And in that case, we'll then just first of all calculate the scale to fit the height as well. So I'll go ahead and say scale is equal to target height divided by image dot shape. And we'll then just take 0, so the height dimension of the image. Then we can say resized image is going to be equal, I'll just call the image, is going to be equal to cv2.resize. And I would like to resize the image, and then I'll put in none right here. And then I can say fx is equal to scale, fy is equal to scale, and interpolation is equal to cv2.interarea, like this. So let's go back in here. So what we are working with is that, let's say we have a video that is, let me just scale it, that is this small, for example. Then as you can see, it is actually smaller than the mobile screen. So what we'll do is that we'll scale it up, or we'll find out the factor between how tall this image right here is, and then this image right here is, that is the result. So that is some kind of factor we'll need to calculate to be able to scale this image all the way up till it fits this size right there. So we'll need to calculate that scale. So if the image right here, the original image, is smaller than the mobile view, then we'll scale it up. But if it is larger than the mobile view, then we'll go ahead and scale it down. So that is basically what we're doing here. So instead of passing in the desired size, we pass in none, and then we just pass in the scaling factor right here to scale the image up or down based on the factor between how large the target height is and how large the original image size is. So after resizing the image right here, we can go ahead and say frame width is equal to resized image like this, dot shape, and then we'll put in a 1. Then I'll center this on the face, so I'll say center x is equal to an integer, and then we can say max score face, put in an x to get the x value out, multiply that by the scale. So in case the image is larger than it should be, we'll just scale it down, or in the opposite way, scale it up. And then I'll say if max score face, else frame width, and then we'll just do a floor division by 2. So if for some reason this max score face shouldn't be there, and it should be because otherwise we would actually hit this resize right here. Well, anyways, if it should be there, then we'll just crop to the middle of the frame, but it should always be there. So we can also say top x, and let me just go through one thing first. The reason that let me just remove this arrow. The reason we are only calculating the center x, so that is the desired x position of the crop, is that, as you can see, we can only really adjust where the x position of the crop is, because the height will always just match the height of the original image, or at least we scale it so they do match. So the only thing we can actually do is just figure out what the center x crop position should be. So that is why we only calculate that, and not also a center y. And then the top x right here is going to be the actual starting x coordinate, so the left edge of the final target with crop. So if I just go back here, let's say we just put this in like this, then the center x would be an x value that would be right here, whereas the top x would be the x value right here. This means that we can crop from here to here, so this will be the crop area. So that is just the difference between those two variables that you'll see now. So top x can be calculated from max, and I'll also put in a minimum, center x minus the target width, floor divided by 2, and then I'll also put in the frame width minus target width, and I'll put in, let me just make this correct, and then I'll put in 0 right here. So what this does is that it ensures that we don't go over the right edge of the image, and also that we don't go start before the left part of the image. So with max right here, for example, we check whether the start position calculated here is less than 0, and if it is less than 0, then we just set it to 0. We also check if the center that we crop to is more than the actual right side, and then if it is that, we just make sure that we don't go over the right edge of the image. So with this calculated as well, now we can go ahead and actually crop this image. So we'll say image cropped is equal to resized image, like this, and then we'll crop from 0 to target heights, and then we'll also say top x to top x plus target width. So this will crop the height, and this will then crop the width. And then just to clarify, the height right here isn't actually being cropped. It is just taking the full height of the resized image, which was already scaled to match the target height. So the only cropping that actually happens is right here, where we crop the width, because as you see, the width right here is way smaller than the width in the original image. So we need to crop away both this part and also this part. Cool. So now that we have the cropped image, we can go ahead and write that cropped image. So I'll say vout.write, and then I'll write the image cropped right here. And then we should be able to write both in crop mode and also in resize mode. So I'll just hop outside this loop, looping for all the frames. So after all of that has been done, we can then say if vout, then we'll say vout.release like this. So now that we have a video that has been written, we can go ahead and just combine that video with the audio. So scrolling up, as you can see, we have the audio path right here, which is the audio path for the audio that matches this specific segment that we create with the vertical video. So we can say FFMPEG command is equal to, and I'll put in a formatted string, FFMPEG-y -input, and then we'll put in the temporary video path. And then we'll also say .input audio path. On the next line, we can put in some flags that we need. So first I'll say -cv. So this will just set a video codec, and we'll set it to H264. So we'll go ahead and do this. And then I can say -preset fast to just prioritize fast encoding speed. Then we can say -crf23. This is going to be the flag that controls the video quality. So 23 is apparently a good balance. And then I can say -c:(a). So this sets the audio codec, and we'll set it to AAC. Lastly, I can put in a flag -b:(a). This will set the audio bitrate, and we'll set it to 128 kilobyte per second. And then I'll just put in one more line, and that is going to be the output path. Just remember to put in a spacing right here though. So the audio path is going to be, the output path is going to be this one right here. And the output will then have both the video and also the audio merged onto the video. Now we can go ahead and say subprocess.run, put in the FFmpeg command, as well as shell to run it in the shell. I'll then also put in check is equal to true. And I'll also put in text is equal to true. Great. So now we should be able to actually run this and then have a vertical video created. So I'll just try and take this video, create vertical video, hop down to under here. And then what we can do is just test it out before we create the subtitle logic, just to make sure it works. So what we're going to do is do what we would have done anyways, which is to upload the video to an S3 bucket. So I'll say S3 client. And remember, this is after having created the vertical video. So S3 client is equal to boto3.client. And then I'll pass in S3 to create a new client of that. Then I'll say S3 client dot upload file. And we'd like to upload the file that is the vertical MP4 path, so the output path. And we'll upload it to the bucket over here. So let me just find where we did this last time. So we can just copy that. We'll take that right there. And that is the bucket we're uploading to. And then the output key is going to just be the output S3 key for this specific clip. So that is going to be, this one up here. So we have the directory. So that is where we have the original video clip. And then we call this new S3 key the clip name. So that is going to be clip1, for example, .mp4. So now if I just go into process clip and set this to 1. And remember, this is how many clips we want to process. I don't know, I just want to process one clip just to test it out. So that is why I set it to 1 for now. And then we should be able to open up the terminal and then run modal run main.py. And then at the same time, if we just hop into AWS over here, so AWS, we should then be able to see the clips appear whenever this script has finished running. So let me just see the status of it over here. So I'll just come back whenever this has finished running and we have some output. So I ran the code, and then after it finished, I got this error right here with the FFmpeg command not being able to successfully process. So what I found out was the problem was that I had 2 dashes up here in front of the S in this line 171. So I'll just go ahead and remove one of these, and then that should fix the error. And then the next thing that happened was that I ran it again, and then I got yet another error. So we'll just go ahead and fix that just so you don't have to run it. So I got this G down error. Too many users has viewed or downloaded this file recently. So we might still be able to access this file from the browser, it says. So what the error is actually about is that inside this init, it automatically tries to download a model file for us. And it does this every time actually we run the script. So it uses G down and run this command to download the file. Instead, I think we should just go ahead and copy this and just download it once and for all. And just include that in the Docker image, just to bake it into the Docker image such that it is always available. And this way we don't have to depend on G down every time to work. So hopefully we don't get these errors anymore. Alright, so up here we can see that the file has downloaded, and here over in my downloads folder we can go ahead and just copy the file. And then in here I can see that the model should have been placed in Modal Face Detector S3FD. So if I hop under Active Speaker Detection, and then I go under Model Face Detector S3FD, we should just paste in this file that we just copied right there. And now we have the model file available locally as well. So whenever we do run this code here again, it should not download the file, but it should rebuild a part of the Docker image, so this image right here, because we did change a file within this directory. So this step right here should then rebuild in the Docker container. So it might take a little longer for this next command to run, but hopefully that will fix our error. So I just ran this down here, and we just have a small spelling error we'll need to fix first. So up we run the Columbia command. I can see that we forgot to put in this spacing right here. So this means that this entire thing, both this and this, would become one part of the string in the arguments. This means that this would then be interpreted as a flag itself, which it isn't. This is really just a value for a flag. So I'll just encourage you to go ahead and fix this if you haven't seen it already, then save it again. And then if you run it again, you should be able to get something out of it whenever it finishes. Alright, so we just have another error down here, which I just checked out. So what the error is that if you scroll all the way up to over here, it says that the Columbia script did complete, but it probably didn't complete since we got an error up here. So we have an error right here at np.int. So it says np.int was a deprecated alias for the built-in integer. So what we can do is find out the file that it happened in. So it is box utils. So I'll just go into box utils, and luckily we have the ASD repository cloned down to our local computer or to our local repository, and then we copy it in. So this means we can also actually change the files within this ASD repository, and then have it just be reflected in the Docker container. So we'll go into box utils and then just fix this error, and then when we run it again, the new version should be copied into the Docker container and then hopefully fix our error. So down here at s.type, let me just find it. It is this line specifically, and there's only one of those. We'll need to use int instead of np.int because np.int was deprecated. So we'll go ahead and save this and then just press up and run this again. And then let's see if it works this time. And then the next error is an error with tqdm, I can see. So we meant to call this, but it actually called this. So going back into main.py, if we just find tqdm, instead of importing tqdm and then down here saying tqdm, we'll need to say from tqdm import tqdm, and that should fix that error. I'll just run it again quickly. Alright, so it finished running, and this is the output right here. So we get an error, but it is still not filling as much as we thought it would. So going over here, we can see that we have this cleaning up temporary directory. So going down to that, we can see that it tries to concatenate a string with a path. So this path right here is a path, and we try to concatenate that with a normal string. So instead of having this normal string, we'll just take this and insert it as a formatted string. This means it'll automatically call the toString method that is defined within this path class right here. And then that way we'll be able to insert the path into the string without this error right here. So I'll go ahead and just take that. And then if we scroll up, we can see that the clip was actually created, and this is an error that happened later on. So this is what happens after processing the clip. So the clip should then be accessible in here in our S3 bucket. So what you can do is refresh right here, then you should be able to see the clip. Go ahead and press download, and then I'll just show you how the clip looks on my screen. So this is the clip that was just downloaded, so let me just try and play it.
Was there much discipline in the boarding school then for you to then have purpose?
1 year to go.
So you see he asked a question, so it identified a moment correctly with a question being asked, so that is pretty nice to know. Then you can see that the cropping also follows the face, and that is because we crop on a per frame basis. We also have a period where no speaking face is detected, so that is why we see the resize mode right here. So with the resize mode, we see the actual video in the background that is blurred, and we see the resized video right here in the middle. And then we also are able to see that it works throughout the video, so that is great to know. So now that we know that works, we can go ahead and just fix this last error. So luckily this is just an error in the end, so we put in this fix, and then we should be able to go ahead and run it again. So I'll just do that. So it just finished running, and this is the result. We see that there are no errors now. So scrolling all the way up, we can just take a look at what happened. It loads the models up here, then it finds the moments, and then we obviously only take the first moment because that is what we slice away right there. Then on going down, we can then see that it starts processing the clip. So it runs the Columbia command where it does face detection, face tracking. Then going down, the Columbia script completed in 25 seconds. Then it creates the vertical video and shows us a progress bar. This comes from TQDM, which we implemented before. So this progress bar right here with TQDM is what you see right there. Cool. Going down, it probably combines the audio with the video right here. And then all the way down, we can see that it took 30 seconds to create clip 0, and then it cleans up the directory and then deletes the folder with all of the temporary files. And then lastly, we have a 200 OK, which means everything succeeded like it was supposed to do. So with this done, we can go ahead and take a look at the subtitles, which is going to be the next part after having created this vertical video right here. So to get started with the subtitles, what I'll first do is scroll up and then create a new function. We'll do this outside the class as well. I'll do it right under create vertical video. I'll call this create subtitles with FFmpeg. I would like to pass in the transcript right there for the segments, which will be a list, clip starts, a float, clip end as well, which is also a float, as well as the clip video path. That'll be a string of course, and then the output path, which will also be a string. And lastly, the max amount of words we would like to show per subtitle when the subtitles are shown. This will just be an integer, and we'll set a default value to 5 for that. And then inside this function, we can first of all define a path for a subtitle file. So what we'll do is we'll create a subtitle file. This is going to be something like temporary subtitles.ass, and then this will be placed inside the same folder as the output path right here. So to just get that folder, what we'll do is just say temporary directory is equal to os.path.directory name, pass in the output path. Right beneath this, we can say subtitle path is equal to os.path.join. And then I would like to join together the temporary directory with temporary subtitles.ass, just like we discussed. And then what we can then do is find all the subtitles that belong within this clip. So the transcript segments up here just consist of a bunch of words with their start and end times. So right now, if we have a clip that maybe is 10 minutes long, then we clip this down. Also, we have a video that might be 10 minutes long, and then we clip that down to a 30-second long video. Well, a 30-second long clip. Well, in that case, we would like to remove all of the words and their timestamps that are outside of this 30-second clip. So what we can do to do that is just fill out the segments. So I'll say clip segments is equal to segment for segment in transcript segments if segment.get start is not none. And then I'll just say and, let me just copy this line right here, and segment.get end is not none. I'll just copy this line, and then I'll say and segment.get let me just do end again, is larger than the clip start. So now we'll just filter for the start and end times. So I'll just go ahead and copy this line, and then we'll just do the same just for the start as well. So less than clip end. So first we'll check if these properties even exists within this segment right here. And then if they do, we then check whether the end is within clip start and start is, we check if both end and start is within the boundaries right here. So we can fill out everything that is not inside the boundaries. And then after this, what we can do is we can group words into chunks of max words. And to do this, first I would like to create subtitles, which is going to be just an array of different chunks. And then this will then be an array of start times, end times, and also the text for the subtitle, and this will be tuples. We'll also have current words. This will be the words we're currently appending to an array in the current chunk. So we'll append 5 words at a time, for example. Then when this is filled up with 5 different words, then we append this along with the start and end time to the subtitles array up here that contains the full subtitles for the clip. So we'll also just need a current start, which will just be none for now, and a current end. And then below this, we can say for segment in clip segments. We'll then first say word is equal to segment.get, and we'll just get the word or nothing if it isn't there. Then we can just say .strip just to make sure that it is a clean string. Then we can get the segment start. So I'll say segment start is equal to segment.get start, and we'll just do the exact same just for the end. So segment end, and this will just then be end instead. Then we can say if not word or segment start is none, or segment end is none, like this. Then we'll just continue. This shouldn't be the case, but we'll just put in this guard statement just to make sure that it does not happen. What we can then do is to make the start and end relative to the actual clip segment or clip in the original video. So for example, if a clip starts 10 seconds into one of the longer videos, well then we'll need to shift all the words that we need to show in the subtitles 10 seconds back. And this way the words in the subtitles can become relative to the clip and not relative to the timestamps in the original video. So that is why we shift them. So I'll then say start relative is equal to max 0.0 sequence start minus, and it's segment, not sequence, segment start right there. And then I'll say minus clip start like this. So we'll take the difference between these, which will make the times relative. I'll just copy this line and call this end relative. And then this will be sequence, or sorry, segment end. We can then check if a word ends before or exactly at the start of the current clip. So what we'll do is just say if end relative is smaller than or equal to 0, then we'll just continue and skip that word. Otherwise, what we'll do is start a new group. So first, if not current words, so if no group has currently been created yet up here, then we'll just create a new one. So what we'll do is first of all say current start is equal to start relative, current end is equal to end relative, and current words is equal to a new list of words. So we'll just use this as the first value in the list, so the word from that we're currently at. And then we can say else if length of current words is larger than or equal to max words. So remember, we only want to make our group 5 words long, so we only want to show 5 subtitles at a time. So we'll chunk it into arrays of 5. So I'll go ahead and say max word. Will probably need to be max words though, like that. And then down here, max words. Then we'll say subtitles dot append, and then we'll append a tuple with the current start, the current end, as well as the current words, which we'll join together by spaces for the subtitles. So we'll do space dot join current words. And remember right now the words are just words in a array like this. So we'll just make a string instead, and then join the words together with a space between each word. After this, what we can then do is say start new group. So current words is going to be this new word, current start is going to be start relative. Current end is going to be end relative. And then we can say else current words dot append word, and current end is equal to end relative. So the first statement up here is for the very first word of a new subtitle. So whenever a new word is supposed to be put within a subtitle, we'll start up a new chunk, and then we'll set the current start, current end, and also create the chunk right here. And then for the second statement right here, this condition is met when the current subtitle line has reached the maximum allowed number of words, so the max words up here. And then what we'll do is we'll add it to the we'll add the chunk to the subtitles array, and then we'll do the exact same as we did up here, where we just start up a new chunk again. And then down here, this last statement is met if the array is, or if the current chunk is not empty, but at the same time it is not full. So we'll just append a new word, and then just change the end relative, because the last word should then be the end relative timestamp, meaning that we'll show the subtitle up until the point where the end timestamp for the last word is there. And then one more thing we need to do is that, as you see right here, we only append the chunk to subtitles, which is done right here, if we hit the limit of max words. But in case that we run out of words when we are halfway through a chunk, those few words will then get lost because we won't append them to the subtitles array right there. So we'll just make sure we do not lose those words down here. So I'll just add the last group if it is not empty, but at the same time not full. So I'll say if current words, then we'll say subtitles.append, and then just do the exact same as we did up here. So I'll just go ahead and do this, and then that fix that problem with not losing words, because this statement right here is not hit. So under this, we can then create the ASS file. So I'll say subs is equal to pysubs2. So we'll need to import that .ssa file. So we'll do this, and then we can define the style for the subtitles. So first we'll say subs.info, and then we can say wrap style is equal to 0. So what this will do is it'll allow the subtitle renderer to break long lines of text, just so it looks nicer. Then we can just copy this line. So I'll copy it down, and then I'll say scaled border and shadow. And this will just be equal to yes. So what this will do is it'll scale the border and shadows that is going to be applied to the subtitles to the resolution of the player. So I'll just copy this line down again 2 times. The first one I'm going to call play resolution X. This will just be 1080. So what we are rendering the clip at. And then down here, it'll be play resolution Y. And this will be 1920. And I'll just copy this one more time and then put in script type and then set the version of the ASS renderer will use. This will be v4.00 plus, like this. And then we can define the actual styling for the subtitles down here. So I'll say style name is equal to defaults, and then new style is equal to pysubs2.ssa style, like this. And then we can say new style dot font name, and we'll use Anton, and Anton is the font we downloaded up here. So remember, we downloaded Anton down into our fonts and then refreshed the font cache. So just going down again, we can use that font. We can also set the font size. The font size will be set to 140. We can set the primary color. This will be set to pysubs2.color. And we'll just set this to white. And white is 255, 255, 255 in RGB colors. So the maximum value in all 3 channels. Then we can copy the line and say outline. Here for the outline we'll say 2.0. For the shadow we'll also say 2.0. And then we can also put in a shadow color. This will be pysubs2.color, and we'll put in 0, 0, 0, and then 128 like this. Right below this we'll put in alignment, so new style.alignment, which will be equal to 2. Below that we'll put in margin left. This will be equal to 50. We'll set this, copy this line 2 more times, and then put in margin right and margin vertical as well. And then lastly, we'll put in a spacing that is of 0.0. So this should style the subtitles, and then what you can do if you would like to change these is just figure out what styling options you have available with ASS format, and then you can change them if you want to, but these are just the ones I'm going to use. Next we can say subs.styles, style name is equal to new style, like that. And then we can add each subtitle line to the file up here, and then go ahead and save the file. And then as soon as we have saved the ASS file, we can use FFmpeg to render on the ASS file onto the clip of the vertical video. So I'll loop through the subtitle lines, so the chunks we made up here. So I'll say for I, and then we got a tuple out, which is start, end, and the text. In enumerates, and we'll enumerate the subtitles right there. Then we can say start time is equal to pysubs2 dot make time. S is equal to start. I'll just copy this line and call this end time. And then I can say start is equal to end right there. Then below this, I'll say line is equal to pysubs2 dot ssa events. We'll put in the start is equal to start time. We'll put in the end, which is equal to the end time. We'll put in the text, which is going to be just text like this, and the style is going to be style name. And then we can say subs dot events dot append, and we'll then append the line. And lastly, we can save the subtitles to an actual .ass file. So we'll say subs.save to subtitle path. And if we go up to the subtitle path, that is the ASS file we see right there. Cool. So now we should be able to take this ASS file, which we just created, and then render that with FFmpeg onto our vertical video. So I can say FFmpeg command is equal to a format of string, where we say FFmpeg -y and -i for input. We'll put in the clip video path followed by -vf, and then we can say backslash, and then we'll say ASS is equal to the subtitle path backslash again, and then we'll just put in this quote, and then remember to make a space here. And then I'll just hop down to the next line, put in a format of string, and then we'll say -c :v, and then H264, and I'll say preset fast CRF 23 output path, and then we should be able to go ahead and run this command. So I can say subprocess dot run FFmpeg command shell is equal to true, check is equal to true as well. We'll then just leave this as it is, and then we should be able to actually create these subtitles. So I'll just take this function declaration and then hop down to where we use it. So I'll just find create vertical video down here. So below create vertical video, we'll just put in the subtitles as well. And the parameters for this is going to be the transcript segments, the start time, the end time, the vertical MP4 path, the subtitle output path, and the max words, which is going to be 5, just so we have it defined here as well. And then if you would like to show maybe 10 words per subtitle, you can just switch this to 10, for example. So that is the idea behind it. And then right now we save the vertical MP4 path, so the vertical video without the subtitles. So we'll just need to change this to the subtitle output path instead, like that. And then we should see the video being rendered over here. So what I'll do is just delete this clip. So I'll press delete, copy this permanent delete right here, paste it in, say delete objects. And then when we run this again, we should be able to see the subtitles on the video as well. Okay, so before running this, I just want to make you aware that there are a couple of errors in the code that I just noticed when running this a second ago. So I'll just hop back into create subtitles with FFmpeg. And first of all, this segment start should be segment end, because we're calculating this just needs to be end right there, because we're calculating the end relative to the clip start, so it needs to be end, not start right here. And then this is also inside the loop right now, which it should not be. So we'll take this part of the code, including this part where we add the last chunk, and we'll just move this outside so it's not indented. So we'll move it one indent back, and this means that it won't be put inside the loop, because the problem is that if you move this inside the loop like it was, then it'll just run this FFmpeg command 1,000 times for every chunk. So this just is obviously totally wrong, so we'll not do that. So this should then work. So now we can try and go ahead and run it again. So I'll open up an integrated terminal, and then you can run the command, and then I'll come back when we have something to show you. It just finished up here, and as you can see, it finished without any errors. We just got a 200 OK, which is perfectly fine. So hopping back in here, if you click the reload sign, you should be able to see the clip that was generated, and then you can go ahead and download this clip. So I'll just press download, and then I can just play it for you. So this right here was the generated clip, and as you can see, there are subtitles down here. So when scrolling through the subtitles, we can see that they are shown. Let me just try and start the clip and see if they match.
I mean, if you were ever caught going down to the pub, that would certainly be a very, very...
So as you can see, the subtitles match what the speaker is saying, so that is great as well. So now we should be able to move on to the next part. So before actually deploying the API, what I would like to do is just make a small test where I give it a longer podcast first of all, and then also I'll make 3 clips instead of just 1. So over here I'll just say 3 clips, and then what I'll do is just give it a longer podcast. So right now we have a couple of different ones to choose from. We have this 30-minute one, and we also have the full one. So I'll just take the 30-minute one and upload it. So under the podcast clipper, I'll create a new folder, test2, create this folder right here, then upload the file. So I'll say add files, and then we can add the 30-minute version instead. Say upload. And then when this has been uploaded, we should be able to just reference the following S3 key. So it'll be test2, and then it should be this S3 key instead. So if I just press save right here, as soon as this is uploaded, we should be able to run the test. So now the upload has finished, so I'll just close right here, and we see that there are no clips. If I then just run this over here and come back when it is finished, we can then check out the end result. So it just finished executing, and we didn't get any errors. So what we can do is just hop in and see if we can figure out if you generate any clips. We got 3 clips right here. So let me just try and download each one of these. I'll say download. I might need to do it one at a time. So I'll download this one, and this one. And then what I'll do is just pull up the clips so you can check them out. So here are the 3 clips. Let me just start with the first one.
Was there much discipline in the boarding school then for you to then have?
So I think that was the question from the clip that we saw earlier on as well. Let me just see the next one.
What did you do after boarding school, David?
Yes, I went in.
That was another question as well, so that is correct too. Let me try the third one.
Why did you never go down the kind of same footsteps as your father, kind of military?
Eyesight, but also I was.
So that was a question as well. So it seems to be working just fine, so that is good for us. And then what I would like to do now is actually deploy the API. So I'll go ahead and say Modal, deploy, and then just press enter. I think I need to put in main.py. And then this should create a URL endpoint, so this one right here. So this endpoint is an endpoint which we can hit. And then if we hit this endpoint, we should be able to access this process video post endpoint. So we should be pretty much good to go with the backend now. One more thing I want to do first though is just hop into Modal. If we then just hop into our stopped apps, this one is live right here. I think we need to take this one, which we just ran a couple of minutes ago. Then we can check out the actual run. So this is an endpoint being called. So this is what happened whenever we ran Modal run main. So we can check how it looked. We can check how it looked in the cloud as well. So if I click this, we can see that it took, let me just see, it took 4.5 minutes. And then we can just check out the same logs, which we're able to see in our own logs. So let me just see how many clips it found, just to verify that that works, for example. So I just scrolled all the way up, so we can see that it found all of these clips right here. And then this is just the same list. And then we can see that it processes the clips individually. So we can say processing clip 0, and then it processed clip 1 after that. And then you can see how it renders out the video. And then it also processed the third clip, so clip 2 right here. So we can then also verify that it works in the cloud, and then we can see the logs and then use the logs for debugging. So that is really nice to know as well. So with your deployed app right here, you'll be able to see it. And then whenever you hit the endpoint, you should see these same logs as we just went through, but just for the live application. So now that we have deployed our backend, we can go ahead and get started with the frontend. So what I would like you to do is hop into Google, then search for the T3 stack. I'll then like you to pick installation, and then we'll just select this npm command. What I would like you to do is hop into a new window. In here we can open up a folder. This folder is going to be under my repositories, and then it will be the AI podcast clipper. I'll then open this up. Then I can open it up in an integrated terminal, paste in the command, and just let this run. And then we can call our project AI podcast clipper frontend like this. So AI podcast clip frontend, I'll just go ahead and save this. We'll pick TypeScript, Tailwind CSS yes, tRPC no, Next auth for authentication. I would like to use Prisma and the app router yes, and then I'll select SQLite yes right now, and then ESLint. I'll just say no to this, yes to npm install, and just press enter right here. And this should then set up our new project, and then also install the npm libraries that we have, or that is just coming with the project by default. So I'll just come back whenever this is done. So now the libraries have been installed, so we can go ahead and close down the terminal, and then just open up the frontend in a new window, or sorry, in a folder. So I'll open up right here, and then go to frontend and press open. And now we see the project being opened up. So we can first of all go ahead and try and run it. So I'll open up npm scripts down here. If you do not see this menu, you can right click and then press npm scripts right here. And then you should be able to see this menu as well. Then if you just click one of these, you should be able to hop into scripts. I usually just place def in the top because I use that the most, as well as Prisma DB Studio, and then also DB push. Those are the ones I use the most, so I usually just put those at the top. So I'll just go ahead and do that. And then we can click run right here. And then we get an error right away because we have invalid environment variables. So right now inside this env.js file, what happens with the T3 stack is that it defines the environment variables needed to be able to run the application. And we have an auth Discord ID and a secret for an example for signing in with Discord. We'll not need that. So I'll just go ahead and delete that, both there and also down here. And under environment, I'll also delete these two. And then if I search for auth, go under config, we should just delete this Discord provider as well. By doing these couple of steps and then pressing def down here again, we should then be able to run the application. So if you hop into localhost 3000, I'll just paste it in right there. We should be able to see our frontend running like we do right here. So there are two things I would like to do just right away. So if we hop down here and then copy this web endpoint, we can go into the front end and just find the .env file. In here, I'll put in a new value called process video endpoint. Like this is equal to, and then I'll insert the endpoint. I'll also just copy this name and then just call this endpoint auth. And this will then be 123, which is the key that we also use to verify the endpoint whenever we set it up in the secrets over here. So we have the secret, which we use to verify the endpoint with. So we'll just need the same value as we had right there, just in our environment file in the front end, so we can make sure in the back end that this is the front end actually calling it. Then what we can do is just hop into AWS, and then we can just find the bucket name again. So I have this bucket name, so I'll hop in here and then I'll just define that. So I'll say AWS, S3 bucket name is equal to the bucket name. I'll also just set my AWS region. So in my case, it is US East 1. And then we should also just set the access key ID for the IAM user. So right here we have this access key ID right there, which we'll set. And we also have this AWS secret access key. Both of these we will need to set. So what I'll do is just hop into my IAM users under AWS, find the user that we created before. So we can click users right there, hop into the user, create another access key, third-party service, application running outside AWS. Then I'll just say frontend, create the access key, copy in the key right there, and also the secret key right there. So this should allow us to be able to list files from the S3 bucket. So when we show the user his clips, and also when we want to upload clips to the S3 bucket when starting to process a video. So this should be enough to get us started with the front end. So what I would like to do is just order my tabs, and then we can get started with the front end now. So I'll just click continue here, and then go back into my code. Alright, I've just opened up my browser on the right side and then the code on the left side, so we can code and then follow along with what happens over here. So the first thing I would like to do is just go ahead and set up Inngest. So this is what will be the link between the front end and the backend. So remember how I told you about this queue where we have the backend over here, which we just set up right now, and then we have the front end where the user can upload right here. So we'll need to now set up this queue, so just so we can test that there is a link between the front end and the backend. And then we know that we can create videos from this Next.js front end. Then we can go ahead and build the front end around that logic. So we'll go ahead and set up Inngest first, which is what we'll use to set up the queue. You can just hop into their website with the link in the description. And I'll just go into the website right here. And then I'll say documentation, and then they have a quick start guide for Next.js. So we'll need to install Inngest like this. So I'll just copy the command, hop down, and then just paste it into the terminal. And then let me just see, we also need to run this command right here to run the Inngest server. So what I'll do is just add that command as a scripts command in here. This means that it just pops up under npm scripts automatically, so we don't need to type it in every time. So right under def, I'll put in this command right there from here. And then I'll say ingest def. And this means we have this command as well. And next, if we scroll down, we should be able to go ahead and create an Inngest client. I'll just start up the Inngest server actually. So it is running now, and we can just click this URL, and then it opens up the Inngest server right here. And then let me just see if we see anything. So right now we haven't really defined any functions or anything, so we might want to set that up before it works. So what I'll do is just go ahead and do that. So hopping in here, if I scroll down, we can create an Inngest client. So we see we have a folder right here that says source ingest. So what I'll do is just hop in under source, and then create a new folder called ingest. Under here I'll create a client.ts, paste in this code, and the app will just be called AI podcast Clipper frontend, like that. So I'll go ahead and save that, and then we'll need to create this route as well. So under source app API, and then we'll just create a new folder here called ingest. Under this we'll create a route.ts, and I'll just paste in this code right here. And then we need to just create the function which we can pass in to this array. So under source ingest and functions, we'll create a function. So under source ingest functions right here. I'll just rename this functions.ts. I'll paste in the code. So now we have a function. I would like to rename this function a little bit though, so this should be called process video. So whenever a user has uploaded a video, he can call, the program will call this process video function from the queue, which will then call our backend. So this is going to be the function that is triggered from the queue. So going back to IntelliDraw, this is this ingest function we're defining right now, and then the queue we are creating is going to be containing events, and these events are then called process video events. So I'll just call it this, and then what I'll do is just leave this as it is. Then I'll just restart both of these servers, go down, start the Inngest and also the Next.js server, and let's see if we get any connections between those. So now we see we get a get API ingest 200. So the Next.js can find the ingest server now, which is great for us. If I refresh over here, we can see under apps error, no functions are registered within our app. So we'll just need to take this function, I'll call it process video, and paste it in under the, I think it's route right here, under functions. So we'll just need to import that. And then when I save, we can see that the function was auto detected. And then what we can actually do is we can go ahead and run the function if we would like to. So you can say invoke, then pass some data to this function that is then accessible through this event. And this way we can test whether we have a connection between the Next.js frontend and then also the Next.js application and then the Modal backend. So this function can be divided into multiple steps. And what I would like to do first is just create a step. So I'll just remove this return and then I'll say awaits step dot and then run. And this should then be called call modal endpoint like this. This will be an async function. And then inside this function, I'll just do a fetch to the Modal backend. So I'll say awaits fetch env, and we can say env down here. And then we'll just need to define these environment variables which we created. So inside this environment variables file, we have these created, but they aren't really type safe. But in the T3 stack, we can access our variables in a type safe way through this env that we can import from this path right here. So we'll just need to define them inside this file right here. So I'll just open up the environment variables over here and then the definitions, I'll open up the environment variables over here and the definitions right here. So first I'll create one for the AWS access key. This will just be a normal string. And we'll just need to say set.string, and then I'll copy this down, create one for the secret key, I'll create one for the region, and I'll create one for the bucket name, as well as the endpoint and the authentication string. Then we just need to set these down here. So by defining them up here, it means that we can access them on the server, and down here we can access the variables on the client. So we will just need to be able to access these on the server because we don't really want to leak any of these secret variables to the client in the Next.js application. So that's why we define them up here under server. Good. So hopping down, we can just define these again. So I'll just copy these down right here. And then we can assign the specific variables to these definitions. So I'll just paste this in and do that a couple of times. I'll just drag this back actually. So I'll do this. And just for each line. And then for this access key, I can put it in. For the secret key, I'll put that in as well. For the region, I'll put that in. And for the bucket name, for the endpoint, and for the authentication. Good. And now we should be able to access our environment variables. So hopping into functions again, we can say env dot, and then we can fetch the modal endpoint. So that is going to be the process video endpoint. And then we'll pass in this dictionary about what we would like as the options. So the method should be a post request as we defined in Modal. The body of the request is going to be json.stringify. We would like to stringify the S3 key, which is the input for the method. So this will just be something like S3 key. We'll just hard code this for now. So if I hop into the AWS dashboard and then we just go to S3, we can just use the test one again. So down here under AI podcast clipper, we can take this test one and just delete the clip. So I'll delete that and then permanently delete right here as well. Then the S3 key is going to be something like test1 / and then the file name right there. And then one thing I would like to do, because we don't want to wait too many minutes on this testing. So one thing I would like to do is just make sure we only process one clip at a time every time we test. So I'll just do this and redeploy again. So this means that we'll redeploy the endpoint. It took only 2.5 seconds. So as you see, it's pretty nice to work with the Modal because we can just deploy the endpoint this fast. So this should be enough actually to call the endpoint. We just need to pass in one more thing though, and that is the headers. So the headers is going to contain the content type, which will be application JSON, and we'll also need to pass in authorization, which will be bearer, and then we're going to put in env dot process video endpoint auth. So it is actually the exact same method that we called the endpoint with as we did down here when we were testing. So we pass in the body right here, and then we also pass in the headers with the two following properties. And this should be enough to test out the endpoint. So what I'll do is just save this right here, hop into the Inngest Inngest dashboard. Let me just find it, it's right there. Inside here, let me just refresh. We can then say invoke, and then I'll invoke the function, and then we can just see what happens. So let me just see if we can see any runs in the Modal dashboard. So right now we have a pending processing video, and that is a good sign that our endpoint right here was invoked by the ingest function. So if I just refresh again, I'll just wait for this to get another status, and then I'll just see what happens. Okay, so now it is running. So we see that we successfully invoked this endpoint with the function. So I'll just wait for this to finish, and then we can check out if it succeeds or not. And while it is still running, I'll just want to show you one thing as well. So over here in the Inngest dashboard, we can see that the function is running as well. So we can see how long the different steps take. So this step right here called Modal endpoint is the step that is currently running. And now it's just finished, and then we can see the entire function finished with all the steps inside of it. This means that it should always also be finished over here, and I've created the clip it should create. So if I just hop into the bucket again, we should be able to see the actual clip now. So we see the created clip, so everything works between the front end and the back end. So what happens behind the scenes here with Inngest is that there is a queue being created for us. So just like you see this queue right here, this queue is automatically created in the background. And whenever we send an event whenever we send an event in Inngest that is called this right here, we'll insert an element into the queue that is created in the background. And when these queue items are then consumed, what will happen is that it'll call this function which we have just defined, process video. So that is basically what happens. And I also talked a little bit about concurrency and throttling, etc. So these options we can easily define up here. So if I hop into the Inngest tutorial right there, we should be able to go down to something like flow control and then see throttling. So we are going to use concurrency. So concurrency will allow us to set only one function being ran at a time. So if I just say concurrency right there and then paste it in right after ID, I should be able to set this to 1. So this is just the most basic form of concurrency where only one of these functions can run at a time. But we would like it to be a little bit more specific, because if there are multiple users in the system and only one of these can run at a time, users will have to wait for a lot of time. So what we'll do is we'll set that only one of these functions can be run at a time, but it will be per user. So we'll specify a key as well, and this key will be events.data.user_ID. So this event right here will contain a data. So in here, when we press the invoke function right there, you can see that we passed in this data dictionary. So this data dictionary allows us to put information into queue items, which is then received by this function. So we can then say that this data dictionary should contain a user ID, and then for each user, we'll then limit their concurrency to one function run at a time. And then if you hop back in here, if you would like to limit your users in other ways, such as them being throttled, for example. So this means how many functions they can start per time period or within a time period. You can also do this. You can just check out the different options right here if you would like to limit your users, but we're just going to use concurrency just to make sure that we don't let the users create 10 videos at a time and just completely spam the system. So before moving on with the implementation of the process video right here, I would like to just go in and define the data structure which we're going to use in the system. So in the T3 stack, you can scroll up and then there is a folder called Prisma. Inside of here, there is a schema.prisma. So right now we defined whenever we ran the npx prisma install command that we wanted to use SQLite. So there should be a local SQLite database inside this repository somewhere. I do not know exactly where it is right now, but we'll just scroll up. All I wanted to know is that the database schema is defined within this schema.prisma. So in here, there is a database URL pointing to where the database actually is. And then there are the different tables. So there is a post table, account table, session, user, verification token right now. So right now, I would like to extend the user a little bit and then also create the other tables which we'll need to go ahead and use the system. So the first thing I would like to do is give a user a password. So right under email right here, you can see, or you can actually just look at the table and see that a user can't really have a password, they only have an email. So I would like to just add a column in the database called password. So I'll say password, and that is supposed to be a string. And then when you put in a question mark like this, it is an optional column, meaning it can be null. If you put in a no question mark, it means you'll have to define this whenever you create a row in the user table. So the password was the first thing. The next thing I would like to define is going to be the credits. So users need to be able to have credits, which we can deduct whenever we create a video. I'll just call this an integer, so it's just a whole number. And I'll set the default value of this field whenever we create the user table or user row, to 3. So whenever a user signs up, he'll have 3 credits automatically per default. I'll actually just set this to 10 just so the user has a little bit more to play around with. Then we can also set a Stripe custom ID. So going into the Excalibur, if we scroll over here to the Stripe flow, we'll remember how I said that we'll sign up users in Stripe as customers when they do create an account. Well, we'll need to store this Stripe ID, which we'll get back from Stripe whenever we create this account, and we'll create a column for this. So this will set to be a string. It is optional because it is set after the user has been created. And it should also be unique, meaning 2 rows in this table shouldn't be able to have the same value for the Stripe custom ID column. I'll then go ahead and define 2 new tables. So down here, I would like to create, first of all, a table called uploaded file. So an uploaded file should just be an original video, and then it should contain the S3 key to that original video in the S3 bucket. So that is the first model. And then I also later on want a table called clip, and this table should then store the references to all the clips that has been generated by the Modal backend. So the uploaded file first should have an ID. This should just be a string, and I'll set this to ID, and I'll say the default value should just be a CUID, just a random UUID that is generated. We would like a column for the S3 key that is also a string, like this. Then I also want a display name for the file. This should just be a string with a question mark, so it's optional. Then I would like to give it an uploaded status. So this should be a boolean, so it can be true or false, it can be uploaded or not. And the default value should be false. Then I would also like to give it a status, which we can show the user in the front end. So I'll say status, this should be a string, so we can set it ourselves. And I'll then say default value should just be queued. And then as time progresses, it'll then be processing. It'll be processed. It can also be no credits, for example. If this function was hit and then we found out the user has no credits, then we'll just stop executing the function and say no credits. And then the user can see that this video was not processed because the user had no credits. So after this, we would like to also put in a created at field. That is a date time. That is a default now. And I would also like to put in an updated at, which is also a date time. And we'll set that to updated at down here in case we need it. And we'll then create a relation between a user and an uploaded file. So every user can have multiple uploaded files, but one uploaded file can only belong to one user. So it is a one-to-many relationship between the user and then the uploaded files. So going down here, I'll just say up here, I'll just say uploaded files, and then I'll create a reference to uploaded file, make that an array. This means that a user can have multiple uploaded files. And then we'll just create a relation back to the user. So the way we'll do this is by saying user. This will be a relation, fields, and then we'll say user ID, and this will just create right below. So we'll create a column called user ID, which is a string. This column right here will store the ID of the user that it belongs to. So we can, after this, say references ID, and then on delete cascade. This means that when a user is created, all his uploaded files are also created, so we don't keep storing uploaded files in case the user deletes his account. So that was the uploaded file. The next thing is going to be a clip. So a user can upload a file, then clips are created, and then when the clips has been created, we'll then also create records in the database for each clip that has been created. So an uploaded file should be able to have a one-to-many relationship to clips, because one uploaded file can have 1, 0, 1 or more uploaded clips, or not uploaded clips, generated clips. And then we'll also like to create a relationship between the user and then these clips, because a user also owns these clips. So each user can also own multiple clips, but a clip can only be owned by one user. So going down here, I'll say model and then clip. I'll give it an ID just like we did up here. Then I'll give it an S3 key, because a clip is just a file in an S3 bucket. So this would be the S3 key. So test1 / this name right here for this specific clip. Let me just go back here. So an S3 key just needs to be a string as well. We'll give it a created at and an updated at. So we'll just copy these two. Below this, we'll give it a relationship to an uploaded file. So I'll say uploaded file, and this should be just optional for now. And I'll say relation fields uploaded file. So we'll need to create an ID. So uploaded file ID string. So I'll say uploaded file ID up here. Then I can say references the ID from this uploaded file ID up here. And then I'll also put in on delete cascade. This means that if an uploaded file is deleted, all the clips related to that will also be deleted. And then I think we just need to spell this correctly, like that. And then up in the uploaded file, we can go ahead and say clips, and this will be of type clip in array, which means we have a one-to-many relationship between the clips and the uploaded files. I'll just go ahead and create a user relationship, a one-to-many relationship between the user and the clips as well. So I'll hop up to right here, and then I'll say clips. This will then be clip like this. What I'll then just do is just create an index for both the uploaded file and the clip. So I'll say add index, and I would like to use the index S3 key. This means that when we look up an uploaded file row with the S3 key as the identifier, these will be faster because they have been indexed. So I'll create one for each of these. Then I'll say db push. So now we have this db.sqlite file right here, and you can see in here that it is defined as being in the current folder. So this script is probably run from this Prisma folder right here. So that is why it's being generated inside the Prisma folder. So now we have a database with the schema which we just defined, and we should then be able to go ahead and continue creating this functions.ts file. Cool. So what I'll just do up here in the function is also just define something called retries. This means that if one of these independent steps down here in the function fails, then it'll be able to retry up to 2 times. So if you put in 0, it'll be able to retry 1 time. If you put in 1, it'll be able to retry 2 times. So I just don't want it to be able to retry 4 times, which is the default, I think. I'll just keep it to 1 for now. So what I would like this queue to contain is the IDs of the uploaded files. So going into the Excel drawer, actually, going into our queue, each of these I would like to contain the ID of the uploaded file. So just an ID pointing to a database, a row, a database record with an uploaded file. So the user uploads a file, and then let me just hop in here. So when a user uploads a file, one of these records right here is created, and then we'll have an ID. So we can both use this ID to get the uploaded file's S3 key, and then call the Modal function with this S3 key. And we can also get out some information about the user because we have a relation to the user, and then we can check the user's credits, for example. So just know that each one of these queue elements contains a message with a ID pointing to the uploaded file. So I would also expect in here, inside this function, that we can get this out from the event. So what I can do is say const uploaded file ID is equal to events.data, and then we should have the uploaded file ID that is being contained within this event right here. Cool. So the first thing I would like to do is check the user's credits. So I'll say awaits step.run. This step should be called check credits, and it should be an async function. So I'll say async, do this, and then we'll go ahead and query the database. So I'll say const uploaded file is equal to await database, which we can import like this. Then we can say dot uploaded file dot find unique or throw, because if we pass in an ID that doesn't match with anything, there's obviously an error in the program that should never happen. So we'll just throw an error right here so we know. So I would like to find this uploaded file where the ID from the event matches the ID from the database in here. So I'll say ID matches uploaded file ID. And then we can select some data from the database in this row we just found. So I'll select, first of all, through the user relation, the user's ID, and also the user's credit amounts. So credits, true as well. We'll just need to wrap the user in a select to. Wrap these statements in a select to. So apart from selecting the user's ID and credits, I would also like to select the S3 key from this uploaded file. So what happens is that we try and look for a row inside this table right here. When we find a row, we select this S3 key for the specific uploaded file, but we also take a look at the user here, and then we hop up to the user that is related, and then we take out the user's ID and also the user's amounts of credits right here. This allows us to do two things at once instead of doing both a query to the user and also a query to the uploaded file. So in here we should have both the user ID, credits, and also the S3 key, and we do have that, so that is great. So below this we can say return user ID, and this will be uploaded file ID. Uploaded file dot user dot ID. We also want to pass back the credits, which will be uploaded file dot user dot credits. I also want to pass back the S3 key, which will be uploaded file dot S3 key like this. So let me just make this a little bit easier to see. So we have this step right here that gets these three things and returns them from this step. So the next things that happen down here should only happen if the user has more than 0 credits. So I'll say const and then just destructure the return statement. So user ID, credits, S3 key. And then we can decide to only run this code right here if the user ID, if the user credits is more than 0, otherwise we'll not do that. So down here, we can paste in this call modal endpoint, and then instead of this hard-coded endpoint or hard-coded S3 key, we can actually also put in the S3 key right there. So now whenever we call this, we'll check the user credits, and then I'll only call the modal endpoint if the user has more than 0 credits. So that is perfect. Now, if you go into the schema at Prisma, remember that we create this status field right here. That can be either queued, processing, processed, or no credits. Well, it is queued by default, so whenever this was uploaded, it was then set to queued. But now we are actually starting to process the video if the user does have credits, so we'll set the status to processing. So down here, we'll create a new step. So I'll copy this line, and then I would like to do that, and call this step right here, set status processing. And then we can say awaits database.uploaded file dot update a specific row. The row I would like to update should have the ID uploaded file ID, and the data I would like to update should be the status column, and we'll update this to processing like this. So first we check the user ID or user credits, then if user has credits, we'll set the status to processing, and then right now we'll just call the modal endpoint right after. And then what happens after modal has ran this code, what happens after the modal endpoint has been hit, is that some more clips are added to this specific folder right here. So if the S3 key was test1 / and then this clip right there, then we know that we are inside this folder test1, and that is the video we're currently processing. So we can check for whether more clips were actually added to this folder than just this one. So for example, when it finishes running, it might have added 3 different clips, And then we just loop through all of the different clips from the AWS API. And then we add these clips in the database. So in this column right, in this table right here. And then we'll be able to show those clips to the user. So the next step after calling the Modal endpoint will be to check this specific folder through the S3 API. And we'll do this within an independent step as well. So I'll say const, and then result or response or something is equal to awaits step.run. And then I'll put in create clips in database, because that is what we do. That is the name of the step. And then the function will just be defined as this. And then I can say const folder prefix. So the folder we would like to look into is going to be the name right here. But this S3 key, which we queried up here, contains both the folder, but also the video, so the entire S3 key. So we'll go ahead and remove this name right here from the actual S3 key, so we only have the folder. So I'll say folder prefix is equal to S3 key dot split, and we would like to split it right here at this / because we see the / right here. Well, if we split it, then we get out this element and this element, and then we just only keep the first one. So we can then keep the first one and then just say exclamation mark, because if we do not do that and hover over here, we can see that it might be undefined because there might be 0 and / right here inside this S3 key. But if we put in an exclamation mark, we get the types right, and then it'll be a string. So we actually just force the TypeScript compiler, TypeScript transpiler, to ignore that there might be an error right here, and then we take on the responsibility on ourselves. And next, what we can do is actually use the AWS S3 API to go ahead and query this specific folder, which we just found. So down here, I'll create a function for doing that. Async function list S3 objects by prefix, and this prefix is this one. I would like to pass in the prefix, which will be a string. I can then say const and then S3 client, and then we'll just need to install an npm library for creating this S3 client. So I'll go to npm, and then I'll just search for client S3. So we'll need this one right here. So let me see if I can find an install command, this one. So I'll open up the terminal and then just install this npm package. So now we have that package. So down here we should be able to say new S3 client and import that. And we are. So I'll just close down the terminal, make this window a little bit smaller, and then we can pass in some credentials for being able to actually authenticate and use the API. So we created inside our environment variables files 2 variables, the AWS access key ID and the secret access key. And these comes from the IAM user, which we created earlier. So we can use these to authenticate our requests to the AWS API. So I'll go ahead and pass in the region first of all. This is going to be env dot and then AWS region. We can then also pass in some credentials. So this will be credentials. We'll pass in an access key ID, which will be env.aws access key ID, and a secret access key, which will just be env.aws secret access key, like that. And then for the specific endpoint we would like to hit in AWS, we're going to use a command. So I'll say const list command, and then we'll hit a list endpoint, and we can do this by using a new class called list objects v2 command, and then we'll need to specify the bucket. So this will be env dot and then s3 bucket name, and then we'll need to specify the prefix, which will be prefix like this. So this just defines the command we would like to send to the API, and then we can actually call the API by saying const response is equal to await s3 client dot send, and we'll send in the list command, and then we'll return the response dot response. I think I misspelled it. That is why. Dot contents dot map, and now loop through the items, and then I'll get the item dot key as an array back, and then we can say this needs to be uppercase. Then we can say dot filter boolean or an empty array. So what happens here is that we get out a list of S3 keys from the response right here with this prefix, and then we remove any undefined or null values from this array of S3 keys by doing this filter right here. And this way we can make sure that the list only contains valid S3 object keys. So that is basically what we do. Then hopping back up here, we can now just say const all keys is equal to awaits list S3 objects by prefix, and then we'll pass in the folder prefix. Then we can say const clip keys is equal to all keys dot filter. So one thing I want to just make clear is that whenever we upload a file in the frontend which we're going to build, we'll call the uploaded file original.mp4. So this means we'll always know what the original podcast clip name is going to be within this folder, and it'll be original.mp4. This means we can filter away this original mp4 and then only get all the other keys, which then by that logic must be clips. So this is why I'll apply this filter right here. So I'll say key is string, and then I can say key is not undefined and not key that ends with original.mp4. So we'll just filter away any keys that is original.mp4, that are original.mp4, meaning we'll only have the clips left in this array now. Cool. So now that we have the S3 key of the clips that were just created in the Modal endpoint, we can go ahead and create those in the database. So I'll say if clipkeys.length is more than 0, then we'll say awaits database.clips.create many. So we can create many at the same time. We'll pass in some data. This will be clipkeys.map. I'll just say clipkey, and then we'll just change the format of the data a little bit to make it match the columns that we require down here. So I would like to insert these clips. Each clip has an S3 key, which is going to be the clip key. Each clip also has an uploaded file ID, which is going to be what is needed to create the relation between the clip and then the uploaded file. So remember, we have this uploaded file ID right here, which then creates the relation between this and this. Well, we need to do this both for the uploaded file, but also for the user. So first we have the uploaded file ID, and then we have the user ID right there. And this should then be enough for each clip to create one of these clips in the database. And after creating these clips, we can then go ahead and just return clips found. So we can deduct credits based on how many clips were found in another step later on. So I'll say clipkeys.length, and these will then be the amount of clips found. So after the result down here, I'll just destructure this actually. So I'll destructure it to clips found like this. And then we can go ahead and deduct the credits. So I'll create a new function or new step. And this step will be called deduct credits. We probably won't return anything, so I'll just remove this return statement. This destructuring of the return statement. And then I can go ahead and say awaits database.user.update. I would like to update a user with the ID, user ID, because that is the one we're currently working with. And I would like to update the credits field. So I'll say data credits, and then we can apply a decrement operator right here to deduct credits from the user column. So this is, let me just find it. This is an integer, so we can use decrement and increment with Prisma. So I can say decrement math.minimum credits, and then also clips found. So you probably noticed that I put this inside a math.min. So let's say, and this is just a design choice by me, let's say that the user has 10 credits, the user has 2 credits left, but then uploads a video, and then 5 credits are used because the Modal backend created 5 clips. Well, in this case, if we didn't do this, it would just deduct 5 credits, bring the user's credits to -3. But I don't really think this makes much sense. I think if the user spends more credits than he have in a single run like this, it should just go down to 0 credits. This means that the user gets a little bit more than he paid for, but the alternative is checking whether the user has enough credits to create a certain amount of videos before even uploading the video. So this is just a simple solution to that problem. So that is why I put in a method min, just to make sure that we don't deduct more credits than the user actually has. So the next thing I would like to do is just mark the video as processed. So up here we mark the video as a processing. So I'll just copy this step right here and then hop down and then put in set status processed. So this will just need to be processed instead. And that should be enough to update the database. And then remember this if statement up here that checks if the user has 0 credits or more. I think it's right there. Well, we'll just add an else statement to that. So I'll say else. So if the user has 0 credits or less, meaning that the user do not have enough credits to create a video, we'll just run another step that will set the status of the video to no credits, like this. So set status no credits. This means that in the dashboard the user will be able to see that it says no credits in front of the uploaded file, so the user will know that he doesn't have enough credits to actually have this file processed. So that is also why I put in no credits right there. Alright, so now we have actually created the Inngest function, which we're going to need to trigger the Modal backend and then also keep track of if the video is processing, not processing, and then also calling the backend, deducting credits, etc. But we don't really have any users to test this on. So one of the next things we're going to do is actually create the authorization and authentication system. So having users be able to log in and register so we can go ahead and test with the uploading features. One thing I would like you to notice here though is that we divided some of these independent parts of the code into steps. So instead of just calling the code like this without this wrapping function, we put it into specific steps. So these steps are retriable pieces of logic that you can define inside an ingest function. This means if any of these steps fail, it'll retry this specific step independently up until the amount of retries that you have defined right here. And you can also see which steps are executing inside the Inngest developer dashboard. So in here under runs, you can see the specific steps. So call modal endpoint was one, for example, so you can see how long it took. So with these Inngest steps, they're pretty smart because you can break down pretty complex workflows like the one we just created into discrete manageable tasks that can be executed independently, like this one, for example, that can then be retried if this one fails without it affecting any of the other things. And each step actually supports both error handling, retries, to make sure that we have a pretty robust system that doesn't just break just because one database call failed, for example. Let's get started with the next part of the application. I will just close down this functions.ts right here and also the Prisma schema, these different files. And then I'll hop into a new tab on Google. So what I would like to do is to install Shadcn. So we'll use Shadcn as the UI library for this video because it's super simple to get started with. So you can really get something built fast. So I would like to open up a new terminal. So I'll hop into terminal. And then I'll just install Shadcn. So you can go ahead and put in the npm command or whatever other option you're using. So I'll just do this, neutral, and then I'll just use legacy peer dependencies. And now we should have Shadcn installed. Great. So first, if we hop into the T3 stack, we see that right now it says T3 stack right here. So hopping under our layout page, the root layout page, we can just change this to podcast clipper, both right there and right there. And for the favicon, we'll just search for favicon generator. And then we'll just do text to icon for now and just say podcast clipper PD. And then I think if we pick rounded, and then something like enter, bold, and then make the font size a little bit smaller, it should probably look fine. You probably want to do a better one than this one. It is just to make it look a little bit different from what we are, from just the default one. So we'll just create this one, download that, and then we should be able to take this download right here and just copy and paste that into the public folder. So I'm going to delete this favicon.ico, and then I have put the favicon.ico from the download up here into my clipboard. So I'll just paste this into the public folder like this, and then we should be able to see our new favicon. Then if I refresh over here, do a hard refresh with Shift Command R, we see a new favicon. And then I actually made a spelling mistake. It should be PC podcast clipper. And then I'll say download again and just redo this. So I'll just do the same thing again, put it into my clipboard. We'll then paste in the new one. And then we can go ahead and just refresh over here and see PC for podcast clipper. And for the first page we're going to build, it's going to be the sign up page, because we'll need to sign up a user before they can actually log in. So on the app, we'll create a new folder called sign up. Sign up like this. Inside the sign up folder, we'll put in a page.tsx. We'll then export default asynchronous function page. And then first we'll just return something. We'll return h1 and then just hello. Then if we hop over here and then go to the sign up routes, we should be able to see hello up there. So it seems to be working just fine for now. And I'll just close down this menu. So first things first, I would like to make this a server component. So I'll say use server. And the reason for this is I would like to redirect the user away from this page if the user is already logged in. So I'll go ahead and get the session. So const session is equal to await auth. So this will give us the session of the currently logged in user. Then we can say if session. Then we'll redirect the user, so we can import next navigation, redirect to dashboard. So if the user is currently logged in, he shouldn't be able to go ahead and sign up. So therefore we'll redirect the user to the dashboard. And before moving on with the actual sign up form, we'll need to go ahead and set up next auth. So next auth is what we are using. It is actually called auth.js now. So auth.js or next auth is what we are using to handle the authentication, so the tokens, sessions, etc. So the T3 stack sets up some of these things for us, but we still need to configure it. So if you search for auth and then hop into the index.ts file, we'll be able to set up a credentials login, which means we want the user to be able to log in with a username and then a password. So under providers, we'll need to import a credentials provider. So I'm going to delete this and search for credentials provider. We need to import that. So if I hop up here, we can search for credentials, and then we can say credentials provider. And then hopefully we should be able to import that, and we are. So down here we can configure how the credentials should be configured whenever the user logs in. So first I'll say name, credentials. I'll then say credentials. Well, the user will have to log in with an email. And then we're just going to put in label email. We are not going to use this label for anything. We're just going to put it in anyways, and then type email. Right under, we'll put in a password, but we do the exact same. So I'm just going to copy this line actually, and then call this property password. This will be password and password right here. So right under these credentials, I'll put in the async authorize. So this is the function that is going to be called whenever a user tries to log in. So whenever a user tries to log in, the credentials is going to be passed to us, and then we can check whether the credentials are right or not by checking whether the user exists in the database, and then we can reject or approve the user's login. So first I'll say if not credentials.email or not credentials.password. So if the email or password is not part of these credentials that we just received when the user logged in, then we'll return null, meaning we'll reject the user and not log the user in. Then we can get the email and password as strings, because right now they're just unknown. So we'll say const email is equal to credentials.email as string. And I'll just copy this line and put in password right under. Like that. And then we can say const user is equal to await database.user.findUnique. So we would like to find a user that has the email that the user just tried to log in with. And if that user does not exist, so if no user exists with the email the user just tried to log in with, we'll return null, like that. Then we can check whether the user's password that he tried to log in with matches with the password actually stored in the database. And the password is stored as an encrypted password. So whenever we do sign up a user, we'll encrypt the password, with a library called bcrypt.js. So we'll store the password hash in the database and not the password in plain text. So we'll need to compare this password with the password from the database. This also means that we'll need to hash this password right here because it is in plain text, and then compare the two hashes. So we'll need to install this library which we're going to use. So I'll search for npm bcrypt.js, so right here, and then we should be able to install the library. So I'll copy this command, open up the terminal, and install that. And then I'll just create a little function. So under lib library, I'll create auth.ts. In here, I'll say export async function, hash password. So this is what we'll use to hash the password whenever the user signs up. We'll pass in a password, which is a string. We'll say return, and then we'll call a hash function. The hash function should come from bcrypt.js. So we can say import hash and compare from bcrypt.js, like this. I'll just need to spell it correctly first though. And then we can call the hash function with the password and then a salt, which is just going to be 12. We'll also export an async function and compare passwords. This will accept a plain password, which is a string, and it'll accept a hashed password. So this is just the password from the database that already exists, and this is the password the user tries to log in with from the plain text, from the login form. This will also be a string. And then we can return compare, and the compare will return a boolean, so whether these two passwords are the same when this one has been hashed, of course. Then we'll pass in the plain password and the hashed password, like this. And then we should be able to import these functions in here whenever we need them. So back in the authorized method, which is what is run whenever a user tries to log in, we will then just check whether the password the user tried to log in with matches the one in the database. So we'll say const password match is equal to await compare passwords. Then we'll just need to spell it correctly inside this other file which we just created, compare passwords. And then we can import that, pass in the password and the hashed password, which is user.password. Then we can check whether they match. So if not password match, then we'll return null and reject the login request. And lastly, if all of these things has passed, that means the user should successfully be logged in. So we'll return the user, meaning we can set the user in this session for when we need the user information. And then down here, we're just going to choose the session type. So that is going to be JSON Web Token. So I'll say session. The session will be having the strategy JWT. And then under callbacks, we'll need to change a couple of things as well, because I would like to be able to store the user's ID inside the JWT token. So to do this, we'll need to change first the session callback right here. So we'll have session and token, and then we'll have the user, and this will then be token.sub instead of user.id. And then down here, we'll have another callback. So this will be JWT. We'll have a token and a user being received. Then we can say if user, then we'll set the token.id to the user.id, and then we'll return the token. Like that. And this is actually enough to set up a super simple credentials sign-in with Next.auth. So after that, we can go ahead and move on with the sign up page. So going into page.tsx, now we reject the user, we don't reject the user, we redirect the user to the dashboard if he's already logged in. And I can then see we have an error over here in config.ts. So scrolling up, I can see that we have two imports. It is supposed to be only compare passwords and not compare password as well. So I'll just go ahead and fix that and then hop back. And then for the sign up form itself, what I would like to do is hop into Shadcn or search for Shadcn auth. And then we can go to the one right here, building blocks for the web, and then we can find some existing login forms. So this one is super simple, so we'll just go ahead and use that. So what I'll do is go to code, and then in here I can first of all add the following code on the page level. So that is the level right here. And then we'll need to add in a sign up form. So instead of sign up, we'll call this instead of login, we'll call this sign up. So under source right here, I'll create a new folder, components. Inside components, I'll create a sign up form.tsx like that. And I'll just get the casing correct. Sign up form.tsx. Inside this, we can just say sign up form instead. And then we'll be ready to import it in just a second. So if you hop under components right here, and then you just copy all of the code, paste it in. We just need to fix the import statements. So I will go ahead and remove all of these imports actually, and then just import them manually to get them right. So we're going to need a card as well. So I'll hop under Shadcn, see if I can find the card right there. And then we should be ready to add in the card. So I'll open up the terminal like that. And then I'll paste in this command that adds the card from Shadcn. So if I import the card now, we should be able to see that. The card header as well, card title, card description, etc. And then for the card content, we can also do that. Label we do not have yet. We'll need the input first. So I'll hop down to input, add the input, and then under label, I'll just add that as well. And now we should be able to get both. So input I can at least find. And right here, I'll just say use legacy peer dependencies. And now we can find the label. I'll just import it from UI/label like that. Then down here we have some buttons. So I'll just find the button right here and add that as well. Legacy peer dependencies. And then I'll add the button right here. And then all of our bugs should be fixed. So now I'll call this sign up form instead. And then if I hop back in here, we can import the sign up form, press save. And then if we take a look at the actual code, we can see that we have the login form from Shadcn from this exact page right here, just in our own local environment. If we then just hop into the sign up form right over here, press F12, we should be able to change this a little bit to make it look like a sign up form instead of a sign in form. So first of all, this shouldn't be login, it should be sign up like that. And then under the card description, we can say sign up instead of login. So now this text matches as well. And then we won't really have any forgot your password logic. So I'll remove this that leads to forgot your password. And then we also don't want to have the users be able to log in with Google. You can do this if you want to, but I'll just not do that. And then down here, we'll just say sign in instead of sign up. And then we can say already have an account instead of the other thing. Cool. So now we should be able to set up the actual form. So this is just the shell of the form. So you can't really do anything with this. So we'll need to kind of check whether the form is correct or not. And then also create the user whenever the button is pressed. And this just needs to be sign up instead of login. So going all the way up to the top, we can define a sort schema, which we can use to validate that the inputs the user entered is correct. So we'll go ahead and say const sign up schema is equal to set, and we can import that .object. So set is already installed by the T3 stack. So if you go into the package.json, you should be able to see sort down here. So you see sort, and that is what we import when we import set. So this is just something that is imported by default by the T3 stack, because they also use it in stuff such as env.js, where we verify whether the environment variables are correct with the following checks as well, where we can check whether it's URL, string, etc. So that is why it is imported already. Cool. So we can now say set.object, and then we can define that we'll need an email that is going to be a string. So we'll say set.string.email, and the error message if the email is not correct is going to be please enter a valid email address like this. And then we'll need a password as well. So I'll just copy this line, call this password, and I'll say set.string.minimum, and I'll say that it needs to be a minimum length of 8 characters long. And then if this gives an error, I'll say password must be at least 8 characters long. Like this. Then for actually validating the form and also submitting it, we're going to use something called React Hook Form. So we'll just go ahead and install that. So I'll say npm React Hook Form, like that. Then we can install it with the following command right here. So I'll open up the terminal again, paste it in, and then we're also going to need a library which will allow us to interpret the following schema right here, and then apply these rules to the form that we have defined down here. So what we can use to do this is going to be hook form, and then resolvers and sort. So now we should be able to find these resolvers. So if I just install it like this, we should then be able to actually pass and use this this object right here. So going down into the component itself, we can now just say use form. So I'll say use form right here, and that is a hook we can now import from React Hook Form. So hopping up here, let me just see why it's not there. I'll just try and import it manually first of all. I'll say import use form from React Hook Form, like that. So with use form, we can pass in a type, as you see right there. So this type we can also derive. So right now we have an object, so a schema, and we can use the schema to verify whether the inputs input into the input fields are correct. But we would also like to get out some types whenever this form is submitted. So we can actually derive a TypeScript type from this object. So to do this, we'll say type sign up form values is equal to set.infer, and we would like to infer type of sign up schema. So I'll just press enter right there, and then we can finish up with a semicolon, and then in use form we can now say sign up form values, like this, and then we can call the hook, so the function, and then pass in a resolver, which will be a sort resolver. So we might have to import that as well manually. So I'll just try and say restart TypeScript server just to see if anything is wrong with that. And then we can just import this manually in the meantime if it doesn't work. So it still doesn't work. So I'll say import sort resolver and then I'll say from, and then hook form resolvers, and then sort, like this. And then down here we can say sort resolver, and then we just pass in the sign up schema, like this. So sign up schema. So this is the actual type, and this is the actual schema up here that will allow us to use the validation rules in the returned variables and methods from this use form. So I'll say const, and then results is equal to, and then in here we can see that we have a couple of things. So I'll just go ahead and destructure this. So I'll say register, and then we can also destructure handle submit, and we can also destructure form states, and then get out the errors. We can then just define a function here. So const on submit is equal to async. It's an async function where we pass in the data. So this is the function that is going to be called whenever the form is submitted. The type of the data is going to be sign up form values, just like we defined in the form right here. And then we'll just leave that as it is. And then down here in the actual form, we can say handle submit, or I think it's on submit actually, is equal to handle submit. And then we can pass in the on submit as the function that is actually going to be called whenever handle submit right here is triggered. And then for the input fields, we'll need to connect this form right here to the actual input fields. So because we have defined these rules up here, we'll need to know that this email field right there should be, or should have these rules applied for this specific input field right here. So to connect these, we can use this register function right there. So to do this, we'll just say ... register, and then this then destructures some properties into this input field for us, and we'll just register it as email. So that is going to be the field which will connect to the input. And then I see we have a small error over here. So what I'll do is just restart the servers. I think it might be because we installed these libraries without restarting the server. Sometimes it works, sometimes it probably doesn't. So I'll just open up Inngest and then also development right there. I just looked into this and I think it might be because we are missing a use client up here. So if I say use client, yeah, we should be able to see it now. So some of these things are only available on the client. And since we have a bunch of use states, or at least we're going to, and also other hooks such as use form, we're going to need to make this a client component. So this will also allow us to import the things that are available on the client, such as things from React hook form and also these resolvers right here. So going down to the register again, this then registers the field, and then whenever a field is changed, it'll then also be synchronized into the form state management that is handled by React hook form right here. And as you can see, this also will give us out the errors if any of these rules are not followed. So going down to under this input, we can just print out an error if there is actually an error. So down here, I'll say if errors.email. And so this will only be shown if errors.email actually contains a value, because as you can see, it can be both a field error, but also undefined, also specified with this question mark right here. So we'll then just render out a paragraph if that is the case, and the paragraph should contain errors.email.message. And then in here, we can just style this a little bit. We'll say text small and text red 500. Then if we just make this a string, just so we can check out what it actually is. So I'll just say true. This is what the error is going to look like. And then I'll just revert it back so it's actually usable. And then we'll just do the same thing for the password down here. So if I just find the password input field, we can go ahead and register that as well. So I'll say ... register. We'll register it as the password field. And then for the error, we can just copy this down to be right under the password field again. This will then be triggered if there is an error for the password field, and it'll show the password error. And we'll then just also create a global error up here that isn't dependent on any fields, but rather something that can show that an error maybe occurred during sign up. And to do that, we'll just create a use state. So up here, I'll say const error and set error is equal to use states. This use state should contain either a string or null if no error is set, and it'll be null per default. And then we can use the exact same method for showing the error as we did down here. So I'll just take this and copy it down to below the actual fields. So I'll show it right over the sign up button right there. And then we can go ahead and call this error instead. And then the error should just show the actual error. And then we'll just style it a little bit. So I'll just say true. And then right here, we can just put in some text for now. And then this error instead should be rounded medium, background red 50, text small, padding of 3, and then the text red is going to be fine as well. So I'll just save this. And now we can see that it is more of a general error instead of these smaller errors that is connected to the specific fields. So now I can put an error right here, and I can remove this. And then we'll just create another use state up here for tracking whether we are submitting or not currently. So I'll copy this use state and say is submitting. And then I can say set is submitting. And this will then be a boolean. So I'll just let it infer the type automatically and set it to false. Then down here, we can render the text in this button right here, depending on whether we're currently submitting or not. So if we're currently submitting, it should say something like loading. Otherwise, it should say sign up. And we'll of course also just disable the actual button if we're currently submitting. So I'll say it should be disabled if is submitting is true. And then for the text itself, I can say if is submitting. Then we'll say signing up, ... Otherwise, we'll say sign up like that. And then we can just test that out actually. So up here, we can set this to true. So signing up, and now we can click it. And if it's false, we can click it, but it says sign up now. And then I can see that down here we have an anchor with no href inside of it. So I'll just change this to a link from next link, which means the page won't reload whenever we switch between the pages. So if you put in a next link like this, it'll just not reload the page whenever you switch pages. But if you put it in an anchor, it'll do a full page reload. So that is just something that you should notice if you didn't know. And then for the href, we'll lead the user to login. If he clicks this already have an account button. And then we can just test out the email. So if I say hello.com and press enter, or I can say hello-gmail, and then for password I can say hello as well. Then we haven't entered a valid email address, and the password must be at least 8 characters. So up here, if I say hello twice, now that is at least fixed. And then if I add .com, that is fixed as well. So cool. The form validation works as it should be. If you would like to add more rules, you can add them up here. So maybe you would like some more advanced password validation to force the user to create some more advanced passwords, or you would like to enforce some other constraints. You can check out all these rules under SOT. If you go to their GitHub, I think you can see all of the different rules they have. So down here, they have a bunch of different rules you can use to make sure that you actually have whatever you need. So with that done, we can go ahead and create the actual sign up logic. So on submit, the user should be created. So we'll just need to implement that. So I'll put everything inside a try catch. So I'll say try catch, and I'll catch an error. And then I can say finally. So inside the try, the first thing I'll do is set is submitting to true. This means it'll start loading right here. Then we can set the error to null, so we don't show an error if there was an error. Then inside the finally, so regardless of whether an error happened or not, we'll set the loading state to false. If an error did happen, we'll actually show the error. So we'll set the error to an unexpected error occurred. Like this. We can then create the server action for actually signing up the user. So what I'll do is hop under source, and then I'll create a new folder right here. So I'll say new folder and then call this actions. Under actions, I'll say new file auth.ts. And then in here, we can create the server actions. So I'll put in use server at the top to specify that this needs to run on the server. And then what I'll do is also just create a new folder called this schemas. Under the signup form, I'll then take the schema we created right here and then just paste it in to the schemas instead. So under schemas, we'll just create one called auth.ts. In here, we can just export the schema right there, and then also import sort, and we'll also just export the type as well. And this should allow us to use them both on the server and on the client by importing them like that, and then also right here on the server. So we'll export an async function, sign up, and the sign up function should receive some form data. So I'll just say data, and the data will be in the following form, sign up form values, because that is what we're going to pass on from the data right here and then into the server action. So I'll import this sign up form values. And right now we are doing client-side validation. This means that we check whether everything is correct before the form is submitted on the client. But because everything is on the client, the user can potentially press F12 and then go ahead and actually modify some of these things or some of the JavaScript and then submit a form that is not correct. So what we'll do is also do some server-side validation to make sure that the user can really modify the form and then submit something to us that is incorrect and thereby break the server or introduce some threat. So I'll use the same schema right here from, let me just find that. I'll use the same schema which we defined right here and used on the client, just on the server instead. So on the server, if I just hop into actions, I'll say const validation results is equal to signup schema.savePass, and I'll pass with raw inputs like that. So it's just going to be data or something. And then I can say if not validation results.success. So it'll check the data that it receives and make sure that it lives up to the criteria defined in the schema, and also check that these properties even exists. So hopping back into auth.ts, if it didn't pass correctly, this means that there was an error in the schema, and then we'll return a success false. And we'll also return the error that actually happened. This will be validation results.error. And we'll just take .issues and show the first one, and then say .message. Or if this doesn't exist for some reason, we'll then just say invalid input. And I'll then just define the return type of this function. So I can say export type sign up results. I'll just remove the export since we might not need that right now. Then I'll say success. This will be a boolean and should always be in the response. And then I'll also have an error that we can return if we do want to set it. This will just be a string. And then up here, we can say that the function is supposed to return a promise. And inside that promise, once it is resolved, it will contain the sign up results like that. So the reason we have a promise is because it is an async function and you must await async functions to get the result out of them. And the reason we're getting an error right now is because we only return the following type that we have defined inside this if statement. We'll also need to return something outside the if statement to live up to what we have told TypeScript we're going to return. So if the validation is not accessed, then we'll return an error. Otherwise, we can go ahead and get the email and password out of the data right here. So I'll say const email and password is going to be equal to validation results.data. And then we're going to sign up the actual user now. So I'll put this inside a try catch. So I'll say try catch error. So if an error did occur, we'll just return success is false, and error is going to be something like an error occurred during sign up, like this. And I'll press save, so it auto formats. Inside the try, we can then first check if a user already exists, because if a user tries to sign up with an email already in the database, we should show an error down here in the global error box, which we just created. So I'll say const existing user is equal to await database dot, and we'll just need to import database dot user dot find unique. Then we'll find a user and check if there is a user where the email that was just used to sign in right here or sign up matches some email in the database. So we'll find unique and then say where email matches email, and then right after we can return an error if the email exists. So I'll say if existing user, then we'll return success false error email already in use, like that. And then if the user does not exist, we'll just go ahead and create a user. So I'll say const, and then we'll hash a password. So I'll say hashed password is equal to await hash password. And then right in here, we have this hash password function we created to actually hash a password and store it in the database. So I'll say hash password and then pass in the plain text password. Then I can say const Stripe, because remember, when we sign up a user, we also want to sign them up in Stripe, as we explained in the Excel draw. So I'll say const Stripe is equal to new Stripe. So we'll just need to initialize a Stripe client. So I'll just need to import this. So what I'll do is just hop up here and then say import Stripe from Stripe. And then we'll just import Stripe or install Stripe. So npm Stripe. And just import that so we can go ahead and do it already. Great. Then closing down the terminal. This should resolve in just a second. Maybe if I restart the TypeScript server. Cool, so it resolved. And then going down here, we can now pass in a Stripe key. So for now, we're just going to pass in a to-do Stripe key. And then what we'll do is say const Stripe customer. So in a second, when we set up the actual Stripe flow, so everything regarding Stripe, we'll just go ahead and create a secret key for Stripe, which we can use to initialize the client with, and then also actually create a user. So I'll just say Stripe customer is equal to await stripe.customers.create. And then we would like to create a customer with the email being the same as the email that was just used to log in the user or sign up the user. So I'll say .to lowercase, like that. So what this will do is it'll create a user in Stripe's database actually. It'll then return the ID back to us that matches the ID in that database, and then we can save both the ID in our own database and also Stripe's ID in our own database. This means we can connect a specific user to a specific user in Stripe. So that is basically why we create a user right here. So then I can create a new user in our database. So I'll say const new user is equal to await database.user.create. We'll create a user with the data email, password. This should be hashed password. And then also the Stripe custom ID, which would just be Stripe customer.id. And then for now, I'll just go ahead and comment this out since we haven't really created this key right here. So we'll just give an error if we do not pass in the correct key. And then what we can do is down here, return success is true and email, or we'll just not pass in an error. And right here, we aren't really using the user. So I'll just remove that line. And then if I hop back into the sign up form, we can go ahead and call this server action, which we just created. So first what I'll do is that I'll hop right under set error null and then say const results is equal to await sign up. So we'll call that, pass in the data, and this data should be the same type as we defined in here. And then we can check whether the results, so this result right here, contains success or not. So I'll say if not results.success, then we'll set the error to what was returned from the server action, because remember we returned the actual error right here if there was an error. So we'll set the error to results.error, and if it is not there, we'll just say an error occurred during sign up, like that. And then we can go ahead and return, because if an error actually happened, we don't want to execute any of the code below this statement. And then if the registration was successful, we'll sign in the user. So I'll say const sign in user or sign in results is equal to await, and we'll call a function called sign in from next auth. So I don't think I see it right there. So we'll just hop in and say import sign in from, and then we'll import it from next auth, and then they have a package called rect right here. So next auth rects, and this sign-in form is then a client-side, this sign-in method right here is a client-side method which we can use to sign in the user. So we'll call that function, and then we'll pass in the email, password, and other flags. And what this function will then do is it'll hop into config.ts, and then it'll call this authorize function for us to check whether the user that we just signed up with is actually existing in the database, and then it'll log in the user if the user does exist. So that is what is going on. So we'll pass in the email. This will be data.email. We'll pass in a password. This will be data.password. And then we'll also just pass in a flag called redirect. Set that to false. And we just need to pass in one more parameter here. So we need to specify that this is a sign-in with credentials. So right here we see that we passed in this credentials provider, but as you see, it's actually an array. So you can also pass in a Google Google provider, if you would like to use Google to be able to log in with. You can also pass in all kinds of different providers. If I just search for next auth providers, you can see all of the ones you can log in with. So all of these ones you can log in with if you would like to, but we'll just do credentials only. And this way, by specifying which one you would like to use on the client side, so in our case credentials, you can log in with the one you actually would like to log in with. So I can then say if sign in results dot error, then we'll set the error account created but couldn't sign in automatically. Please try again. So we know that the account was created because no error actually happened during the sign up, because we reached down to this point, but we still wasn't able to sign in. And then if the sign in error is not existent, so if the sign in went well, we'll then redirect the user manually. So I'll hop up here and then say const router is equal to use router from next navigation like this. So this is a hook we can use to push the user to another page in code. So I'll then say router.push, and we'll push the user to the dashboard page like that. And now if we open up a Prisma DB Studio, so if you open up npm scripts and then find the one called DB Studio. It is a command we can run to actually see a live overview of the database. So these are all the different database tables, and then the user table right here, we can check out to see if any users exists. So right now there are no rows in this table, but if we go ahead and sign up a user, we should be able to see a user in the table. So I'll put in andreas@gmail.com. So I'll just say @gmail.com and then put in a password and sign up. And then right now we're taken to the the login page. And the reason we're taken to this not very pretty looking page is because we haven't defined the login page yet. So it'll take us to the default login page that is a part of Next.auth. So it works now because we're taken to the sign up page. But if we hop into Prisma Studio and refresh, we should be able to see the user right here. So we have the user ID, we have an email, and then we have the hashed password. So this is not the password I put in, this is a hash of the password. So that is the reason why we put in the password, the hashing right here. So under auth, and then hash password. So the reason that we do this is because if the database is hacked, you'd be able to see all the different people's passwords. And if they reuse passwords across multiple sites, this is obviously not very good. So it is very important that you hash your passwords like this and not just store the passwords in plain text. We also see that we have 10 credits, and that is about it. The Stripe custom ID is null right now because we did not set that, but we should be able to create the login page now and then log in the user. So right now what I'll do is just hop into my files and then find the sign up page, create another one. This one should be called login, like this. In here we then have the same page.tsx. And then instead of a sign up form, we'll just need to create a login form as well. So I'll copy this right here and then call this login form. Down here, I'll call this login form as well. And what we can then do is just scroll down and say login. And I'll then just import this into the page. Remove the import up here. And then if we go to login, we should be able to see the actual login form. So I'll just say login like this. And now we see that we have this other form as well. So under login form, it is pretty much going to be the same form, except we will need to log in instead of sign up the user. So down here, I can start out by saying sign up. And then I can say don't have an account like that. And then we should be able to be taken between the different pages. So this should be sign up. Then if I click it, we can see that we're taken between the different pages, sign up and login. And then on submit up here. So what happens when you enter the form? Instead of signing up the user like this, we'll just sign in the user like we did before. And I actually see that we call this sign in results from the form up here. So what it should be called is sign up results. Like that. That is just a smaller mistake that doesn't really do anything. It's just for naming sake. And then if the sign in failed, we'll just say invalid email or password like this. But if you do log in with the correct credentials, we'll push you to the dashboard. And then for the validation rules for the actual schema, if the user enters in a password that is less, let me just go to auth, the schemas. Let me just find that right there. If the user enters a password right now in the login form that is less than 8 characters, he'll get this error message right here. And that is obviously wrong because it doesn't really make sense for the user to enter in a password more than 8 characters after already having signed up. So we'll create separate schemas for both login and also sign up. So I'll call this the login schema. And then we'll just import a type down here as well. Export. So I'll say login form values. And then right here, we'll remove this minimum 8 and call it minimum 1 instead. And then we'll just say password is required like this. And then this up here should be fine. Good. So hopping into the login form, we can then use the correct type as well. So I'll say login form values. And then I can say login schema. And that should now point to the correct schema which we created. And then I also see an error. It is spelled credentials, not credentials or whatever this is, credentials like this. So this is probably the reason actually that we were sent to that hideous looking login page and not the previous explanation I gave right there. So right now, if I refresh and then go ahead and log in, we should actually be able to log in. So before testing it out, I just want to make some minor adjustments to the UI just to make sure that it actually reflects a proper login page. So for example, it says enter email below to sign up. That is definitely not correct. It should be something like to log into your account. But I actually also think that that was the only change we had to make. So hopping up here, we should be able to log in with the user we just created. So I'll say andreas@gmail.com, and then I'll put in my password. I'll just put in a password that is not there right now. If I put in a single character, right now it says invalid email or password. And then if I remove the password, it says password is required. Then if I put in my actual password, I think this is my password. Oh, that is definitely not it. This is the one. Cool. So now we're taken to the dashboard because we are logged in. If you want to make sure that you're logged in, what you can do is press F12, hop into these developer tools, then you can click application, and then under your cookies, you should be able to see the cookies or the session tokens that is put in by Next.auth or Auth.js. So these tokens down here is what will keep you logged in. So for example, if we hop over to the login page again, right now it should take us back to the dashboard because remember, if I hop in here, it'll redirect us to the dashboard if we do have a session and we are logged in. So if you want to forcefully log out, what you can do is hop in here, select these and just press delete. This will then delete the cookies and then this should log you out. So hopping back into login now, we should be able to see that we are able to hop back into login. So that is basically what logging out does. It should just delete your cookies. So of course this is done automatically, but just so you know, before we have a logout button, if you would like to log out, you can just go into cookies and just delete the cookies manually. Great. So with the sign up and login forms handled, what we can do is just go ahead and hop over to the dashboard page, which is going to be the next page we'll create. So first of all, I'll create a new folder under app. I'll just say new folder, dashboard. In here, I'll start by creating a layout.tsx. So just like we have a layout.tsx down here, which will wrap all the content that is inside this folder app, we'll also create a layout.tsx in here, which will wrap all the pages that are going to be inside this dashboard folder. So in here, inside this layout.tsx, for example, we can define a header, so a navigation header that can show the amount of credits that the user has. And this doesn't really change a lot. So because it doesn't change a lot, we'll just like to extract it out into this layout.tsx. Then all pages will then have a navigation header with the amount of credits that the user has shown on the page. So to get started with this, we can start by just logging in so we can see the dashboard. Like this. And now we are logged in. And right now we don't really have a page, and that is why we see this 404. So I'll hop in here and just say new file, page.tsx. In here I'll just say export default async function, dashboard page. And this will then just return something like an h1 and then hello. So now we at least have a page inside this dashboard folder. And then what I'll do is just call this a server component. So I'll say use server. And then over here, for reload, we should be able to see the actual page. But we of course just needs to change this layout a little bit. So in here we don't really return anything, and that is what it is complaining about. So I'll just make this a use server as well. Then I'll say export default async function. And then I'll say dashboard layout. Then I can pass in the children, so that is what we receive. And these children are basically just the entire contents of this page. So let's say you navigate to /dashboard. Well, this is the page, so that is going to be the children of the layout page. And then we can wrap these children, so the page, in anything we would like to. So I'll then say children to just define the type as well. that will then just be a React node like this. And then for the contents, we can say const session is equal to auth, and auth we can import right here on the server side. And this will allow us to get the currently logged in user's ID. And this way we can query the amount of credits the user has. So now we can say if not session dot user, and I think we just need to await this. So I can say session dot user dot ID, then we'll redirect to the login page like this. We'll just need to import this though from the correct path. So this needs to be imported from Next navigation. So as you see right here, ID can be string or undefined. So we'll just make sure that it is not undefined and get the types correct. And if it for some reason is undefined, we'll then just redirect the user to the login page. And then if the user is logged in and we can get the user's ID, we'll then just get the user's credits. So I'll say const user is equal to awaits database.user.findUnique. And I'll say find unique or throw, because we shouldn't really be able to get an ID out here that doesn't exist. So we'll definitely throw an error if that happens. So we'll find a user where ID is session.user.id, and we would like to select credits where they are true. We would like to select the credits column and also the email column right here. And then we can actually render these out. So what I'll do is say return, and then I'll start by putting in a div that just wraps the entire page. So this should have flex, minimum height screen, and flex column. And then inside this, we can just go ahead and say user.email, and we can say user.credits as well, like this. And then we can see the email and the amount of credits that we have. And then we can render out the actual page contents. So this will just be wrapped in a main where we pass in the children like this. So hello, that is the contents of this page right here. And then for styling of the main, we'll just say container mx auto flex1 and py6 like that, which will just help center the contents of the page and make it look a little bit nicer. And then instead of this hard-coded information right here, we'll just hop into components and create an actual navigation header, which we can use to pass these into and then show them in a nice way. So other components will say nav header.csx. In here we can say const nav header, and we'll receive the credits and the email from the parent component. The credit should be a number and the email should be a string. And then we can say return in here. We'll just pass in a reg fragment for now, and then say export default nav header. This will just be a client component for now, so we'll say use client. And then we should be able to import it in here. So nav header, and then just add the missing attributes. So this will be user.credits, and this will be user.email. So now whatever we define inside this nav header as the return statement should be rendered out on the layout page. So I'll start by adding in a header. Let me just see what the error is right here. String and null is not assignable to type string. So I think I have seen a small bug right here. So if we hop into schema.prisma, we see that email is optional. So an email should definitely not be optional, just like a password is not optional. A user must always have both an email, but also a password. So I'll just go ahead and remove this optional mark right there, and then just run prisma db push. And I think we got a small error right there. Or actually we did not. Your database is now up to sync with the new Prisma schema. Cool. So closing down the terminal again, this should resolve this error, because now it is no longer optional, so it can't be undefined, it'll always be a string. So let's start out implementing this navigation header. So in here, I'll start with a root component, which is going to be a header. Then I can say class name, bg, background, sticky. I can say top 0, set 10, flex, justify center, and border bottom, like this. This will just be the wrapper for the actual header. Now I can put in a div with the class name container flex h16 items center justify between px4 and py2. So now we have the actual header up here. So first I would like to create an app logo that is kind of cool in its style. So I'll say link and just create a closing tag. Inside this link, I'll put in a couple of things. First, I'll just say class name. And I think we need to import this. No, we need to add some missing attributes. So the missing attribute is probably going to be href. So if you click this, it'll just take you to the dashboard, like any link probably does on the left side in a header. The class name will be flex and items center, like this. And then we can put in the actual link content. So inside this link, I'll put in a div. And I'll say font sans, text extra large, font medium, and tracking tight. And then for the links itself, I'll say span, podcast, and for this one, I'll say class name, text, foreground. And then I'll copy this line, put in a / instead. I'll copy this line and call this clipper and step. And then for this / I'll say font light and text gray 500 like this. And this actually needs to be an A and not an E. And then what we can do is say text foreground and font light for the last one. So now we have a pretty sleek logo up here, or not quite a logo, but kind of a logo still. So whenever you click this, it should take you to the dashboard page. That you can see that something happens because it re-renders down here. Cool, so under this link, if we just hop under this, we can put in a new div. I'll say class name, flex, items center, gap 4. In here I can put in a credits display. So I'll put in a div with class name, flex, items center, gap 2. I'll put in a badge and we'll need to install this from Shadcn. So I'll search for Shadcn badge and just install this. So we'll need to open up a terminal, paste in the command, use legacy peer dependencies, and then I'll just close down the terminal once again. So if I hop in and import the badge now, we can then inside the badge pass in the credits and say credits after that. And then over here we should be able to see the credits like that. And then we'll just need to style this. So I'll say variant secondary and class name is going to be h8 px of 3 py of 1.5 text extra small and font medium like this. And the reason I'm making it a specific height is because we will put in a button right next to it where you can buy more credits, and this should be the same height as the button. So the button will also be h8. So I'll put in a button with a link inside of it that says buy more. So we'll just need to import the button, and then the link we'll need to add the missing attributes. So the href is going to lead to another page we haven't created yet. So dashboard/billing. And then for the button, we can go ahead and say variant outline. We can also say size small. We can put in as child, and we can also put in the class name, which will be h8 text extra small and font medium like this. And then it says button is not defined, so maybe we need to install that in some way. If I just refresh over here first, we can just check what happens. So my server just decided to load forever. I'm not really sure why. So what I did was I restarted the development server, and then it was able to load again. So over here you can now see the credits and you can see the buy more button. And the reason, by the way, that we put in this as child property for the button is because we would like the link right here to become the actual button. So this actually means that this link will just look and behave like the button, but act as a link for navigation. And then if we hop under here, we can create the actual user menu. So I would like to use a menu or drop down menu from Shadcn. So I'll say Shadcn and then drop down menu like that. Find that and install it. So we'll need to open up the terminal and just paste this in. Use legacy API dependencies. And then what we can do is put in a drop down menu like this. We can then put in a drop down menu trigger. And we'll then just say schild as well. Just close that. We'll of course need to import this. Then we'll put in a button. This button should have an avatar inside of it, so we'll need to import the avatar as well. So hopping over here to avatar, we can just take that and install that as well. So terminal, and now we should be able to import the avatar like that. Inside the avatar, I'll put in an avatar fallback. This should be email.character@0. So the first letter of the email is going to be what we use as the round bubble that shows the user's character. So if I save now, we see something that doesn't look very good, but at least we see something. So inside the button, I'll just put in variant ghost, and I would like to put in class name relative age 8 with 8 rounded full and padding 0. And then right now, if you look over here, you can see that this text is not centered inside the ring. So that is obviously a little bit wrong. So it seems like some of this styling for this avatar fallback is not working. But if we scroll up, we can also see that the imports are incorrect. So this Radix UI is basically what Shadcn is built on. So if we import straight from that, all the styling made in Shadcn will become lost because we don't really depend on Shadcn. So instead of importing the React dropdown menu from Radix UI, we'll import it from Shadcn instead. So all of these Radix UI places, we'll just go ahead and remove those imports and then re-import them down here from UI dropdown menu instead of Radix UI. That should let us see the actual styling like this. So now we see the actual avatar fallback and it looks correct. So just in case you get these kind of weird styling errors with Shadcn, that is probably why. And then after this drop down menu trigger, we can put in drop down menu content like this. Inside this drop down menu content, we can put in a drop down menu label right there. Inside this one, we can put in a paragraph that says email like that. So this is going to be the email whenever you drop down the list or drop down this menu by clicking the button. As you can see, it drops down. So now we just need to style it a little. So first, this paragraph, I'll say text muted foreground, and I'll say text extra small. And then for the drop down menu content, I'll say align end. And what I'll then do is I'll add another item. This will be a button though. I'll first add a drop down menu separator like that. And we just need to make sure that we import from the correct places and not Radix UI. So I'll just go ahead and remove this right here, scroll down and then just import the correct thing again like that. So right after the separator, we'll put in a drop down menu item, and in here we'll just put in a button, and the button will just be a regular link that says billing. And then for the import, this will just need to be drop down like that, and link we'll need to add an href for, and the href is just going to be /dashboard/billing. So the exact same thing that this button over here leads to if we click that as well. And then what I'll do is say schild right here to make this link the actual menu item instead of the menu item being the menu item. Then I'll put in an additional separator beneath that, and then put in one more item. This item, I'll just copy like this. And then I'll remove the schild and put in some class names, and then also say sign out. So the class name should be text destructive like that, and then cursor pointer. So whenever you hover it, you see this button right here, it becomes a pointer, so it means you can click something. And then the text destructive, it's just red text like you see it right there. So that is basically the style we were going for. And then whenever you actually do click this drop down menu item, so on click, what we'll do is say sign out. So we can call this Next.auth React client-side API to sign out the user. And then we'll say callback URL. And then is equal to just the regular dashboard. So I think I'll just make this dashboard instead like that. And then if we hover this, we can see that it's deprecated. That is why we saw this crossing over of the actual keyword before. So we'll just replace this with redirect to. So when you sign out, you're redirected to the dashboard like that. So now if we hop over here and then click this, we can then click billing and it should take us to a 404 page. So that is great. We can also click sign out. And this then takes us to the login page right here. So what happens is that it first redirects us to the dashboard after being signed out. And then what happens in the dashboard page, so right here, is that it redirects us to the login page because we do not have a session anymore since we're signed out. So the session token is destroyed. And to make that even clearer, I think we should just go ahead and redirect the user to the login page whenever they log out instead of to the dashboard, and then having this middle step. And then before we close up the nav header, one more thing I would like is this to be fixed. So right now it says billings. It should just be billing, so in singular form. And then scrolling up, I think there is another thing I also spotted right here. So it should be items sender with a dash between it, and not items sender with a dot. So that was another bug. So logging back in, we can just test that it works for a final time. And then it seems to work just fine. So we'll go ahead and just say that is it for the navigation header. And then we can continue with the layout file. Good, so in here I would like to add just one more component, and that is a toaster. So going into Shadcn, we can find the toaster component. So down here we have something called Sonner. So if we click here, show toast, this is a toaster down here. And we add this by importing this component right here, and then putting it into a layout.tsx file. So I'll just go ahead and import that. Terminal, paste this in. Use legacy pair dependencies. And then I would like to just take the toaster and put it into this dashboard right here. So what I'll do is just put it in right there. And then import that. And then I want to make sure that the import path is actually correct. It should be this one, components UI Sonner, like this. And then I see that we have an error inside this Sonner class right here. Sonner component. So we just click this, we see that we have an error. It's a type and must be used imported in this way. So we'll just click quick fix, import that with type instead of no type like that. And that should then fix the error for us. And then we can go ahead and get started with the actual page contents. So first I'll just copy these two statements and then hop in here and then just run the same ones just to get the user ID inside this server component. So I'll just import both of these again, and then we'll do a database query first of all. So I'll say const user data is equal to await database.user.findUnique. And I'd like to find a unique user where the user's ID matches session.user.id, like this. So we get the user ID from the session, and then we can find the user in the database matching that ID. And then in this database, I would like to select some data. The first one is I would like to select the user's uploaded files. So if we hop into the functions.cs right here, so that is what happens with the ingest MQ. The first thing that happens is that we find the uploaded file. So that is just an original file from the user. So for example, if they upload a full podcast, that is going to be an uploaded file. That is the first thing you'll need to notice. And then the second thing down here is that we also create clips in the database. And we do this by finding all of the S3 objects in the S3 bucket. And then for each of these clips or video files, we then create one of these clips in the database. So we have both the original files up here, but also the clips that has been created. So those are the two things we'll work with. So first we'll just select the upload files. So these are just the original files. And here I would like to select the files where uploaded is true. This means we'll only select files that has been uploaded. And from these uploaded files, I would like to select some specific columns in those rows. I would like to select the ID of each of those, the S3 key. I would like to select the display name, also the status. This is what we can use to show the status of each of these uploaded files on the dashboard. So the status is going to be true as well. We would like to select created at, so we can show the user when it was uploaded. And then also I would like to select a count, where we select clips true like this. And what selecting this count does is that we can show that for each of these uploaded files, this many clips has been created. So for example, for each podcast, we can then show, oh, for this podcast, 3 clips were created, and for this other one, 5 clips were created, etc. So that is basically what we do with this count. Next, I would like to also select some other things. So right outside this, I would like to select some clips as well. And I would like to order the clips by the created at date, and then this should be in descending order. And then up here, I would like to just change this to find unique or throw. This means that instead of us having to do a manual check down here for whether this is existent or not, we'll just throw an error if it is not there. Cool. So going down, we can then say const formatted files, and then is equal to userdata.uploadedfiles.map. And then we'll create a data structure that can more easily be able to, or that will more easily help us render out this data in the frontend. So I'd like to create a list of objects that have an ID. The ID should be file.id. They should also have an S3 key. This should just be file.s3 key. I also want a file name. This should be the file.display name, or if it is not there, unknown file name. I would like a status as well. This should be file.status. Below, I would like a clips count. This should be the file dot and then count dot clips. And lastly, I would like a created at. This should be file.created at. And then what we'll do is we'll create a component down here called dashboard client, which will then be a client-side component, which we can use to show all of this data in the correct way. First of all, I would like to do one thing though. Because we have a server component right here that calls the database, this might take a little while, so we don't want the website to be unresponsive. So what we'll do is just put in a loading state, and the way we're going to do this is under dashboard, we're going to say loading.tsx. Inside this, we'll export a default function, loading, and then we can, inside this, return a div. This div should have the classes flex, items, sensor, justify sensor, so it'll sender both vertically and horizontally. Then I'll say P12. Then inside this div, what I would like to do is put in a loader2. Here I'll just close it like this. Inside this loader2, we can import that from Seed React. I'll give it the class names text, muted, foreground, age 12, so height 12, width 12 as well, and then animate spin right down there. Then I'll just close this over here so we can see it a little bit better. Then I'll put in a span that says loading dashboard ... Inside the span, we can then say class name ml3, text large like this. And then every time this page is loaded and we're waiting for the database call to finish and this await to resolve, we'll then just see this loading state defined inside the loading.tsx. So right now, because the database is super fast and it's an SQLite database, there's really no loading time at all. So we can go ahead and just simulate a loading time. So I'll say awaits new promise. So we'll create a fake promise, just like we can await this promise right here. We'll just create a promise ourselves that is set to finish after 3 seconds. So I'll go ahead and say results and then set timeout, and I can say results and then I'll just make it 5 seconds actually. Then if we reload over here, we now see the loading state for 5 seconds, and right now it looks not so good, but it looks decent. So I'll just make this 10, 10, and then I'll make this flex column instead, like this. If we then reload, I can see it looks a little bit better. Maybe if I put in a gap of 5, it looks a little bit more decent. So let's now go ahead and create the actual contents of the page. So closing down this loading state, then we'll create a component instead of hello right here. So if I hop under components, we'll create a new one called dashboard client.tsx. In here I'll say export function and then dashboard client, and we would like to pass in the uploaded files as well as the clips like this, and we can just define the types for those. So the types will be uploaded files like that, and that will be of type ID, which can be a string, s3 key, which can also be a string. We can also have file name, a string. There is a status. There is going to be a clips count. That is going to be a number. And then we'll have a created at, which will be a date. Cool. If I save that, we just need to define the type for the clips now. So the clips will just be of type clip from the database. So we can just import this from the database. So the reason we have this is because whenever you create a new database schema in here, or a new database model or table, that's what I meant. Then for example, this one, and then you run Prisma DB push, it'll then generate the client-side types for you. You can also run Prisma DB generate right here. This will then, Prisma post install, so Prisma generate. This will then just generate the TypeScript types for you whenever you change this Prisma.schema or schema.prisma file. So this also means that you can actually import these types if you would like to use them, and that is what we're doing right here. So what we have defined is basically that we have an array of rows from this table right there. Cool. So now that we have that defined, we can go ahead and just open up the function and just return an h1 for now. And then we should be able to import this dashboard client. And because we'll be making this a client component, we'll just put use client up on the top right here. This just means we can use states and hooks inside of this. Cool. So hopping in here, we'll just use this component and then just add the missing attributes. So for the uploaded files, we can go ahead and just pass in the formatted files. And then for the clips, we'll pass in the user data.clips. And then I see we have a small discrepancy between the uploaded files right here. And then I think we'll just copy this 1-to-1 actually. So copy it in like that. And then what I actually think we're missing is an array. So we'll pass in an array of these objects. So that was what we were missing. And then we see hello being rendered over here. So that is perfectly fine. Now we just need to remove this fake promise because we don't want to see the loading time every time. And now we're back to normal again. Cool, so let's just close down this layout and then just get started. So what I'll do is first add in a div. This div should have the class names mxauto. So it means it'll send it horizontally. Then I can put it flex max width 5xl like this. And then I can put in flex column space y6 px of 4 and then also a py of 8. Then if I save that, we shouldn't really see much of a difference because we haven't really put any content into it. Then I'll put in a div and then an h1 that says podcast clipper. Inside here, I'll just do some styling. I'll say text 2xl. I'll say font semi-bold, and I'll put in a tracking tight like this. And then below this h1, I'll just put in a paragraph and say upload your podcast and get AI generated clips instantly. And then we'll just do some styling for that as well. I'll say text muted foreground, save that. And I'll then just wrap these two in a div actually. And then right below this div, I'll put in a link. This link should say buy credits. And then we'll put in an href, which will link to dashboard/billing. And then we'll just need to import this link from next link up here. And the reason we are putting this into a div is because we can group these two together, and then we can do some styling that will separate this link from these two, and then these two will act as one group. So what I'll do is say flex items center justify between like this. And then as you can see, because we put in a flex and then justify between, because we have wrapped this inside a div, both of these will be kept on the left part of the screen, while this will then be put all the way over here on the right side of the screen. And then for the button, or sorry, for the link, I'll just wrap that in a button. So I'll put in a button right here from UI button, and then put in by credits. So now we have an actual by credits button that looks a little bit nicer. And then I would like to put in some tabs. That means we can switch between the upload functionality. So we have two pages in here basically. I would like a tab for being able to upload. Then I would like to click another tab that allows us to see the clips that have been created already. So Shadcn actually has an option for creating these tabs. So if I go in and then find tabs, we should be able to see the example right here. And then we can just add the tabs right after. So I'll open up a terminal, paste this in, use legacy peer dependencies. And then under this div right here, I'll put in a new tabs from UI tabs, inside tabs, and I'll just make the default value actually. So we're going to have two different modes. We're going to have an upload mode and then also a my clips mode. So I'll just set the default value to upload, and this means that we'll show this page with uploads per default whenever you reload the page. So I'll create the tabs list. Inside the tabs list, I'll put in a tabs trigger from UI tabs as well. Inside this tabs trigger, I'll put in upload, and then the value should be upload. Under this, I'll put in a my clips tab. Then I'll say my clips, like this. And then we'll just need to import the tabs list and make sure we don't have any Radix UI imports. So as you see, we have two tabs now and we can switch between those. So the switching between those is handled by Shadcn. So internally inside these components, there are some state that takes place that tracks whether you click this one or this one. And then the value that each one of these hold is then upload or my clips. So this allows you to switch between them by just defining this value prop. So it allows us to not write any of the code that switches between these, which is very nice. And then after creating this tabs list, we can go ahead and create the tabs content. So as well as we defined the value up here, we can also define a component right here. And then whenever the value is equal to upload, the tabs content right here is what is going to be shown. But then we can just create another one down below as soon as we would like to show my clips as well, like this. So all the contents of this component is what is being showed when this is selected, and all the contents of this component is what is going to be shown when this is selected. So that is kind of what we'll do. First, we'll start out with the tabs content for the upload though. So we'll put in a card from UI card. Inside the card, we'll put in a card header. Inside the card header, we'll put in a card title. And we can then put in upload podcast. We'll just need to import this from UI card. And right under the card title, we'll put in a card description. The card description should be like something like upload your audio or video file to generate clips. And then under the card header, we'll put in a card content. The card content should have a drop zone. So this is let me just show you. Drop zone, upload. So a drop zone is where you can basically upload a file to. So it's going to look something like this, where you can drag over a file over the area and then drop it to upload the file, or you can click this and then it'll open up a file picker dialog for you, which you can then use to select a file and then upload that. So we'll use something specifically called Shadcn drop zone, just because it is made with Shadcn, so it is super simple. So I'll just take this right here, and then we can just install that. And then I think we need to put in this legacy peer dependencies because we're using React 19, and this is only compatible with React 18. So we'll just go ahead and do that for now. And then if we hop under card content, we should now be able to add in the drop zone. So if we can't find this import, we might have to import it manually. So I'll say import drop zone from Shadcn drop zone. And we also want to import something called the drop zone state, and that is a type. So we'll just prefix it with type right here. And then we should be able to open up the drop zone and then put in our manual contents, the contents of what we would like to show within these two brackets. So in here, I'll put in these curly braces, and then I'll say drop zone states, and then we can render it conditionally based on this drop zone state. So first I'll put in a rect fragment, and then I'll put in a div. This div should have the styling flex column, items center, justify center, space y4, rounded large, p10, and text center, like that. And then if I open up the div, we can put in an upload cloud from Lucid React. This should just have some styling as well. So we'll put in text muted foreground. I'll put in age 12 and width 12, like this. So now we have this upload cloud. Below this, we'll put in a paragraph that says drag and drop your file. Then I'll put in another paragraph that says or click to browse, and then I'll just say MP4 up to 500 megabytes, like this. And then we'll just do some styling of these. So I'll say font medium, and right below this, I'll put in another style tag. So I'll say text muted foreground, and then I'll say text small. So it looks something like that. And then lastly, I'll just add in a button that also says select file. So right under this paragraph, I'll put in a button. This button should have the variant. Oh, this is definitely not the correct place. I'll say variant defaults, and then size small. And then I'll say select file, like this. So now we also see that. And then I think we spelled this incorrectly, text muted foreground, because it wasn't gray. So this is how it is supposed to look. And then if we click some of these, we can see that we can see our documents. And then the reason I include this drop zone right here is because if you hop into the type right there, and then also right here, we can see all of the properties we get out. So there is a flag, for example, for whether the drag is active. So for example, if you are dragging a file and then you are hovering the file over this right here, you might want to say that, okay, we are ready to accept your file, or just change how this is rendered based on whether these flags are true or not. So if you would like to play around with that and make some more complex states, you can go ahead and do that from this drop zone state right here. And then also one thing I noticed is that you see that we have, that the cursor changes whenever we hover this, but then if we hover over the select file, it changes back to normal. So I don't really want that. I would like this to also still be the cursor pointer whenever you hover the button. So hovering the select file, it is now cursor pointer, both if you're over the select file or not over it. Then I'll just create a use state up here for storing the files. So I'll say const files set files is equal to use states, and then we can say file right here, and this should be an array of files and just an empty array per default. And we can also just create a boolean for whether we're uploading the file or not. So I'll say const uploading set uploading is equal to use states false, like that. And then if we're currently uploading a file, we don't want the user to be able to upload one at the same time. So what we'll do is we'll hop down to this button again, and then we'll set this disabled flag to uploading. This means if uploading is true, then the button will be disabled, so it'll look like this. And then we'll quickly just define another function up here that is called handle drop. So I'll say const handle drop, and this function is supposed to accept these files as a parameters. So accepted files, which is an array of files. And then for now, we won't really implement that. We'll just go down and implement the styling first. So hopping down to the drop zone itself, we'll say on drop. So this is what happens whenever you do select a file or drop a file over this drop zone. So we'll say on drop is equal to handle drop. And then we can also say we'll only accept a specific type of file. This file is going to be video of type MP4. And then we can just define an array that says .mp4 right here as well. Then right after this property, we'll put in a max size. And I would like to only have 500 megabytes. So we'll say 500. So these are the amounts of megabytes. and then we'll just calculate how many megabytes it is. So we'll say 1024 times 1024. So what we basically do here is that we convert megabytes down to bytes. So we want to be able to accept 500 megabytes. So therefore we say 500 megabytes times 1024 kilobytes per megabyte. And then we get that down to bytes by saying this many kilobytes times 1024 bytes per kilobyte. So for the last property, we'll say disabled, and we'll disable it if we're uploading like this. So I'll just say true. And then as you can see, we can't really click this and select any files, or at least I can't, but you can't really see that probably. And then if I just go back to normal, we can continue. And then right below this drop zone right here, we would like to go ahead and actually show the file that is currently selected. So if I just go down and then create a new div, and then I'll create some styling inside that, I'll say flex items start and justify between. Then inside this div, I can put in another one, and then I'll just show the display names of the dropped files. So I'll only show this if there are more than 0 files selected. So I'll just say files.length. So we'll only show it if there's actually a file selected. And then I can put in a div like this with the class name, space y1, and text small. Text small like that. And then inside this div, we can put in a paragraph and say selected file. Inside this selected file, I'll put in a class name, font medium. And then right now, whenever you go ahead and select a file, so right now I'm inside the AI podcast Clipper backend. And then if I select this file, for example, we see that nothing happens. And that is because we haven't implemented this handle drop yet. So what we would like to do is whenever we select a file, it should actually set the file inside this use state. So I'll say set files, accepted files, save that. And then whenever we do select a file here, we should be able to see this text selected files, because now the files.length is more than 0. And then what I would like to do is just allow the user to only upload one file. So I'll hop back over to the drop zone and then say max files, put in a 1 up here. And then going down, I also want to show the actual file that was uploaded. So I'll put in files.map, and then I'll say file right here. And then I'll render out a paragraph, file.name. And then for paragraph, I'll say class name, text, muted, foreground. And then because we are inside this map, we'll need to define a key as well. This will just be file.name. This won't really matter that much though, because we only have a single file. So even though we're inside a map, we'll only ever render a single file out. So whenever we select a file, we see the name right here. And let me just try and change that. So now we see another file name instead. And then what we can do is create the button for actually doing the upload. So right now we select a file, but we don't really upload the file. So the user should be able to select a file like we do right here. And then whenever they're happy with the file selected, they can click the upload button, and that'll start the entire process of both uploading the file, but also queuing the processed video, the video to be processed. So first of all, for this button, I'll put in whether we are uploading or not. So if we are uploading, then I would like to put in a loader icon. So I'll put in loader 2 from Lucid React, and then I'll just close the bracket this way. Then I'll say class name mr2, age 4, height 4, animate spin, like this. And then right next to this loader, I would like to put in uploading ... And then I think we'll need to just put in this other statement as well that says upload and generate clips. So now if we have not selected a file, we'll then just show this. Otherwise, what we'll show is this. So uploading and then a spinning spinner. And then this spinner should also be disabled if, and let me just go into the button. Sorry, this button should also be disabled. Let me just define that. If files.length is equal to 0, so if 0 files are selected, or we are uploading currently. So uploading like this. So right now, if I refresh, we have not selected any files, so it is disabled. If I then select a file, now it is enabled, and we can go ahead and click this if we would like to. And then we'll just need to define what happens when we do click it. So on click, I would like to define to handle upload like this. And then this is just a function which we'll define next to our other functions up here. So I'll say const handle click, or was it handle upload? Handle upload is equal to an async function that takes no parameters down here. And now we do not get any errors anymore. So we can just implement this. It shouldn't take too long. So what we'll do is say if files.length is equal to 0. Then what we'll do is return, because we don't really want this method to be called if we do not have any files selected. Then we can get out the specific file that was selected. So we'll say files 0. And then right now we can see this can be file or undefined. So we'll just put in an exclamation mark, meaning we take on the responsibility of making sure that it is actually a file and not undefined. And that is what we did up here by checking that it actually does exist and the files.length is not 0. Down below we can set uploading to true. And right below this we'll put in a try catch. So I'll say try catch error. And then also I'll put in a finally. I'll then say set uploading, set that to false. And then the first thing I would like to do inside this try is then to generate an upload URL, which we can fetch to upload the file directly to an S3 bucket. So it kind of goes like this. We on the client would like to upload a file to an S3 bucket, but instead of us uploading from the client to our Next.js backend, and then from the backend to the S3 bucket. This is a pretty, Next.js backend like this. This is a pretty bad pattern, because we take all this data and then pass it right through our backend, and then through our backend, and then to the S3 bucket. So what we'll do instead is we'll have our backend generate an upload URL, which we can then use to fetch directly to the S3 bucket. So we first call our Next.js backend to generate this upload URL via the AWS API, and then after that we can upload directly from the client to the S3 bucket by going around our Next.js backend. So that is what we'll do. So I'll just create an action or server action for being able to generate this pre-signed URL, which is what you call it. So under actions I can say new file s3.ts. In here I'll say use server. I can then say export asynchronous function generates upload URL, file info. The file info should contain a file name, a string, and then also a content type, which is also a string. And then I would like the function to return a promise, which we'll define the type for in just a second. As we are developing the function. One thing I know that we'll need to define though is whether we have success in generating the pre-signed URL or not. So the first thing we'll do inside this server action is going to get the session out. So I'll say const session is equal to awaits auth like this. This means we can get out the user's current session, so the ID that the user has that is currently logged in. Then what I'll quickly do is just say if not session. Then we'll throw a new error unauthorized like this. And next we can then create a new S3 client. So I'll say const S3 client is equal to new S3 client like this. And then we'll just need to pass in a region, and that is going to be the environment variables .aws region. We'll need to pass in the credentials like this. This is going to be an access. I think we'll need to just import this correctly. This will contain an access key ID, which is env.aws access key ID, but also a secret access key, which will be env.secret access key. So this client right here will then allow us to interact with the AWS S3 API through the credentials which we have from the IAM user that we created early on when we built the backend. So first I would like to extract the file extension from the original file name. So I'll say const file extension is equal to file info.filename.split. And then because a file usually has a name dot and then some type such as MP4, we can do a split. That means we get an array with this as the first element and this as the second element. So we'll say file.split, and we'll split at the dot, and then we'll say .pub. And this will then give us the last, it'll remove the last element from the array and return it. So we can then get the element out, that is the file extension. And if the file extension does not exist, so if this returns undefined, then we'll just put in an empty string like this. So we can now generate a unique key with a UUID format. So I'll go ahead and say const unique ID is equal to UUID, and then I'll say v4, and we'll probably need to import or install this. So let me just see if it's a default import actually. So I'll say import v4 as UUID v4 from UUID. It is not. So I'll just go ahead and open up a terminal, and then I'll say pip, oh sorry, it is npm now, npm install UUID. And then we'll need to pass in the legacy dependencies. Just close down the terminal again. And then if I restart the TypeScript server, maybe this import will resolve. And it did right there. So now we can generate a new unique ID. So basically the idea behind this is that every single upload we make will have a unique ID. So we'll have a UUID and then an original .mp4. And then let me just make a new line. So every time you upload a new file, we'll upload this to an S3 bucket. So the S3 key will consist of the unique ID. So just a unique UID like this. And then it'll have an MP4 file inside this folder. And then whenever you do create a clip, what will happen is that it'll just say clip1.mp4, clip2.mp4, etc. And this way you can know that this will always be the original file and this will always be the clips. So right now we're generating this unique UUID, and if we hop into the functions which we created, we can also see the exact same thing happening. So right up here, whenever we upload the file, or sorry, call the modal endpoint, we send along this S3 key from the database that we're going to create right now. And then whenever the modal endpoint has been clipped and we would like to create these clips in the database, we take, let me just go back, we take this part of the key, of the original key, and then we can use this folder name to find all the other clips inside this folder. And then we can create a record in the database for each of those clips. So that is what we do here whenever we create many. So what we do is we take the S3 key and split it by this / and take the first element. So that means we split this string right here. And then we take the first element, which is the UUID, and then we can use that to find all the clips inside the folder. So right now we just need to create this unique ID, and then we can construct the S3 key from that. So I'll say const key, and this is going to be the S3 key, and this will be a formatted string where we pass in the unique ID as the folder name, / original dot, and then we can put in the file extension. So right now, even though we only allow MP4 files, we'll just make this dynamic to also support other files in the future if you would like to also handle those. So now we have the file which we're going to upload, the S3 key which we're going to upload to, and now we just need to create a put object command which we can use to generate the pre-signed URL. So I'll say const command is equal to new put object command, and then I'll specify the buckets, which is going to be environment.s3 bucket name, the key, which is going to be the key, as well as the content type, which will be the file info dot, and then content type. And then we'll generate a pre-signed URL. So const signed URL is equal to get signed URL. And we'll just need to import this get signed URL. So I think we already installed the S3 request pre-signer. I'm not 100% sure though, so I'll just say import get signed URL from, and then AWS, and I see we do not. So we'll need to just say npm s3 request pre-signer. And this is just a part of the AWS SDK that allows us to generate these pre-signed URLs. So I'll copy in this installation command and then just paste it into the terminal right here. and then we'll need to pass in the legacy peer dependencies. And then if we go in here, we can now say request pre-signer, hopefully, and we can, so that is great. And then we can pass in the S3 client, the command which we would like to fire, and then we can also pass in an expires in, so an option for how long the pre-signed URL should last. So unless you upload to this pre-signed URL within 600 seconds, so 10 minutes, it'll then expire, and then you won't be able to upload to this pre-signed URL again. So then I'll say const uploaded file db record is equal to awaits database.uploaded file .creates, and then we'll just create a record in the database that says, okay, now we actually are now we are in the process of uploading a file, but we'll then set the flag uploaded to false, which will then only set to true whenever the file has been uploaded. This way we can keep track of whether a file is 100% uploaded or not uploaded. Because we are able to generate these pre-signed URLs and then just not upload anything to them, so we want to make sure that a file is actually uploaded before we send it to being processed. So I'll say data, and then user ID. This will be session.user.id. We'll then pass in an S3 key, which will be the key, a display name, which is fileinfo.filename. We'll also pass in uploaded and set this to false, as I just explained. And then from this query where we also create the database record, I would like to select the ID from the created record, so ID true. And then what we can do is below this, we can return success, true, signed URL, key, and then also the uploaded file ID like this. And we'll just need to specify the following name .id. And then up here, we don't really have these parameters added to this promise. So I'll say signed URL, string, key, string, and then uploaded file ID, string as well. And then we should be able to use this method. So hopping back into the dashboard client, we can say const, and now this do result is equal to awaits generate upload URL, import that. Then we'll pass in the file name, which is going to be file.name, and we'll pass in the content type, which will be file.type. And both of these we get from the file up here, which we just selected. And we can then also destructure this right here because we have success, signed URL, key, uploaded file ID. So I'll say success, signed URL, and uploaded file ID. And then the next thing is going to check whether these are correct. So I'll just say if not success, then we'll throw a new error, failed to get upload URL. And then otherwise we can then say const upload response is equal to, and then we'll await fetch, and we'll make a fetch to the signed URL. So this signed URL basically is a URL on the AWS infrastructure, which we can then use to upload to. So we can use the put HTTP method to upload something, and then the body of the upload, the request is going to be the file itself, and the headers is going to be content type, file.type, and the reason that it is going to be file.type is because we're uploading the file basically. And this of course just needs to be method put like that, and this needs to be body, and then below this we'll say if not uploaded response dot okay, then we'll throw a new error, and then I'll say upload failed with status, upload response dot status, and then we can say okay, now that the file is uploaded, we can then set the files to just be an empty array, because when we upload the files, the file, actually not files, but file, we'll then just set the array to make sure that the user can upload another one if you would like to. And then right after, we'll also show a toast.success. So if we just import toast right here, and then say .success, it'll show a green check mark or something like that. and then it should say video uploaded successfully. And then we'll also just pass in a description to the toast, which will say your video has been scheduled for processing. And the reason we say scheduled for processing is because we have this queue that I explained in Next.js, so it might not get processed straight away if the user just uploaded a bunch and is being rate limit right now. So the video is being scheduled for processing and not just processed straight away. Then I'll say check the status below, because we'll make some kind of view that shows the status of all the uploaded videos. And then I would like to show this for 5,000 milliseconds, aka 5 seconds. And then if an error occurs right here, I'll then say toast.error, and then I'll say upload failed. Then I can put in a description, which will be there was a problem uploading your video. Please try again. Like this. So right now we upload the file, and then whenever the file has been uploaded and the response is okay, so down here, we only show this toast. But what I would like to do is add an element to this queue. So going back, right now the video is being uploaded, but we don't really insert this event into the queue. And as soon as we have inserted an event into the queue, then all of these other things will just happen automatically. We only need to insert an event into the queue. So that is going to be the next step. So right before setting these files to 0 and then resetting the state of the system, we'll just call a server action called process video, which we're going to create, and that will then put an element into the queue and then start this entire process. So what I'll do is just hop under my actions up here. Actions, then I'll create a new file called generation.ts. In here I'll I'll just make this a server file first, use server, then I'll say export async function process video, and then we'll take an uploaded file ID, which is a string as the only parameter. In here we can just say const uploaded video is equal to await database dot uploaded file dot find unique of row. Then we can find the file in the database where the ID corresponds to the uploaded file ID, and then we can select the columns uploaded true, ID true, and user ID true. This means that we only have this ID passed in, and then we actually fetch some more data and enrich the uploaded file ID data with all of these columns as well. And then we can insert into the queue right here. So the way we'll do this is by saying awaits, and then we can say ingest. So we'll just import this ingest and then say .send. So going into functions right here, we can see that the event we are listening to that will fire this function is the following event right here. So going into generation, we can then pass in the event name. That is going to be this one. And then I'll just say the data which we'll send to this function. So the data which we receive right here from event.data, that is going to be the uploaded file ID, which will be uploaded video.id. And we'll also send in the user ID, which will be uploaded video.user ID. And the reason we are passing in the user ID as well right here is because, as you see in here, we are limiting the concurrency of this function by this key event.data.user ID. So we'll need the user ID to be able to limit the concurrency per user. So that is basically why we're passing in these two parameters. So this piece of code right here is the only thing we'll need to insert elements into the queue. And then after having inserted into the queue, we'll then say await database.uploaded file.update. And then we'll update where the ID matches the uploaded file ID. And then we would like to insert the data uploaded true, because now that the video has been successfully uploaded and we have inserted something into the queue, well, then we for sure know that the video has been uploaded, so we'll set this flag to true. And then I just want to make sure that each upload file ID can only be processed once. So what I'll do is say if uploaded video dot uploaded, then I'll return. So right down here we set this flag to true. So if it has been processed once and inserted into the queue, we will make sure that we can insert it into the queue again. So for example, if any bugs occur that will call this process video multiple times with the same upload file ID, we won't have a lot of videos being processed by our backend. We'll make sure that they can only be processed once per video. And also, if someone calls our API endpoint directly with Postman, for example, or a script, they could just send this same upload file ID continuously, and then just queue a bunch of different items and spend all of our modal money. And that is obviously also not what we want. So this is just to make our application a little bit more secure from these kind of cases that I just talked about. So if we just copy this process video and hop back into the dashboard client, we should now be able to await the process video, import that from actions, and then we can say upload file ID, which we got returned from this generate upload URL. So we can now just test this flow end to end. So what I'll do is make this a little bit larger, and then we have our ingest server, and right now we do not see any runs, but we should see one as soon as we upload a video. Then we have our podcast clipper. I'll just refresh that as well. And then I'll go ahead and select a file. I'll take this 5-minute one. So I'll open it, upload and generate clips. And right now it is uploading. And now it has been uploaded successfully. And then if we hop into Inngest, we should be able to see this event running right here. So right now we do see an error. If I just close this. Alright, so I just looked into this error for a couple of minutes, and here's what I found out. So as you see, we get this error right here that says, let me scroll down. Argument where of type uploaded file where a unique input needs at least one of the ID arguments. So right now, and then we can find the actual line that it happens at. So the actual line is going to be this one, check credits in step.run, and step.run is going to be defined within this functions. So going down to right here. So this uploaded file ID is null for some reason. So what I did was that I went in to where this actually comes from, and it comes from generation. So whenever we send the event. So right here we call it uploaded file ID, but right here we call it upload file ID. So these names obviously does not match, and that is why we get this issue. So I'll just rename this to be correct uploaded file ID, all the different places. And then I would like to try and run this again just to see if that resolves the bug. So let me just go in and select the file, press open, upload and generate clips. And then in a second, we should be able to see a run in here. So I'll just wait. Now it says queued and running. And right now we do not get any errors yet. So that is very promising. I'll just come back whenever this is finished, and then we can take a look at what happened. So all of these different steps inside the function or inside the ingest function finished, so that is perfectly fine. And then we can just check out the results. So if we hop into this AI podcast clipper, we should be able to see, let me just refresh there. We should be able to see the different uploads. So right now we have 3 uploads, and the reason is that we filled one, then I spent one upload testing, and then we have one upload that is actually correct. So that is probably this one, maybe this one. So this is the correct one. So this is the unique UID that I talked about. Then we have the original MP4 file, so the original upload. And then we also have the clip itself. And then if I hop under the, let me just find Prisma Studio, we can just go under my database tables and then just find clips. And then we should be able to see the clips in here as well. And then if we go under, let me just find uploaded file, we should be able to see these uploaded files as well, all with the status true for uploaded. So that seems to be working as well. So right now we know that the flows work end to end basically. We do not have a lot of feedback for the user though, because as soon as they select a file and upload, we only see this toast down here, but that's basically all we see. We can't really see any clips or any status of the clips we have uploaded. So the next thing I would like to build is a small table that shows each of the uploaded clips as well as their status, so whether they're queued, currently processing, have processed, or whether there's no credits left for the user. So that is going to be the next step. Going down here, this should be perfectly fine now. And then I'll just scroll down to below this bar right here. Oh, sorry, this card. So that is going to be right under this div, and it's actually not below the card. It is still inside the card, but just below the contents that is in the bottom of the card right here. So I'll then just put in a table that displays the uploaded file history. So I'll first of all only show this if the length of the uploaded files is more than 0. So I can say uploaded files.length is more than 0. And if that is the case, then we'll render out a div. So this div will have class name pt6. And then I'll show something inside this div. I'll put in an h3 and say qStatus. And then I'll just style this a little bit. So I'll say text md and spell this correctly. And then I can also put in margin bottom 2 and font medium like that. And then what I'll do is I'll put in a container for the table itself. So I'll say class name, max height, and then 300 pixels like that. And then I'll say overflow auto, and then rounded medium, and I'll put in a border as well. And right now, the reason we're able to see this is because we actually do have uploaded files, as we just checked in the database. So we'll then be able to see that it actually works while we're developing it. So that's pretty nice as well. So down here, I'll put in a table. We might want to install this from Shadcn first. So what I'll do is I'll go down to table right here and just add that. So as you see, they have this finished table with a bunch of features. So we'll just use that instead of building one ourselves. So I'll go to terminal and then I'll install the table. And then down here, I should now be able to import a table from UI table. And then inside the table, I'll put in a table header as well. The table header should contain a table row. Inside the table row, I'll put in a table head. So that is basically a column. This one should say file, for example. And then I'll copy this 3 times. Then I'll say uploaded. So this column should show the status, so whether it's uploaded or not. I'll also want one that's called processed. And then another one that says clips created, like this. And then I'll just hop back right here. And then for the table body itself, we'll loop through all of the different files and then render them out as table rows. So under the table header, we'll put in a table body. The table body should have a map. So I'll say uploaded files dot map. And then for each one of these, I'll render out a table row. And the table row key should just be the item.id. So the uploaded files ID, and that is used to differentiate between the different ones. Then inside this, I'll put in a table cell, where I'll put in an item.filename. And then I'll just import this and give the class names max with extra small, truncate, and font medium like this. So now we're able to see the file names of the uploaded files. And we basically just need to do this for all the different table cells, which we would like to include. Oh, sorry, all the different columns. So we have this one, and this one left. So this next one should show the created date. So what I'll do is I'll say new dates item dot created at, and then I can say dot to local date string. And then what I'll do is I'll just change this a little bit up here. So I'll say text muted foreground and text small like this. And then below this table cell, we'll create a little bit more of a complex one. So I'll say table cell, and then we'll show the status depending on what the status is. So we'll say item if item.status is equal to queued, and so basically if this is true, then we'll show this over here. Then we'll show a batch, and a batch is the same one we used up here. So just a Shadcn element. And this batch, I'll just go ahead and import. And in here, we'll put in queued as the text inside the batch. Like this. And then we'll style the batch a little bit. So we'll just go ahead and say variant is equal to outline. Like this. So now we can see that this is queued. And then we'll just create batches for the rest of the statuses. So we have 4 statuses. We have one for processing. We also have one for processed, like this. And we also have one that is called no credits, and this just says no credits, like this. So now we can see that we have the two that failed. That is the one right here and the one right here. Both of those are queued because they failed. So because they failed, they didn't really make it down to the point where it said where they say processed and processed updated in the database row. So we probably want to create a way to make sure that if they do fail, we say failed right here instead of queued, because we don't want the user to be able to think that they actually queued when they failed in reality. And then for this last one, clips created. And this one, I'll just change the status as well. So status, and then down here for the last table cell, I would like to put in item.clips count. So if that is larger than 0, then we'll show a span with the amount of clips. Otherwise, we'll show another span that says no clips yet. And this span should have the class name text muted foreground like this. So because there's no clips created on the failed ones up here, they obviously say no clips created yet. And down here we do not see the text because we do have clips created. So what I'll do inside this one is I'll say item.clipsCount, and then I'll say clip. And then if we do have more than one clip, so if there are 2 clips, then we don't want the singular form of the word, we'll append an S to that. So what I'll do is I'll say item.clipsCount. And if that is not equal to 1, then we'll put in an S, otherwise we'll put in nothing. Like this. So if clips count is going to be 2, for example, so if I put in 2 and 2, then it'll say 2 clips, but it'll also be able to say 1 clip. And then regarding the status which we talked about, right now, if there are no credits, we'll just make this destructive. So this means it is red and it stands out a lot. So what I'll do is I'll just make one called failed as well, and then I'll say failed, and then if I just remove this queued right here, and then just say queued, we can just check how it looks. So this is how it is going to look if it is failed, and then I'll just revert back. So we only want to show this obviously if it did fail. So now we just need to hop into our functions in Inngest, and then if they do fail, we can go ahead and update the database status to failed instead of processing or queued, for example. So if we hop into the Inngest documentation, I'll just search for Inngest. We can then just go in to the documentation. So I'll just go to this one right here, then find the functions. We should then be able to go to errors and retries and just see how we can handle the actual error. So failure handlers, Inngest errors. Going down, we have this one right here. So after a step exhausts all of its retries, it'll throw a step error, which can be caught and handled in a function handler if desired. So it can be handled with try catch, for example, and then we can update the database inside the catch. So I'll just wrap this entire thing inside a try catch. So I'll say try, and then I'll say catch, error, and then inside the error, I'm going to just take this right here and paste it in. And then I would like to say failed if that is the case. And then I'll copy all of these different lines all the way down to the last step. So that is going to be down to right there. Or is this the one actually? No, above this one. Cool. So from here, and then all the way up to check credits, and I'll put this into the try catch. This means that if any of these steps fail more than the maximum amount of times they can fail, it'll then trigger the catch statement down here, and that should set the status to failed for that specific uploaded file. So now that I've saved that, I can go back into my application, and then I would like to just test this out. So what we can do is we can just replicate the error that happened before. So right now, we actually pass in the correct uploaded file ID, but let's try and pass in one that is incorrect like what happened before. So if we pass in undefined, that is the exact error that happened, and just refresh over here, then we can select a file 5 minutes long, upload that, and then we'll just check out in the Inngest dashboard what actually happens, because it should fail 3 times very quickly in a row. So over here, running, it fails attempt 0, and it'll probably also fail the second attempt over here. So it just tried the second attempt and also failed that. So the reason why it takes some time for it to try the second attempt is because it introduces some delay between attempt 1 and attempt 2. So going back into the dashboard right here, and then just refreshing, we can now see that this clip right here has failed and that it has the database status set to failed. And then you notice how I had to refresh. Well, that is because we fetch the actual data on the page level. So whenever the page loads, we fetch all this data because we're inside a server component. But this also means that if we want the fresh data, we'll have to refresh the page. One way we can get around this though is that we can revalidate the path. So what we basically do is that we say for a specific path such as this one /dashboard, we just redo all of the database fetches, and we can then do this programmatically, meaning we do not have to do it just by refreshing the page. So the place we're going to do this is inside this serve action. So going into generation and then under uploaded file. So this is the process video. So if you just search for where we use this inside the dashboard client right here. So after we already have uploaded the file, then inside this process video, as you see, we insert this, we do not insert, we set upload to true for this file right here. So we do know that it is in the database, but right now it is not shown for the file that is uploaded. So we can say revalidate path, and then we can put in /dashboard. So this will then redo the database queries, and then we should be able to see the uploaded file instantly. So if we just upload a file now, right here, and then just wait for that to upload, we should be able to see it pop up by itself like it did right here. So now we see a new file that has been queued, but no clips has been created yet. So one thing is that right now it popped up by itself that it is queued, but even though it is running, so I just waited for a little bit now, and now it is completed, we don't really see it update down here. So if I refresh now, we see filled again. So we only see the update once we actually refresh the page. And that is also kind of annoying that you have to refresh the entire page. I'll just go ahead and fix this again because we don't really want to introduce a bug by ourselves. So what I would like to introduce is a button up here that says refresh. So you can click this and it just spins around for half a second, shows the user that we are reloading, and then we can go ahead and reload the page with that, or not reload the page, we can reload this queue status table without reloading the entire page. So how I'm going to do that is first of all up here. So I'll create a use state inside the dashboard client. This one should be refreshing, and then set refreshing. And it'll just be a simple use state that is just a boolean that is false per default. And then I'll just create a function called handle refresh. Inside this function, it'll just be a simple async function where we say set refreshing, and we set that to true. And then we just need to import a hook as well, const router. So this allows us to refresh the page without refreshing the page fully. And this will be equal to use router from next navigation. In here, I can then go ahead and say set timeout. So we just want to make this refreshing true for about half a second. So I'll say set timeout and then set refreshing, and I'll say false 600. So we set it to false after 600 milliseconds, so about half a second. And this means that we can show the spinner for these 600 milliseconds while this refreshing is true. So we would like to show it right over here on the right, above the table on the right. So we go down to where queue status is, and then we'll just wrap this in a div. This div should have class names flex, items center to center them vertically, and then we'll say justify between to push them apart, and then we'll also say margin bottom 2. And then in here we already have the queue status, and the next thing is just going to be adding in this button. Inside the button, I'll just put in so if we're refreshing, I would like to show loader 2. Oh, I just need to make sure that the brackets match. And then I'll style this a little bit. So I'll say mr2 h4 with 4 and animate spin like this. And then for the button itself, right outside here, I'll just say refresh as well. And then for the button itself, I'll go ahead and say variant outline. I'll also say size small. I'll say on click. then we handle refresh. Then we can say it should be disabled whenever we are refreshing, and I think that should be it for the button. Now going up here again, I just want to make sure that we actually did refresh, and we actually did not. So we import the router, but I just forgot to refresh. So I'll say router.refresh like this, and then just call this function. Now if I then over here just say refresh, we see that it loads for a second. So let me just try and upload a new file. So I'll just upload this again and then say upload generated clips. And then when it is uploaded, it should say queued. And then whenever I refresh it, it should say processing or something like that. So if I say refresh now, we now see that it says processing. And then if I wait for a couple of minutes for this to finish, we should probably see it says something like processed. So I just waited for this to finish, and now if I hop into Inngest, we're able to see that the job is completed. So going back in here, if you press refresh, we now see that it says processed instead of processing. So all in all, this queue status and also the refresh logic works exactly like we would expect it to. So now we can actually go ahead and start implementing this next tab, my clips. Right now we are able to generate clips, but we aren't able to actually play the clips. So to get started with this, I'll hop down to right under this tab's content right here. And then I'll put in another tab's content like I explained to you earlier. The value for this one should just be my clips, like that. In here we'll put in a card. Inside the card I'll put in a card header, like that. I'll then say my clips. And if we just switch over to this other pane right here, we should be able to see that. Under the card header, I'll put in a card description. This should be inside a card title actually. I'll just make it a card title, like that. Then inside the card description, I'll put in view and manage your generated clips here. And then I'll say processing may take a few minutes, like that. And I think we just need to wrap the card description inside a card header, which will align it nicely with the card title as well. Now under this card header, we'll put in card content. In here, we'll put in a custom component, which will then contain the display of the clips themselves. So what I'll do is I'll hop under components, in here, find components, new file, clip, display.tsx. In here I'll start by exporting. I'll actually just make this use client to make it a client component. So first I'll export a function called clip display. I'll then say clips, and then clips will be a clip from Prisma client, an array of those. And then in here I'll just return just a rect fragment for now, like this. And then what I can do is I can hop back in here, and then I can put this clip display into this card content as the component. And then I'll just pass in the clips as the clips, which we already passed down up here. Let me just see, we had it right here. It was passed down from the page into the dashboard client, and then we just passed them down into another component, which is this clip display. So this clip display component right here is going to contain a grid containing all the different cards for the different videos. So first I'll just create an empty state if there are no clips. So I'll say if clips.length is equal to length is equal to 0. Then I'll return a paragraph that says no clips generated yet. And I'll just test this out. So what I'll do is just copy this and just say true instead, so we can just see how it looks. So I like to just make it muted. So I'll say text muted foreground, and then padding 4 and text center. So now it'll look something like this if there are no clips generated yet. And then of course we'll have generated clips right now because we did just test out the tool. So if there are generated clips, what we'll do is to return a grid. So I'll just put in a div, and then here I'll loop through the different clips right here, and then render out another component called clip card, which we're going to create in just a second. So first of all, we'll create the grid in CSS. So under class names, we'll say grid columns 2, gap 2, small, grid columns 3, and large grid columns 4. So these are just different breakpoints. So per default, you have two columns of grids. You have a grid with 2 columns on this breakpoint. So 640 pixels or larger in width, you'll have 3 columns, and then on large, so on 1024 pixels, you'll have 4 columns in the grid. So that is pretty simple. And then what I'll do is I'll loop through the different clips. So I'll say clips.map, and then I'll say clip. And then inside this, for each clip, I would like to render out another component. So what I'll do is I'll say function clip card, and this will just accept a clip as its parameter. The clip will just be a simple clip from the database, like that. And then in here, I'll just return a fragment for now. So I can then just render out each of these clips like this. So I just need to give it a key, which is going to be clip.id. And I'll need to give it a clip as well, which will just be a clip like this. And then instead of these curly braces, we'll just make regular braces. So this lets React know that we are returning HTML or JSX straight away instead of returning a programming statement. So now if we save, we should be able to see this right here. And then whatever we put inside here allows us to render out the clips in the way that we would like to. So let's render out a card. I'll say div. Inside the div, I'll say class name flex, max width 52, and then I'll say flex column and gap 2. And then inside this, I'll put in another div. I'll say class name bg muted, like that. And then before moving on, we just need to define a couple of things up here. So first of all, this clip right here, which we're going to show, only contains the reference to the S3 bucket right here. So we have the S3 key. We do not actually have a link to actually play the clip. So if you go into the S3 bucket, we can also see that we can't really play the clip right here. We'll need to download it first. And what this basically does whenever you click here and then click download is that it generates a link for you, and then it redirects you to that link, which will then download the clip for you. So we can use kind of the same technique to get a link that we are able to actually play inside a video player in the HTML. So we'll need to call the API for S3 to then generate a clip URL. And we can then take this URL and put it into a video player. So first I'll say const and then play URL, and then set play URL, and then is equal to a use state, which can be either string or null if the URL has not been loaded yet. And we'll then just create a server action, which we can use to fetch this URL. So what I would like to do is hop into generation.ts, and then I'll go down and create a new function, export async function get clip play URL, and then we'll pass in a clip ID, which will be a string. And then I can also just tell it what we're going to return. I'll return a promise. The promise should resolve to a dictionary with a success that can be a boolean, a URL that can be a string, and then also an error, which can be a string as well. Good. And then for the function itself, first we'll just get the session. So I think we did this. No, we didn't do that up here. So we'll just say const session is equal to awaits auth, so we can get the user's ID. I'll just import this, and then I'll say if not session dot user dot ID, then we'll return success false and error unauthorized, like that. I can spell correctly. Good. So under this, I'll then say try and then catch, and I'll catch an error. Good. And then inside the try, first we'll use the user's ID to find all the clips that he has previously created or that he owns in the database. So I'll say const clip is equal to awaits db.clip, and then we can find a specific clip. So I'll say find unique to find one where the ID matches the clip ID. So we get the clip ID right here. But if we don't really use the user's ID, then anyone can just call this function and then just get a random clip out. So I would be able to get a clip that doesn't belong to me. So we want to check both for the clip ID, but also for the user's ID to make sure that the user that is logged in is also the one who owns the clip. So I can then say user ID, and then this should match session.user.id like that. And now we should be able to fetch a clip that belongs to the user. I'll then just say find unique or throw instead of find unique, just so we make sure that this can't be null, this entire clip. And then down here, I'll then say const s3 client. So we'll create an s3 client, just like we have done in the different other places. So I'll just copy this statement, hop back into generation, and then now down here, I'll paste that in. So I'll just import the s3 client, and then the env from this path right there. Then under the s3 client, we can now create a get command. So I'll say const, and then command is equal to new get object command. And I would like to create a command where the bucket is env.s3 bucket name, and the key is clip.s3 key. So we tell AWS whenever we fire this command to the API that, okay, we would like a new pre-signed URL that allows, gives us an element from this bucket with this s3 key within the bucket. Then we can say const signed URL is equal to awaits get signed URL. We pass in the s3 client, the command, and also how long the link should be available for. So I'll say expires in 3600. So these are these are seconds. So this means that the URL will be available for 1 hour. I'll just spell this correctly though, signed URL. And then what we can do is we can return success equals true, and we can return URL is the signed URL. If we do get an error, we'll return success is false and error failed to generate play URL like that. And then going back into the component we were at before, so that should be page.tsx clip display. So while this server action that we just created is going to load, so it'll take some time because we both query the database, we also call the external API, so the AWS API, and then we first return the get signed URL afterwards, the signed URL afterwards. So because this takes some time, there will be some loading time before the user can actually play the video. So we'll make sure to keep track of that loading time. So I'll say const is loading URL, and then set is loading URL, and this will be equal to use states, and I'll just set this to true because whenever this loads for the first time, the the signed URL is not there, so it should just be loading from the start. And then as soon as the clip has been loaded, or we have the actual URL, then we stop the loading state. So whenever this component right here mounts, whenever it loads, we'll just run a use effect that'll call this server action and then generate the URL for us. So I'll just do this, and it'll be dependent on clip.id. In here, I'll say async function play URL. Fetch play URL. And then we'll just call this function. So I'll say void play, fetch play URL like this, and then just call the function. And then inside this fetch play URL, what I'm going to do is I'll say set is loading URL to true. Then I'll try and I'll say const result. I'll try and get the clip play URL like this, where I pass in the clip.id, just like we defined inside this function. And then what I can do with the result is that I can say if, and then results.success and results.url. Then what we'll do is we'll set the play URL to the URL that was generated by the AWS API. That is going to be contained within results.url. Then right outside we'll say else if, and then we can say else if results.error. Well, in that case we'll just console.error the error failed to get play URL plus, and then I'll just say results.error error, and then it should be a string. So console.error right here. And then after this, I can go into the catch statement, which we can just define. So I'll say catch error. And then in here, we'll just do a console.error as well. And then I'll just pass in the error instead. And in here, after the catch, I can just put in a finally. So we start the loading up here. And we just need to remove that actually, because we have it set to true per default. But within the finally, regardless of whether an error happens or not, what we'll do is we'll just set is loading to false, like that. And this should then be enough to actually load the play URL for the video for each of these clips. So now that we have the play URL, let's just try and actually show the clip down here. So inside this div, I'll put in is loading URL. And then I'll say if we are loading, then I would like to show a div. Inside this div, I'll put in a loader2, and I'll just close the brackets like this, and then say class name, import it first of all. The class name should be text, muted, foreground, and then age 8, width 8, animate spin. And then for the outer div, I can say class name, flex, age full, width full, items center, justify center. And then I'll just need to add an else statement. So right now we have the if statement, so if this is true, and the else statement, if it is false, is going to be another if statement, so a nested if statement. So if the play URL is available, then we'll render out a video. This video should have the source be the play URL. It should have controls, so you can like pause it, etc. And then we'll say preload metadata, and we'll say class name, age full, width full, rounded, MD, and object cover. And then we just need an else statement for the nested if statement as well. So this will be a div. And then inside this div, I'll put in play like this. And that should come from Lucid React. So if I just say play, hopefully we should be able to import this from Lucid React. Good. And then for play, I'll then say class name, text, muted, foreground. I can say age 10, width 10, opacity 50. And then right now we see loading dashboard. If I go under my clips, we can see that it loads, and then we see the clips after a couple of seconds. I'll just do some styling for this one as well. So I'll say class name, flex, age full, width full, items center, justify center, and leave it at that. If I then reload over here, go back to my clips, we can see it like this. And if I then just try and click one of these,
there's much discipline in the board.
We can see that we're able to control the clip.
And
and we can also see the subtitles down here. One thing we're not able to do though is have a button right now that says download. We'll just need to implement that, because right now we can only click download here. But I would like a button that specifically says download. So going down here and then saying div, class name, flex column, gap2, we can put in this button, and this button should say download. So I'll just say download like this, and then just import the button. And then over here we can see a download button now. Then for the variant, I'll just set this to outline. I'll then just also say size small. And then what I'll do is I'll put in a download icon into the button. So I'll say download from Lucid React. And then I'll say class name, MR 1.5, H4, width 4, like this. And this should then create the button that looks pretty nice. And then actually we can use the same link that we generate in here, get clip play URL, to actually play the video, to also download the video. Because if you navigate to the link that it uses to play the video, it'll download the video automatically for you. So what we'll do is we'll just use that link and then automatically navigate the user to that link if they do click the download button. So I'll hop down and then create a function, const handle download is equal to a new function. And then the way we're going to do this is that we're going to say const link is equal to document dot create and then element, and we'll create a new anchor element. Then we'll say link.href, so we'll set the link that it points to, this anchor element, to the play URL. Then what we'll do is we'll say link.style.display is equal to none, so we don't really want to show this link. And then right here, play URL, we'll then only do this, so I'll just say if play URL, just to get the types right. And then below this, we'll just say document.body.append, and then I'll append the link to the body. So in here, we just create a link, or the definition for how the link should look. Then we actually append it to the body, so we append it to the website. It won't really be shown though, because we have display none set to it. But then when we do have this link, we can then automatically click it for the user, and then take the user to that page to automatically download the video. So after appending it to the body, we'll say link.click, like this, and then we'll remove the link from the body again. So down here, I'll say remove child, like that, and this should just be a append child as well. And then we can take this handle download, hop down to the button, and then we can say on click. And then when we do click the button, we will handle the download. So right now, if we click this download button, let me just see, it starts downloading the video. If I click this one, it starts downloading that video as well. And we can then see the clips are downloaded. So if I click one of these and then open it up, so I just dragged it up to my other screen, we can then see the clip.
Did you?
Oh, yes.
So it seems to be working just fine, which is great. And then if we just reload, just to make sure that everything looks fine, it loads as it should be. Then if we make it mobile size, we should then be able to see that it also works pretty fine. I do want to create some spacing between these two though, because as you see, they're very close to each other. So what I'll do is I'll just find this upload and generate clips. So this button right here, that is right there. I'll just say margin top 1. I'll just say 2 actually, to create some more distance. So now they're a little bit more spaced apart, which is a little bit better in my opinion. But otherwise it looks totally fine for a mobile view right here. Cool. So now that we're able to upload clips and also see the generated clips in the dashboard, we can go ahead and create the Stripe logic for buying credits. So first of all, I'll just create the actual page itself that says buy credits. Right now it takes it to a 404 because we do not have this dashboard/billing. So let's start out by creating that page. So first of all, I'll close down these pages right here, and then I'll hop under app, and then I'll create under dashboard a new folder called billing. New folder, billing, right there. And under billing, I'll create a new page.tsx, like this. Inside this file, I would like to first of all make it a client component, so use client. Then I'll say export defaults function billing page, like this. Then I would like to return some HTML. I'll just return a div first of all, like this. And then we can navigate to the actual page. So if I click buy more right here, or right there, we should be able to see the page. And as you notice, we still have the navigation header up here. And that is because this page is also wrapped inside the layout.tsx that contains the nav header. So that is the power of using these layout.tsx files. So if I close this down, we can go ahead and fill out the contents of the page. So first I'll say class name, mx-auto, flex, minimum width 5 XL, like this. And then what we can do is say flex column, space y8, px of 4, and a py of 12. Inside this div, I'll put in one more where I say class name, flex, and then items center, and then gap 4 between the elements inside the div. Then we can put in a button, and then inside this button, we'll just need to import that. I'll put in an arrow left icon. So this is going to be the back button for the page, because right now if you click buy more, it takes you to the page, but I will need some way to take us back to the dashboard if you would like to do that. So I'll create a button with an arrow and then some text. So the arrow left icon right here. We'll import that from the seed React. Then we'll say class name, size 4. And then I'll just put a link inside the button. So I'll hop in here and say link. Just save that. And then I'll wrap this arrow left icon with the link. So I'll say next link. And I'll say inside the button, variant, outline. And I'll say size icon. And I'll say as child, like this. And then we just need to import the link and set the href to /dashboard. So it takes us back to the dashboard whenever we click it. So let me just try that. So it takes us back and forth like it is supposed to. And then under this button, I would like to put in some text with some explanations. So I'll say div and then class name flex1 space y2 and text center. Then inside this div, I'll put in an h1 that says by credits. I'll give this h1 some styling, text free Excel, font bold, tracking tight, and also on large and small screens, I'll say text for Excel, like that. But I do actually want to center this text right here in the center and then still have the button without the button pushing the text a little bit to the right. So let me just see, we'll just fix this spelling error. And then the way I'm going to do this is just by changing this code a little bit. So as you can see, we have a pretty high minimum width. So it is okay for larger screens, but for smaller screens, the width is way too much. So I'll just remove this class right there. And then I would like to put on another class because as you can see, this text is not completely centered in the middle of the screen. It is pushed a little bit to the right by this button. So what I'll do is I'll make this relative. And then I'll take this button and then say class absolute. Then I'll say top 0 and left 0. And that should then fix it for this down here. I might be able to remove this. And then up here I can say justify center. And that should center the text without being affected by this button, like this. So now if we go under this by credits, I'll put in a paragraph that says purchase credits to generate more podcast clips. The more the more credits you buy, the better the value. And that is how we're going to structure the pricing of the clips as well, the packages. So I'll say class name text and then muted foreground, like that. And then I can see we made some spelling errors again. So this should be text and not this. So I'll just actually do a solution-wide search for this to make sure I didn't mess up any other places. So right outside this div right here. So right out here, I'll put in another div that should contain the grid of the pricing cards. So I'll say class name, grid columns 1, gap of 8, and MD, so on larger screens, I'll say grid calls free, like that. In here, I would like to loop through the different pricing plans and then render out different pricing cards, which is going to be a component for itself. First of all, I'll just define the pricing plans though. So for the type for the plans, we'll say interface pricing plan, and that is going to be a title that they contain as well as a price. A pricing plan also needs a description. A pricing plan also needs features. Each feature is going to be a string, so we'll have an array of those features. We'll have the button text, which will be a string. We'll also have a button variant. So to get those and get the type right, we can say variant props. Then we can say type of button variants. And then we can say we're going to set variant as the default one. Then we can say is popular. So for the popular plan, we would like to render the card a little bit different. So that is just going to be a boolean. We'll have save percentage. That is going to be a string. And we'll have price ID, which is what we're going to redirect the user to whenever they click buy. this will be a price ID. So I'll just say price ID. So let me just hop into the server actions and just create another one for Stripe. So I'll say stripe.ts. In here, we'll just export, I'll just say use server first of all. I'll export a type because we're going to use them in here as well. So I'll say export type price ID is going to be equal to a small package, a medium package, and a large package. And then we'll come back to this later on when we implement Stripe. We just need this type. So we can then say price ID like that. And now with the types in place, we can go ahead and define the actual, now with the type in place, we can go ahead and define the actual pricing plans. So I'll say const plans. And each plan should be of the type pricing plan. So we'll have an array of those. So we're going to need, first of all, a small pack. Here the title will be small pack. And then the next prop should be price. The price is going to be $9.99 US. The description is going to be something like perfect for occasional podcast creators. We're also going to have the features. The features will be 50 credits. It is also going to be no expiration. And it should be download all clips. And then the next property we will set is going to be the button text. That will just be buy 50 credits. That'll be the button text on the card. Then we'll have the button variant. This will just be outline. And then for the price ID, we'll set this to small because it is the small pack. Then I'll copy this pricing card right here. And then we'll call this the medium pack. This will be $24.99 US. We'll then have best value for regular podcasters. And we can then say 150 credits instead of 50 credits. And we'll just say 150 here as well. The button variant should just be defaults. And we'll then just also say is popular true, so we can make sure to render it a little bit different because this will be the middle card. The save percentage is going to be save, and then it's going to be 17% between these two prices compared to how many of the credits you get. Then the price ID will be medium like that. And lastly, I'll just copy in this one right here. This will be the large pack. This will be $69.99. And then this will be ideal for podcast, studios, and agencies like that. And for the credits, we'll give them 500 credits. And then we'll say buy 500 credits, button variant, outline, save 30%. I'll just remove this percent because we already have the percentage sign. Then I can put in large as the price ID. And then going down, we should be able to render out these pricing plans. So I'll just hop up actually and then just create a function called pricing card. This should receive a plan, which is of the following type, plan, pricing plan. Then in here, we'll just return a React fragment. So we'll just render these out inside this grid. So I'll say plans.map. And then I would like to, for each of these plans, return a pricing card where the key is going to be plan.title and the plan is going to be the plan like this. Then hopping up to the pricing cards, we can go ahead and render those out. So each pricing card should be a card. So I'll go ahead and say card like this, and then I'll style the card as well. So I'll say class name, and we'll just do this. And then first of all, I'll put in this cn helper functions from libutils. So what this allows us to do is to add classes to the class name right here based on a specific variable, so whether it's true or not. So the ones that should always be there is going to be relative, flex, and flex call, like that. And then for the next parameter, I'll say plan that is popular, and then I'll say and border primary, and I'll say border 2, like this. So now we have these three plans being rendered out. So inside the card, if we just open that up, I'll say plan that is popular, and diff most popular. So now we can see this, we have most popular twice. So this one needs to be false because only this middle one is the most popular one. And then we'll just style this to make it look nicer. So this most popular diff, I'll say class name, bg primary, text, primary foreground. And then I'll say absolute, top 0, left 1/2, minus translate x 1/2. And then I'll say minus translate y 1/2. I'll say transform, rounded full, px3, py1, text small, and font medium, like that. So as you can see where we're going, we are taking this element and then we are lifting it up just above the card. So we have to use absolute to position it relatively to its parent element, so this card right here. And then what we do is that we first center this element inside the card. So we say left 1/2. And then what we can do is we can say minus translate x 1/2. So if we just remove this, you can see that right now it is being centered vertically, but it is the left point that is being centered vertically. So by adding this translate x 1/2, what we do is we move it manually the last half width of this element to the left to actually make it fully centered. So if I do the same with translate y 1/2, if I just remove that, we can see that it is right now at the top, but it isn't a little bit over the card. So by translating it half a width over the card, we can make it look like it is floating above the card like this. So that is why we use these translate and transform CSS classes, as you see. And then if we hop under here, we can then say card header, and then we can say class name flex1. And then for the card header, I'll just go ahead and import that. And then I can put in a card title as well. I'll then just say plan.title, import this, and now we can see the pack names as well. Then right below this card title, I'll then put in a div where I say class name text for Excel, font bold. So this will need to be text like this. And in here, I'll then just show the price. So I'll say plan.price, put in a forced spacing like that. And then right below, we'll put in the save percentage. So I'll say plan.save percentage if there is one. If there is, we'll put in a paragraph where we say plan.save percentage like this. Inside this paragraph, we'll say text small, font medium, text green 600. So it'll look like that. And below this, we'll put in a card description where we say plan.description. I'll save that. And now you can see we have that as well. And if I then take this and make it on a large screen, you can see how it becomes 3 columns instead of 2 columns, like we defined up here. So going up to its parent component, we can see that we have 3 columns on larger screens over the medium breakpoint, but on smaller screens like we see now, we have a single column. So that's why we did that. And then under this card header, we're going to put in a card content component. Inside this one, we'll say class name, and then space y2. Then I'll put in an unordered list, which is going to be the bullet point list for all our features. So I'll say UL for unordered list. In here, I'll say class name, text, muted, foreground, space y2, and text small. Inside this unordered list, I'm going to loop through the different features for each plan. So I'll say plan.features.map. And then for each feature, I'll get the feature and the index of the feature. And then I would like to render out a list item, li. So an unordered list can contain list items, which will then become the bullet points. Each of these list items should have a check icon. So just like a check mark. So it'll look like that. Then I can say class name, text, primary, size 4. Then right below this check icon, I'll put in the actual feature name. So it's going to be displayed to the right of it probably, like that. So it'll look like this. And I would like to show these side by side. So that is why I inside this list item is going to put in flex items center and gap2 to space them out a little bit. Then inside this list item, because we're inside a map, I'll put in a key, and the key is just going to be the indexes for now, like this. So this is going to show us the actual cards themselves and the contents of them, but it is not going to show us the buy buttons, so we'll just need to create that. So I'll create a new one called card footer. Inside the card footer, I'll put in a form like this. And then for the form, I'll say class name with full. So this should contain a button that allows us to create a checkout session with Stripe, as we explained over here in the IntelliDraw. So Stripe purchase flow. So right now, when the user clicks buy, we should create a checkout session. So right now we are just about to create the buy button. And then when the user does click the buy button, we'll create a server action for creating this checkout session, and then redirect the user to this checkout session. So that is what you see right here. Cool. So hopping back into our code like this, we can go ahead and get started with the form for containing the button that will redirect the user. So inside this form, I'll create a button first of all. So I'll say button, and then I'll say variant. This will just be plan.button variant, like that. Then we'll say class name with full, and we'll say type submit. So now we see this button, but it doesn't really have any text. So we can then say plan.button text as we defined up here. So each plan should have their own button text, and that is what you see on the plans now. And then I'll wait with setting up Stripe so that we can actually click the button and get taken to a checkout session until we have just finished the rest of this page. So for now, I'll just hop under the pricing cards, and here I'll just add some additional information. So right down here, under this div, I'll put in how credits work, so just a small section with some explanatory text. I'll put in a div here and say class name BG muted at 50%, and then I can say rounded, large, and padding 6. Then below this, I can put in an h3. I can say class name margin bottom 4, text large, font semi-bold, and I can say how credits work, like this. Then right below this, I can put in an unordered list, and I can then say list item 1 credit is equal to 1 minute of podcast processing, like this. And then I'll just style this unordered list a little bit. Text muted foreground, and then a list disk, like that, and space y2, padding left 5, and text small. And then I'll just add some more list items. So the second one is going to say the program will create around 1 clip per 5 minutes of podcast. Under this list item, I'll put in credits will or credits never expire and can be used anytime. And then right under this one, I'll create another one. Longer podcasts require more credits based on duration, because a longer podcast will be able to generate more clips. And lastly, all packages are one-time purchases, not subscriptions. Cool. So this is just some explanatory text. You can change this to whatever use case you would like to, if you decide to deploy this as a SaaS or software as a service application. One thing you probably have noticed is that it breaks kind of weird up here, so it doesn't really look that good. It isn't a problem on larger sizes or smaller sizes, but it is a problem on exactly this breakpoint, which seems to be medium. How I'm going to fix this is to go up to most popular, and then I'll put in a white space, no wrap, like that. So whenever we resize it, it looks great on all screen sizes, so we don't really allow it to break. So that is basically what we did right there. Good, so now our billing page is done, and we only need to implement the logic actually letting the user buy packets. So what I'll do is I'll hop in and close these down first of all, and then I would like to search for Stripe, and then we'll go sign up for Stripe. So hop into Stripe, say sign in, and then create an account or sign up if you already have one. I'll just sign up and then come back whenever I have done that. Great, so I just signed in, and right now I'm not on the dashboard, but if you are signed in, you should be on the dashboard. So what I want you to do is click up here and then go to create a sandbox. So you should be able to find it somewhere like this, create sandbox, and then I'll just create a new account from scratch. So if you're deploying this to production, you do not need to create a sandbox, but because I'm just playing around right now by creating this SaaS, I'll be creating a sandbox. So otherwise you'll just need to create a new account, just like the one I have here, for example. So let's start by creating a sandbox just so we can test around and simulate things. So I'll say create sandbox, create a new account from scratch, and not copy my existing account. Then I'll say AI podcast clipper, or whatever the name of your business is going to be. Then I'll say create sandbox. And then this should be ready in just a second. So now we're in a testing sandbox. And then the first thing I would like to do is just hop in and say npm stripe. I'll take this one, and then I'll just run npm install stripe in my terminal, like that. And we might need to append this legacy peer dependencies instead to make it work. Good. So now that we have Stripe set up, we'll need to do a couple of things. First of all, I'll create a product. So right now we have 3 different plans. We have a small, medium, and large pack. So what I would like to do is hop under my product catalog, create a new product. This one should be called a credits pack. And then I'll just say one-off. If you want a subscription, you can say recurring. And then I'll say USD. And then the small one should be $9.99 US. And then I'll say add product. Now we have a credits pack. You can also add an image, for example, and text if you would like to show that on the checkouts page. So under here, we can see we have one price right now, and that is just going to be the small pack, so the defaults. I would like to create multiple prices under the same product. So you can structure your Stripe products in a couple of different ways. You can create a product for each of these, but you can also create a price ID for each of the products, meaning you only have one product, but with multiple prices. And that is what I'm going to do, because a credits pack is just a credits pack or product in my opinion. So I'll say plus right here, add a new price, one-off. Then I'll switch to US dollars, $24.99. And then for description, I'm going to say medium pack. And I'll create this price. And then I'll create another one-off. And then this should be US dollars as well. And then this should be $69.99. And then I'll say large pack, create price. And then for the default one, the small one, I'll just edit the price actually. And for the description, I'll say small pack. And then say updates. So now we have these 3 price IDs for our credits pack. And then we're going to need these price IDs, or at least something referring to these price IDs within our application. So what I'll do is I'll go into my application. I'll just close down all these folders, hop into my environment variables, and then I would like to define the IDs of these prices in here. So the first thing I'm going to do is to define the Stripe small credit pack. And then I'll just copy this down twice, call this medium, and then I'll call this large right here. So the first one is going to be the small pack. Then I'll say copy price ID for that. For the medium pack, I'll say copy price ID. And for the large pack, I'll say copy price ID as well. So that is what we're going to need to know which pack the user actually bought. And then to interact with Stripe, we're going to need a publishable key and a secret key. So I'll copy this API key right here. And then I'll say Stripe secret key. That's the first one. And we also need we need to preface this with next public. A next public Stripe publish Apple key, like that. So for the publishable key, we can click that, paste it in here. And for the secret key, we'll copy that, paste it in here. Make sure you get these correct, so you don't give the user credits for a large pack if they buy a small pack, for example. For the publishable key, you can know it by PK, and for the secret key, you can know it by SK. And then by prefacing this environment variable with next public, it means that we can also access this environment variable on the client side and not just on the server on the in the application. So to be able to use Stripe webhooks, we're just going to set up a base URL as well. This is HTTP and then localhost 3000, because that is what our application runs on during development. And then we are going to set up a Stripe webhook secret. So whenever Stripe sends a request to us, so a webhook, we'll need to use the secret to verify whether it is actually Stripe who sent us the webhook or whether it was some malicious source who was just trying to mess up our software. So I'll go under webhooks. In here I'll say create event destination. I would like to test in a local environment. So if you're doing this in production, you'll need to add an endpoint, and this endpoint URL should correspond to what webhook you create under source app API, for example. But we're just going to test in a local environment. So to do this, we'll need to first of all run Stripe login. So I'll hop in here, press terminal, and then I'll put Stripe login into my account, copy this URL right here, hop under this page and just import this, or just enter this. And then we'll just need to verify with my phone. So that is what I'm going to do. And then I just verified. So now I can click allow access, and access is now granted down here. So that should be good. And then we'll say Stripe listen forward to, and then we'll need to forward it to whatever webhook we're going to define. So we are running on 3000 down here. And then you can see this because we are running on port 3000 locally. And then the path we're going to define the webhook for is going to be under API and Stripe and then /webhook. So go ahead and copy this command right here if you want. I'll just paste it in like this right now. This way you can just save it and paste it in more easily next time. So I'll just go ahead and run this. And then this way, whenever we do something with Stripe, such as buy something, this will then forward the event back to this endpoint, which we just defined right here. And this way we can handle the webhooks from Stripe in a simulated way and thereby update the database if the user buys credits, etc. So then for the Stripe webhook secret, this is the one. So I'll take this and paste it in under Stripe webhook secret, and then I'll say done. If you run this in production, you'll get a Stripe webhook secret from the dashboard right here, I suppose, and it won't be generated automatically in the terminal, but that is just what I think, just so you are aware of that. Cool. So I'll just go ahead and hop into my env.js, open this up right there, and then we'll just need to add these different environment variables in the env.js just to make sure that they are type safe. So going down to under process video endpoint, I'll paste in this right here. I'll actually paste it in down here because we'll need it on the client. So I'll paste this in and then say set.string. And then right below this, right above this, up here at the server. So these are the variables that we want to be allowed to be used on the client. And these are the ones that we want to be allowed to use on the server. So this one is the next one, and this should only be available on the server. This is set.string. Below this, we'll put in the Stripe small credit pack. Under this, the medium pack. Under this, the large pack. Under this, we'll put in a base URL. And lastly, we'll put in a Stripe webhook secret. And now the last part is just setting all of these up down here. So pointing the actual process environment, that variable, to the ones we defined up here. So the first one is going to be next public publishable key. So this will be the following. Below that, we'll put in the Stripe secret key, which will be process.env.stripe secret key. Below this, we're going to have this small credits pack, process.env.small credits pack. Then below this, we'll have the medium pack, like that. And lastly, we'll have the large pack. And then we also have a base URL, like this. And below this, we have a Stripe webhook secret, like that. So now we have defined all of the variables, and we should be able to use them within our program. And we have also set up our products, which allows us to actually buy something within Stripe. So I'll just go to home right here, and then whenever we buy something, we should be able to see it in the dashboard as well. So going into our application, I think I'll just refresh, because right now it says invalid environment variables, and that is because we just updated some of these files and the environment variables. Good. So going under actions and then Stripe, we should be able to create the server action for generating the URL where the user can check out a product and buy it. So hopping back to CalendarDraw, right now we created the button that the user can click to buy something. So when the user does buy it, we should call a server action in the Next.js application right here. This will then call the Stripe API and create a session URL for us, and we can then redirect the user to that session URL. So right now, when the user clicks buy down here, let me just hop up, clicks buy right here at the button text, we should then create a checkout session with the server action. So I'll hop in under Stripe.ts and say export async function, create checkout session, price ID. So that is what we receive whenever we click this buy button. First, I'll say const server session is equal to awaits auth. So we'll get the currently logged in user like this. Then we can say const user is equal to awaits, and then db, and I'll just need to import this .user.find unique, and I'll just say find unique or throw to make sure that the user actually does exist. Then I'll say where id is equal to server session.user.id, and I would like to select the Stripe custom ID from that user. So I'll say select Stripe custom ID true like that. And then after we've created for the user, we can then say const session is equal to awaits Stripe. So we'll use the Stripe API. So just like we initiate a new S3 client, like we do right here, we'll just need to initialize a client for being able to interact with the Stripe API. So I'll do this up here, just above the type. I'll say const Stripe is equal to new Stripe, and then I'll say env.stripe secret key. So env.stripe secret key, and then I'm going to go ahead and say API version, and then just put in 2025/04/30.basal, and now we should be able to use this to query the Stripe API. So I can say stripe.checkout.sessions.create, and then we can add the specific product that the user wanted to buy. So let's say the user clicks on this one. Well, then this is the product we would like to show in the cart whenever the user checks out. So let me just go back here. So what I would like to do is say line items, and then you can add multiple things to the cart whenever the user buys something, but we only want to add one credits pack at a time. So we'll just say price, and then we can pass in the price ID. So we'll just need to create a mapping table from these and then to the actual price IDs, which we define inside the environment variable file like this one. So if you give it small, then what I want out is this one right here. So what I'll do is I'll say const price IDs record, so a dictionary basically with a price ID and a string is equal to, and then if you give it small, you get out environment.stripe small credit pack, and then if you give it medium and large, you get out their respective ones like this. So down here I can now say price IDs and then pass in the price ID which we got from up here, and then I would like to also say quantity 1 because you only want to buy a single one at a time. And then I would also like to connect this purchase to the actual user in our system. So the way we're going to do this is via this, let me just scroll up, via this Stripe custom ID, which we then created or got from Stripe whenever we signed up our user as well. We still need to implement this, so I'll just open up the config, I'll just open up the actions and then auth right here, and then we'll just need to do that as well. So this will just make sure that we sign up a user in Stripe whenever we sign up a user in our system as well. So I'll just go ahead and say const stripe is equal to new stripe, and then we'll pass in the env dot stripe secret key. And then what I'll do is I'll say whenever we hit this function, we'll create this new customer in Stripe, and then we'll take this Stripe customer and then put this ID we got from Stripe into our database. This way we can connect our own users with the Stripe users. So because we haven't done this until now, we'll need to just hop into Prisma, find our user, delete our user, because as you see, we do not have a Stripe custom ID, so it would actually fail if we tried to buy something with our user because it would just be undefined. So now that I've done that, I can go ahead and just sign out, and then I'll press sign up, and then say andreas@gmail.com, put in a password. Then if we hop in here, we should be able to see our user now. So if I refresh, we can see we have a Stripe custom ID, and inside Stripe, if I refresh this, hopefully we should also have a new customer. So if I click customers right there, we have andreas@gmail.com. So that is exactly what I mean. We have a customer, but also a user in our own system. Good. So under stripe.js, whenever a user buys something, I would like to also say that the customer buying something is user.stripe custom ID. The mode should be payment. And the success URL should be env.base URL. So we'll redirect back to the base URL, so our own website right here, whenever the purchase has been finished, /dashboard, and then we can just append a success flag, set this to true, just if you would like to show a toast that says successfully bought the credits or something like that. And then one thing we need to do is just wrap this in a dictionary, or just an object, sorry, because right now you can't just put these in raw into an array. Good. So now this crate gives us an error. So right now I think the thing it can't find is this stripe.custom ID because it can't be null. We can just verify by putting in an exclamation mark, and yep. So we just want to make sure that it actually is on the user. So I'll say if, and then not user.stripe custom ID. We'll then throw a new error, and then user has no Stripe customer ID. And this way it should always be string down here because we checked that it exists beforehand. Good. So now that we have the session, so if I hop back into CalendarDraw, now what this does right here is that it creates this call to Stripe, and then we are getting a session ID returned, and that is what is stored inside this session. So now I can say if, and then not session.url. Then I'll throw a new error, failed to create session URL. Below this, I'll say redirect with next navigation, pass in the session.url like this. So we had our session URL created, and then we redirect the user to this session URL like we see here. And that is what we do within the server action with this line right there. So now if we hop back into dashboard billing and then go into the actual form, we can then say action. So this is what happens when the form is triggered when you click this button right here, which is type submit. Then we can say create checkout session and pass in the plan.price ID. So as you can see, this price ID up here, large, is then going to be passed in right there. And then if I go into this, the price ID will match one of these items up here, and then we can get out the specific price ID, and then the user will be able to purchase that. Cool. So hopping back into our application, just refreshing, I'll then just click buy credits, and then I'll say buy 150 credits, and then this should take us to this checkout page where we have the credits pack, and then also the price. So let me just check. This is $9.99. This is 25 US, and this over here is 70 US. Good. So the price IDs seem to match just fine. So if we hop back into the draw right here. Right now, the user has been redirected to this checkout session. That is what you see on this page whenever you click buy. And then the user then needs to fill out his information to complete the purchase. And then when the user has done that, this will make a request to Stripe, which will then send a webhook event back to our Next.js backend. So we'll just need to define this endpoint, which will be hit by the Stripe webhook event. So what I'll do is hop under source and then app API. Then I'll create a new folder called webhooks, like that. And then I'll create a new file called, a new folder called Stripe. In here, I'll put in a route.ts, and then we can define the endpoint which will be hit. So remember, going into the terminal, if I just go up to where we ran the Stripe command, I think it is down here. We set it up to be API Stripe webhook. I'll just go ahead and stop this actually. And then I would like to call this webhook/Stripe. And then actually webhooks/Stripe in case we have more webhooks. And then down here, I'll just run the same command again. So now it forwards webhooks to API webhooks/Stripe instead of Stripe webhooks. And then I'll just copy this from the environment variable files into this route like this. And then it'll just be / 2 times. And then what we can do is we can first of all initialize Stripe. So just like we did here, we can initialize Stripe inside our webhooks, import this from Stripe, and then I would like to say const webhook secret is equal to env.stripe webhook secret. So we'll just import this like that, and then we can export the actual endpoint. So this will be export async function post. So this will be hit whenever you make a post request or a request with the post HTTP method to this specific endpoint. So we'll receive a request of type request. And then in here, we can put everything inside a try catch. And then the first thing we would like to do is just to verify that Stripe is actually the one sending us this webhook and not some malicious person over here, malicious. So it could be some malicious source that would just try to invoke our webhook and give themselves credits or like destroy something. So we receive a webhook key from Stripe, that is the secret webhook down here, which we can then use to verify that. So what I'll do inside the try is first of all say const body is equal to awaits a request dot text. Then we can say const signature is equal to request dot headers dot gets, and then we would like to get Stripe signature. And then let me just see, this can be null. So if it is null, we'll just give it an empty string. Then what I can do is say try events, and let me just define a let event stripe dot event, and we want to set the value right now so it can't be undefined. So we'll say event is equal to stripe.webhooks dot construct event, and then we'll pass in the body, the signature, and the webhook secret from up here. Then down below, if an error happens right here, what we'll do is that we'll reject the user. So I'll say catch error, and then we'll say console.error webhook signature verification failed, and we'll just give it the error as well. So basically, when we construct this event, it'll check whether our webhook secret, which is defined in here, matches the one from the signature of the request, and if they do not match, we'll then get an error in the try catch, and then we can reject the actual request. So I'll then say return new next response like this, and then I'll say webhook signature verification failed, and I'll say status 400. Good. So after verifying the request, everything should be good down here. So then I'll go ahead and handle the actual event. So I'll say if event dot type is equal to checkout session.completed. Then what I would like to do is first of all get the session. So I'll say const session is equal to events.data.object, and then I'll say s stripe.checkout.session. So now if we have the session, we can see that we have the session like we defined. Then I can say const customer ID is equal to session.customer. So this customer ID right here is then the same customer ID that we also set inside schema.prisma. So right here we have a Stripe custom ID. So this way we can check what the custom ID is of the request, and then find the user in our database that has that custom ID, and then that is the user who made the purchase, and that is also the user which we need to increase the credits for. So now we can actually retrieve the lines which, or the order lines. So the order lines or line items are the items that the user bought. So I can say const retrieved session is equal to await stripe.checkout.sessions.retrieve, and I'll pass in the session.id, and I'll also say expand line items because we would like more data about the line items. And then if I hop back in and search for line items in here, as you see, we put this specific price ID in as a line item. So this means that we can then figure out what product the user bought, because that is just going to be the price ID of the line item that we put in whenever we initiated the session. And then after doing this, we can then get the specific line items. So I'll say line items is equal to retrieved sessions.line items. Then I'll say if line items and line items.data.length is more than 0. Then I'll say const price ID and get the price ID out from the line item. So the product that the user actually bought is going to be equal to line items.data. And since the user is only able to buy one product at a time, we'll just grab the first one because we know that there will always only be one product or one line item. Then I can say .price.id. If it is not there, I'll then just say undefined. And then because it can be undefined, I'll say if price ID. And then now that we have the user who bought the product and the product that the user bought, we're then able to determine how many credits to add to the user's account. So I'll say let credits to add be equal to 0. And then I'll say if the price ID is equal to environment variables dot stripe small credit pack. Then we'll say credits to add is going to be 50. Just like we promised. Else if we'll pass in the following right here. This will be Stripe medium credit pack. And then credits to add will then be 150 like we promised the user. And we'll then just add the last else if as well. So this will be the large pack. And this will be 500 credits. So this variable will now contain the amount of credits to add to the user's account. So now the only thing we need to do is just await db.update, so update the user's row in the database. And we'll need to update where the Stripe custom ID, so we can find the user by his Stripe custom ID because the Stripe custom ID is unique, as you see right there. So only one user can have a specific Stripe custom ID. So where the Stripe custom ID matches the custom ID from the webhook. And then going up here, we'll just make sure that this is a string. I know it is a string, so I'm just going to cast it as a string. And then I would like to update the user's row with credits, and I would like to specifically increment his credits with the credits to add like that. And then after doing this, then everything should have been done successfully. So down here we can return a new next response. We'll return null as the body and status 200 like this. Good. So this is then if everything goes as it is planned to. If we do catch an error, we'll say return new next response, and we'll then just include webhook error and say status 500, so an internal server error. And for good order's sake, we'll just say console.error, just so we have it in our logs, error processing webhook. And then we'll just pass in the error right after that as well, like this. So what we just did right here was that we created the webhook that is hit whenever Stripe return the webhook to us. And then we extract the price ID from the webhook data. So that is what we did right here. We got the line items, so the items the user bought. We know he can only buy one item at a time, so we just say 0. And then we can figure out how many credits to add based on the price ID. And then what we do is we update the credits based on the price ID in the database. So that is what we do right here. This will then update the database. And now the new credits should appear in the dashboard when the user navigates to the website. So let's just try out the full flow. I'll hop into the website, and then right now I have 10 credits. I'll just buy this small pack. I'll put in 42 for all the numbers, and then I'll say 1, 2, 3, 4, and then I'll say 1, 2, 3 here, and then I'll say Andreas, and then I'll say test, and click pay. And then we can see if we get any errors or whether it works as we want it to. So right now we have 60 credits, so it actually matches that we bought these 50 credits. So now I'll just try with the other 2 packs. This should give us 150, meaning we should get 210. So I'll just buy this one as well. And let me see, 210. And then we can just buy the last one for $70. 1, 2, 3, 4. Oh, it needs to be somewhere in the future. Like that. And then I'll say Andreas test again and press pay. And then we have 710 credits. So all our free packets actually work now, which is great. And additionally, they're also mobile friendly, which is great too, because this means people can buy credits on the mobile as well. And then one thing I would like to test as well is that if the user has 0 credits, then they cannot create a video. So down here, the status of the uploaded clip will then just be something like no credits. So we have set this up already. We just need to test it out. So I'll go in and find the actual user. And under credits, I'll set this to just 0 credits, save one change, hop back into our program, and then just refresh. So now we can see we have 0 credits. I'll select this file that is 5 minutes long, upload and generate clips. And then when this is done, we should be able to see that this happens in here. So the first step is going to be checking the credits. And when this is done, it'll then set the status to no credits if the user doesn't have any credits. So right now we see queued. If we refresh, we can then see no credits. So the user is not able to process videos unless they have credits. So that is great as well. In here, inside the ingest functions, we should be able to see in here as well that we check the credits, and then the next step that is run is set status no credits. So both things work perfectly fine. Great. So right now, a couple of things you should know. We have not set up the actual dashboard page for the SaaS. So right now, if we go to this page right here, this page is going to be probably your landing page. So whenever the user visits your website, and this could then have a button that links to the sign up form. So login or sign up if you have that. If you would like to do that. So inside this page, if you would like to edit the page that I just showed you, let me just find that. So this one right here, you would have to go under app and then under page.tsx, and you can then see all the HTML for the landing page. You can even just use an LLM to generate a quick landing page if you would like to. And then you could use some screenshots from the dashboard right here to show what the app does, and also include some of these clips that has been generated on the landing page to show how powerful it is. Good. So one more thing I would like to do before moving on and deploying the app is tweaking the design a little bit. So I found this service called tweakcn. So because we're using Tailwind CSS and Shadcn, we can pretty easily change all the styling of the app to a look that fits us more by changing this globals.css file. So in here, all of the different styles are actually defined. So what we can do is that we can hop into this tweakcn, and then we can find a theme that matches what we would like to, and then we can just copy the entire theme into this globals.css, and that'll actually change the entire app for us automatically. So right now it is just the default and basic Shadcn theme, but we can change it so it looks unique. So if you go in and then pick one of these, for example, this, or this, you can see how the app changes completely based on the theme. So what I would like to do is hop in and then say start customizing. One that I really like is this one called Caffeine. So I'm just going to pick this one and then say code. Then I'll copy this entire thing, hop into the globals.css, and then I would like to remove from dark, roots, and then all the way up to inline. This means this will be left, and then I can paste in the Caffeine theme. If I then hop back, we can now see that the theme is completely different. So now it looks way more custom and way better than it did just with the standard Shadcn theme. And we can then also just try and log out just to see how that looks. So this is going to be the login form. And this will be the sign up form. So as you see, this is much better than before. So if you want to give your SaaS a personal look, please go into Twixen and just try that out. I just learned about it yesterday and I think it's super cool. So just try that out if you would like to. Good, so let me just go ahead and close this globals.css file now. Then before we can deploy the front end, we just need to fix a couple of things. So the backend is actually already deployed. So we know this because we have this under live apps in Modal, and we have used the live production with the actual authentication key for the entire time. So the backend is completely deployed now, and we just need to deploy two things. First of all, we need to deploy the front end to Vercel, and then I'm going to deploy the Inngest server to production as well, and that is free as well, of course. And then we'll just set up a basic database that is free on Vercel too, just so we have a database instead of SQLite that lies in here right now. So the first thing you'll need to do to get it deployed is go down here, and whenever the website is built, so whenever this command is run, it is going to run this linter automatically. And if the linter gives you any errors, it is going to not be able to deploy or build the entire app. So we'll just have to fix all these errors. It is pretty simple though. So if you click Control or Command and click the error, you should be able to see it in here. So the first type is this one: prefer using knowledge coalescing operators instead of logical ORs. So this just means that instead of using these, you'll just have to put in 2 question marks, and we'll just need to do this the places that it tells us to. So that is going to be there, as well as right here. And then we just need to remove the type right there because it says the assertion is unnecessary, so as is unnecessary. Then if we go down here, we'll just put in the null coalescing operators, and right there. And then right here we have an error of value unknown, so I'll just say I'll just make this a formatted string and pass it in this way instead, like that. And then I would like to scroll down to find this one. So we need to escape this apostrophe character with this one instead. Then going down here, we'll just need to fix that one. And then we have some unsafe assignments of any type. So if you hover this, we can see that it is any. So I'll just say as string because we know that it is going to be a string. So the way we do that is just by going up here and then say as, and then we take uploaded file ID, say that is a string, and then we also have the user ID actually, which is also a string because we pass in both of these whenever we create the ingest event right here. We pass in the upload file ID and the user ID. This is a string and this is a string as well. So that is why we can be sure of that. Then if we just scroll down again, all of these any actually relates to this uploaded file ID, so we won't really worry much about those. Right here though, we have an error, and I'll just say s, and I'll just say unknown, because it was unknown. And then we need to put in this one instead. Then down here, it is just something about the null coalescing operators once again. And then let's just see if we cleared up all the different lint errors, or whether we need to do a little bit more fixing. So this should be ready in just a second. So we have warning, warning, warning. This one still bugs out a little bit. So this error right here is unknown, and it can't really pass unknown into a string. So what we'll do, because this isn't necessary, is just to remove this right now. So I'll just go ahead and do that, because we don't really need to fix it right now. You can go ahead and fix it if you would like to, but it is only a log statement if you would like to see the printouts. These other ones, such as error, where it is defined but not used, and then also this one where it's defined but not used, etc. You can go ahead and clean these up if you would like to. You probably should do that before deploying to production, but this should run more than easily right now with no problems. So we should now be able to go ahead and build the actual application. So if we say npm scripts and then we say next build, we should then be able to create and optimize production builds. So I'll just wait for this to finish and then come back to you. And we just see that it finished building. So we got green check marks for everything. So everything seems to work just fine. And this also means that we can actually go ahead and deploy the application now. So first things first, I'm going to create a GitHub repository. So I'll say initialize repository, say initial, and then I'll just commit all of these different files to my repo. I'll publish the branch as a private repo. And then if we log into Vercel, we should be able to actually deploy this new application from our GitHub repo. So if you hop over to Vercel and then say login, you should be able to go to login with GitHub. So I'll just log in and then we'll see each other in the dashboard. So now we are logged in and we can say add new project. And then I'll find my AI podcast clipper, which we just created. And then I'll just say environment variables, and then we can add more. Oh, sorry, we can actually take the entire file and then we can do copy paste. So the ones we're going to need are these ones and also the auth secret. Let me just remove this. And then I'll take all of these ones down here and then I'll just say Command V and just paste all of them in. Remove this first one. And then over here, I'll just redo to just get these things back again. So we'll need to change a couple of things. We'll need to change the database URL as well as the Stripe secret key and also publishable key. And then you probably also want to change this endpoint authentication token both here and also in the Modal deployment if you would like to deploy to production at least. We also need to change this Stripe webhook secret. First of all, I would like to get the URL that is attached to this deployment. So I'll press deploy right now, and then it should probably fail because we reference an SQLite database. So I'll just fix that first of all. So if we hop into the schema.prisma, up here it is set up to be an SQLite. So we'll just change this in just a second. So right now we have this deployment which is building and it failed with an error, it says. So I'll say go to project. And then we'll start by setting up the database that at least make this not fail. So first of all, if we just say, go back to the root right here, then we should be able to say integrations and then Neon. So I'm just going to use this one because it is free. So I'll just say install for Neon. I'll just take this one. And there is a free plan right here. And then I can say continue. And this one should just be called AI podcast clipper DB. Then I'll say create. And now we have a database. So if I just select Prisma right there, I can put in PostgreSQL instead of SQLite for the provider. And then for the secret itself, what I'm going to do is just take the secret. And I think we just need to find the secret in here. So the secret, or actually all of these we'll need to set. So I'll just take this entire thing, hop into env, and then I'll actually only take this. It seems like we only need the first one, recommended for most use cases. And then for the database URL, we'll just set this to the database URL like that. And then if we go back into schema.prisma, then this was set up to PostgreSQL as well. So now if we do just close this down and then run a npm scripts db push, we should be able to push the schema to the database up here. So this Postgres NeonB DB database instead of the local database, which we've worked with so far. And everything seems to be working fine. Your database is now in sync with Prisma schema, so that is great. Then what I'll do is just hop under settings. I'll just hop into my application. So if I just go back to this one right here, what I'll do is just hop under settings, environment variables, and then I'll take the environment variable right here. And I'll just use this as the environment variable for the database URL. Like that. And that is definitely not it right there. This is the one. So I'll use this one as the database URL because we know that is the correct one, and save that. And that should at least fix the database problem. Then I'll try and redeploy and see what errors we get. So right here, I'll say redeploy, and then I'll say redeploy right there. So now we should be able to see the build logs again while we are building, and then I'll just come back whenever we get an error. So as you can see right now, it says fix the upstream dependency conflict or retry, and then it says force or legacy PS dependencies, and that is what we did every time we installed a package with npm. So to also do this in production, what I would like to do is hop into settings and then go to build and deployment, and then the install command right here will say npm install, and we'll say -- and I'll just say I instead of install, and I'll say legacy peer dependencies, and then I'll just save that. Then hopping back to deployments, I'll just try this again just to see if we can get it to even work. So if it doesn't work, it should fail within a couple of seconds. Great, so the deployment just finished without any build errors, and we see what we also usually see inside when we build. So we saw the same warnings that we got, and I would recommend you to go ahead and remove these if you deploy to production. If you're just playing around, it doesn't really matter that much. And then if we go to this URL right here, we should be able to see our application. So hopping to dashboard, for example, that should not work. It should take us to the login page right here. And we can also sign up if we would like to. Good. So before doing any of these things, I'll just go ahead and get the correct URL. So this URL right here will then be our new base URL for production. So hopping in under our deployment and then settings, environment variables, this base URL that we see down here is just a localhost right now, and it should be localhost if it is local, but right now because we're in production, we'll just put in the correct one and press save. And the reason this base URL is used is such that Stripe can redirect its webhooks back to the correct URL. So because we now have the correct URL, we'll also just need to set up a correct mrep webhook setup in here in Stripe. So I'll go into webhooks again, and then I would like to add an endpoint. And then this is not a test in a local environment. In a local environment, this is an actual endpoint. So I'll paste in our actual endpoint, and it should then be API webhooks Stripe like this. And then I would like to listen to some specific events. So if we hop under Stripe webhooks right there, this specific event right here is definitely one we would like to listen to. So we can select this event, search for it, and then we'll only be updated whenever we get this event in our code. So if we wanted to listen to other events, you could also do that. And then in that case, you would just say else if event.type is equal to, and then listen to that other event, and then you would handle that accordingly. Right now, we're only handling this event though, so that is the only thing we're going to care about. You could also have things such as customer deleted and a bunch of other events that will then fire whenever that happens. So if you take customer dot and then deleted, whenever you delete a customer in Stripe, for example, it will then fire an event back to this route.ts file. In here, you could then also delete the same users in our database, for example, if they were deleted in Stripe to keep it synchronized. So there are so many different options that you can use right here whenever you want to add events. We'll just use this one for now, and then we'll take this one. This is the local one. Then I'll say add endpoint. And then we just need to take this signing secret and copy that. And that is then going to be the real signing secret. So down here under Stripe webhook secret, we'll say edit, and then we'll put in the actual one and then say save. And this should then allow Stripe to send webhooks to our actual production deployment. So that was it for Stripe and also for the Vercel deployment. Now one thing we need to deploy is going to be Inngest, so the entire queue system right here. So we're going to search for Inngest and then deployment, and then we just see whether we can find this. We need to deploy it with Vercel. Then down here they have an official integration, so I'll just open this up and then connect the account. So specific projects, I would like to select this AI podcast clipper, say connect accounts. And then I'll just sign in with Inngest in the meantime. So I just did that and just signed in with Inngest, and then I was redirected back to this page. Then I can say I already have an Inngest account. And then we would like to deploy this with Vercel, so I'll say next. Is first of all just hop back into this page, so Inngest under Vercel, so under integrations. Then I'll say connect account again, specific projects, and just pick my podcast clipper frontend. Then I'll say connect accounts. And then I'll select this right here and then say save configuration. I'll then say continue to ingest Visual Dashboard. So as you can see, each Visual project will have ingest signing key and ingest event key environment variables set. So it'll set these environment variables for us automatically. And then the next time you deploy your project to Visual, your functions will automatically appear in the ingest dashboard. So we'll just do this, wait for it to complete the installation. And then if we now hop under our project again, and then under settings and environment variables, we now are able to see these ingest environment variables that has been automatically set. Then what I will do is just go under build and deployment, under deployment protection, and then just disable this deployment protection as well, since this can be another factor for not being able to connect to ingest. So if deployment protection is enabled, it might fail. So with these two things done, what I'll do is just go ahead and cancel this deployment right here. And then I'll just do a full redeploy again. So I'll say redeploy and make sure this existing build cache is not checked, so we can do a redeploy from scratch, and that you also deploy to production. And then we can just say redeploy and just wait for this redeploy to happen. And now the deployment is finished and you can see it is ready, and we have the 3 blue check marks. So going under deployments here, we should see this being redeployed as well, meaning that it is ready. So hopping back into ingest here, you want to make sure that under integrations, manage, and your project, it is set to enabled. And then going back here again, under apps, you should be able to see your app. So because I was testing 5 minutes ago before trying to actually deploy to ingest in front of you, I just archived the actual deployment. So I'll just go ahead and say on archive app. And then whatever you see is probably this right here, success, because you already redeployed, and then it should be ready to sync for you. So if you click up here and check app health and then check, you should be able to see that there are no issues found. And then you can go back into getting started. And then you can also see that the app is synced successfully. So this is what you should see after following the steps that I just did before. Then I'll just press next, and then the function to test should be process video. And then, right here, I'll say process video, and then we'll just find generation. And then since we haven't really created any users yet in the new database, we can actually just skip this part. So I'll just skip this and take me to the dashboard. And now we have our application and we have our function right here, and it is all connected to our live production environment. So what I'll now do is hop into our page right here, and then I'll, right there, then I'll just refresh. And then inside this Prisma Studio, I'll go ahead and close that down and then just open up a new one. That is not the one. Then I'll just open up a new Prisma Studio right here, just so we can see the actual contents of this new database which we created. Right now there are 0 users, so we'll just go ahead and create one. So I'll go to podcast clipper, and then I would like to enter andreas@gmail.com and then say password 123 and then sign up. And right now we are getting an error. So the way we can check the error is by going into our deployments and then hop under the newest production deployment. Then we can say runtime logs. And then here we can see the actual errors for our deployment. So right here we get an invalid Prisma user.findUnique, and it says error validating data source DB. The URL must start with protocol file. So it seems like we still have the SQLite setting set up, because when using SQLite you'll need to refer to a file. So going under schema Prisma, we should be able to see that we changed this to PostgreSQL, but we didn't really commit this to GitHub. So right now in the production environment, we still have SQLite. So we'll just say change to PostgreSQL and then commit that. This should then rebuild in production. So going back here under deployments, this should trigger a rebuild in just a second right here. And then I'll come back whenever this is done, and then we'll just test the deployment again. So the deployment just finished, and we can just go ahead and hop back in here and just refresh just to get the newest one, and then try and sign up again. So I'll say andreas@gmail.com, create a password, sign up. So this should then sign us up and take us to the dashboard, and we have 10 credits. If I go under Prisma Studio, we should then also be able to see the actual user now if we just refresh here. So we're able to see the user, and we're able to see the Stripe custom ID, meaning we also have a connection to Stripe now. So that is great too. Then I'll just try and first of all select the file, repos, backend, and then I'll upload this 5-minute one, and then say upload and generate clips. And then we'll just see what happens whenever we do that. So now it is queued. So let's just hop into Inngest, the dashboard, and then we can go under runs and just see if this works or not. So yeah, it is running currently in live production, and the credits step worked, the set status processed is working, and I think this is the step that is calling the Modal backend. So we can just hop into Modal, if we can find it here, and see if that is being called correctly as well. So right here we have pending, and then no logs yet, but it should be ready in just a second. So now it is running, so I'll just try and open it up, see if we can see any logs. So we do see the logs, so I'll just wait for this to finish, and then we can check out the results in just a second. And it is not this local dashboard actually, it is this one over here. So let's check out the results. So the result is, and by the way, you can see 2 more up here, and that is because I ran some tests after doing this, but I just want to show the results first. So we get these errors for both attempt 1 and attempt 2 for this step called call modal endpoint. So we see that we have function invocation timeout. So if we just search for that and then go into the cell, this happens whenever we have a request to a serverless function and then it reaches a timeout threshold. So there is a timeout threshold. So if I just search for Brazil serverless function timeout, we should be able to see the actual timeout. It is about 10 seconds per default for the hobby plan, and then all the way up to I think it's 60 seconds if you're on the hobby plan. So for example, if Modal takes 2 minutes to run, but you only have 1 minute before it times out, well then it is going to crash, and then it'll give you this error right here. So if we actually hop into Modal and then we check out the app, I'll just reload here, we can see that it takes about 30 seconds startup, and then it takes 1.5 minutes for the execution time. So we should estimate between 2 and 2.5 minutes for the actual execution time of this endpoint, which we call, and if we only have 60 seconds to go with, it is not going to work out very well for us. Luckily, I looked into this, so if you go to Inngest and then step.fetch, they have a perfect solution for this. So what they say right here is that the Inngest TypeScript SDK provides a step.fetch API, enabling you to make requests to third-party APIs or fetch data in a durable way by offloading them to the Inngest platform. So right here, this is actually the exact problem that I just had. So without step.fetch, that is what we did right here. We see that we send a request to Modal, that is what we do with fetch, and then the serverless function keeps running while we are waiting for the request, and then as soon as we get a response back, well then the next steps down here is going to be run. But if this wait for request period takes more than a minute, well then it is going to crash. And we know that it is a minute because if we go into Inngest right here, we can see that it times out after a minute, because a minute is the duration for both attempt 1 and also attempt 2. So with this new utility that I found up here, we can then send a request, and then we'll offload the actual waiting to Inngest's infrastructure. So this means that our server won't actually be waiting for this. Inngest server is going to be waiting for it, and then as soon as the request is finished, well then we can run the next steps back on our server again. So what we'll need to do is just use this fetch utility instead. So instead of having a step and then putting a fetch inside of this, you can go ahead and say something like step.fetch like this. So if you scroll down, we can say step.fetch, and then I think it's a wrapper around the original fetch, and this also means you can put in like whatever post method, whatever HTTP method you would like to use, the body, headers, etc. So what I'm going to do is call this step.fetch instead, and then I'll take all of the options from the original fetch, and then I'll remove this fetch, and then I'm just going to paste them in right here instead, like this, because both this step.fetch and also fetch right here is compatible with each other. So now if I do that, and then I say step.fetch, timeout error, and I'll just make sure that this is the only thing we changed. Good. So now that that is done, we can go ahead and just commit this and push it to production. And then we should see the redeployment being built inside our deployment right here. So when this is built, I'll come back to you. So now the deployment just finished, and we can then go ahead and hop over here to our deployment and just refresh. So I'll just wait for this to refresh. And then when this is done, and I just refreshed again, it was just some kind of error. So now that this is done, I'll just say select file, upload the same podcast file again, say open, then I'll say upload and generate clips. And then whenever this is uploaded, we should see this toast down here. So now we see the toast and that our video is queued. And then if we hop into Inngest, refresh over here, we should be able to see it now being ran, And then we can see that the first 2 steps successfully completed. And then we have a queued step down here. So this is not what we have seen before, but it is queued. So we'll just wait for this entire process to finish. And then we'll see what the output of this entire function was. Alright, so it just finished right here, and we can see that this step.fetch that was queued earlier took about 2.5 minutes, 2.4 minutes, and then the rest of the steps were executed after that, and the entire function actually completed. So hopping into Modal, we can also check out this in here. So we have 200, which means that it executed correctly, and it took about 2.5 minutes, like we knew it did. Good. So let's just hop into our dashboard right here, and then go under my clips. So now we are able to actually see our clips. So if I play a clip here,
was there much discipline in the boarding school then?
Yes. We can see that the clips work, and we can download the clip if we want to. So that is it for the actual processing. We are now able to actually select the file and have it being generated in the background in production. Now I just want to test that Stripe is actually working. So what I'll do is just clean up my pages up here first. And now that is done. So I'll then press buy more. And now we can see all of our credit packs. I'll start with this pack right here. And we'll just see whether it works or not. So right now, if I put in 42, and then I say pay, we can just see if we get any new credits or whether it works or whether it doesn't work. So we get 50 more credits, so it actually seems to be working just fine. Let me just add the other pack. And then put in a correct CVC. That works just fine as well. And lastly, we can check out the large pack. So I'll just put in the card information one more time. And that is working perfectly fine as well. And then if we just hop into the Stripe dashboard, it's pretty interesting to see in here as well. So under customers, we should have 2 customers for the 2 different profiles I created. Then under transactions, we should be able to see the transactions we just made. So we did a full test of all the products, both locally, but also in production, which we did right now. And we can then see all of the information about the transactions, along with a full overview here on the dashboard. And then remember, if you would like to deploy this in production, you shouldn't use a sandbox. You just need to follow the exact same steps that we did, just outside a sandbox. So in a real account in here, where you can just create an account basically. And then also, if you would like a custom domain instead of this domain right here for Vercel, you should probably also head into Vercel, and then you can go into domains, and then you'll be able to buy or connect custom domains and then add them to your deployments, such that it isn't just the default Vercel deployment, and this is only in case you want to deploy it in production. So this was it for this tutorial, at least code-wise. So now what I would like to do is just hop into Excalibur and then explain some of the exercises you can do to improve this and to learn a bit more about it. But this was it for the code part. So thank you for following along, and I really hope you enjoyed learning all of this super cool code with me today. Now, let's just go through the exercises that I think you can really learn something from. So first of all, you can play around with the viral moment identification prompt and then see if you can extract specific parts of the videos that you think are cool. So for example, right here in Identify Moments, you could change the prompt to not just extract stories or questions, but something completely different. Also, right now we also define constraints such as the video being 40 to 60 seconds long. So there are a bunch of different options for playing around with this transcript right here to make it exactly like you would like the program to work. Cool, so that is the first one. It is pretty easy and then therefore green because you only have to change text basically and then just test that it works. If you want to take it a step further, you can then also create multiple modes. So for example, in the front end, you can create a drop down that says question mode or story mode. And this should then look for those specific moments in the modal backend. So whenever you call the backend from the front end, you just send along the value, so the mode, as a parameter for the API, and you can then alter the prompt based on that specific value. And this way you can let the user switch between different modes whenever they change that drop down value. So if you want to then take this a step further as well, you can then input a YouTube link, and then that video is downloaded in the Modal endpoint instead of the user having to upload a video manually and then download it by the S3 key. So you can then use something like PyTube, which we used in the start of the video, or just a YTDLP, which you can install into the Docker container. So if you do this, then the FastAPI endpoint will just receive either an S3 key if the user decides to manually upload a video, or a link to a YouTube video, which would then just be downloaded instead of original the day before, and then everything should work as it currently is as well. So it is only going to be the video downloading process that probably has to change, and then also the uploading process as well. But it shouldn't be that hard to do, but it is still a little bit more challenging than creating these tasks up here. Cool. If you then want to take it a step further, you can let your users connect a YouTube channel and then automatically find that user's videos from the connected channel. This is a little bit harder because you will have to deal with a third-party integration. But it is super neat for the user because, for example, if they sign up for the first time, they might be able to log in with the YouTube channel on this SaaS that you're building. And then this SaaS will automatically display all of the YouTube videos and then let them clip those videos instead of having to find the videos links and then input them like we did with this task up here, or even worse, having to download the video just to upload it again for the SaaS. If you then want to make it really neat for the users, you can use a cron job, so a job that runs in the background every day, for example, to automatically schedule clips to a user's YouTube channel every day. It should automatically pull a video down, render the clips, and then post one of them every day. So in this case, the user would have to connect their YouTube channel, and then the backend would automatically download their videos for them, and then also post the videos every day. So this would be the ultimate kind of done for you SaaS for the user, meaning they only have to log in once, and then everything happens automatically without them having to even touch the SaaS after setting it up. You can then also take another approach where it's more manual, where the user can select the clips before actually creating them and posting them. So in this task right here, you can let the user generate previews of clips by rendering them in much lower resolution, so maybe only 100 or 200 pixels in height. And then these low resolutions, so right now we're doing 1920 by 1080, and this takes a long time to render because it is a lot of pixels. But if you use a lower resolution than that, it is much faster to render, and it's very much faster. So this allows the user to see a lot more clips and then pick the ones they like, because you can render many more clips before actually rendering the big one. And they should then be able to render this one that they select in 1920 by 1080. So in this case, you would have two different endpoints, for example. You would have an endpoint that just returns 10 different rendered clips in a low resolution, and then when they click download or render the full clip, then it'll generate a clip in 1920 by 1080, which then takes a few more minutes, but at least it is in the correct resolution now. So these are the tasks that I have for you. I think you would learn a lot by doing these. And then if you decide to build this as a SaaS and deploy it to production, I also think that some of these tasks down here are really useful for the user and can also help your product stand out in the market, because there is a lot of AI short form clipping tools. So you're going to need some kind of edge to be able to compete with the other tools, and these down here definitely give you some kind of edge. So again, thank you so much for following along with the video, and I'll see you in the next one.